Good morning, everyone. Raw Space here, and welcome to Spacewalk, US Spacewalk number 74, to install a new rollout solar array on the ISS. So this will be the first new solar array the ISS has received in many years, since the installation of its original solar arrays was completed, like in the last decade. I don't even... it was like 2007 or something like that when the last solar array was installed. The oldest solar array on the ISS is more than 20 years old. So yeah, what we have here, let me show you what they're going to look like. What we have here are called IROSAs. They are ISS rollout solar arrays. They arrive at the ISS rolled up into a big cylinder, basically, into a cylindrical shape, and they literally roll out in front of the existing solar arrays. So in this image, this image is not accurate. They show a different pattern than I believe that they show a different pattern than is the final plan for the solar array deployment. It's my understanding that the 4 right solar arrays will have IROSAs on them, and then 2 of the left 4 solar arrays will have IROSAs on them. Now, as depicted here, we see that it's symmetrical, left and right. They both have 3 of the new IROSAs, but I guess we'll have to wait and see if the understanding that I had as to where they're going to deploy these 6 out of 8 IROSAs was accurate or not. But the IROSA literally sits on top of the old solar array and covers it up partially. they extend about half the length of the old solar array, and not not fully the width. So maybe half the width of the old solar array. But they are new, better solar array technology, and they are more efficient by a factor of more than 30%. In fact, despite their smaller size, they're going to increase the power output of the ISS by about 30%. That's the goal. So they were delivered to the ISS a few weeks ago. The first two, I should say, the first two IROSAs were delivered to the ISS a few weeks ago on a SpaceX cargo dragon rolled up in the trunk, which is the unpressurized storage area underneath the cargo capsule that has the solar panels on the outside of the trunk. So they were delivered in the trunk, and the arrays have already been pre-positioned so they had to use Canadarm2, the space station robotic arm that was you may have seen in the news recently as having been impacted by some piece of orbital debris, but it was not damaged. I mean, it had a hole in the protective covering, but its functionality wasn't affected at all. But in any case, they used Canadarm2 to extract the solar arrays from the trunk of the cargo dragon. It then mounted the arrays. Excuse me. It then mounted the arrays to there's basically a cart that rolls down the length of the truss structure of the ISS. So if the habitation modules are oriented this way, the truss structure is oriented perpendicular to it, which if we open up this image again, you see here the truss structure is going left to right there. So there's a work cart that basically rolls down the length of the truss structure and is able to deliver work materials or hardware to a work site anywhere along that truss, farther than the Canadarm is able to reach. And in fact, Canadarm can't reach out this far. So this is actually how big the IROSAs are. They're pretty big, and it's easy to, when you're looking at something like this, it's easy to lose perspective of just how big the stuff we're sending up there is. But I don't have the exact dimensions handy for you, but you can see there roughly. Unless those are very, very small people, the IROSA is pretty big. So unlike the original solar arrays, it is rolled up like a Swiss roll, which sounds good about right now, rather than being folded up like origami or like a folded napkin. And let's see. So today, if you remember that image of the ISS from the top view, today they will be installing the IROSA over the 2B, or on the 2B power channel, which is when you see references to the space station's truss structure, P stands for port, which is the nautical term for left. S stands for starboard, which is the nautical term for right. And you see the other directions there. We got forward, aft, zenith, and nadir. Zenith and nadir aren't applicable here because the truss structure does not have a Z dimension. It only goes out left and right, and then has the arrays attached to it. So the front left array, if you're looking in the direction that the ISS is orbiting, is what's going to be enhanced with the IROSA today. So during a previous spacewalk or spacewalks, they already mounted, or rather they already prepared the site by installing the mounting adapter to the base of the solar array. So all they have to do today, it's a lot of work, but all they have to do today is attach the IROSA to the mounting adapter, and it will then roll out over a period of minutes and start provide, and then they'll turn it on. It'll start providing power. The spacewalkers today are Tomas Pesquet from France and Shane Kimbrough from the USA. Both veteran astronauts, and in fact, this won't be their first spacewalk together. Hello, Beno. Hey, Beno. Hey, buddy. You don't want to visit? Okay, bye. In fact, this won't be their first spacewalk together. Back in 2017, they did another spacewalk together. And I don't have that queued up, so I don't remember what it is that they worked on. But they have a history of working well together, and they were paired up specifically to work on this. They will also be doing another spacewalk on Sunday to install the 4B array. If you see the graphic, the 4B is the power channel directly opposite 2B. So, yeah. And that's what they'll be working on Sunday. Now, the spacewalk, as pretty much all spacewalks, the spacewalk is expected to last for about 6.5 hours. But it could go over if they experience any delays. There's always wiggle room. Their suits have enough oxygen for upwards of 9 hours if need be. So they'll be good to go regardless. Let's see, any questions here? Yes. Rolled up like a tissue paper roll. 6 meters by 13.7 meters are the dimensions of the, you know what, I should keep these pictures queued up. 6 meters by 13.7 meters. Let's see if we can do a quick conversion. 6 meters, 2 feet. Feety, oh my gosh. $19.7 feet by, so that's the width. Hey, Benno. By 13.7 meters, 2 feet. Oh, it knew what I said when I said feety. That's funny. 40, okay, so it's about 50 feet long. So they're quite large. Obviously, Cargo Dragon is not 20 feet wide, so it was folded in half when it was delivered. Let's see. Diameter is only 12 feet. So all right, more questions. Will it be unrolled today or just mounted? I'm actually a little unclear on that. I listened in on the preview briefing, the Spacewalk preview briefing, but I don't know if they mentioned a specific timeline for the unrolling. It certainly won't be unrolled while the astronauts are out there. Well, I could be wrong, but I'm probably not. You know, typically the way NASA does these things is, because there's nothing the astronauts can do if there's, in fact, they did specifically mention, there was a question asked during the briefing, what happens if something goes wrong with the deployment? Do they have a contingency plan? And they actually don't have a contingency plan if the unrolling of the array fails or experiences a problem. But, in true NASA fashion, if something does happen, they will kick into troubleshooting mode and, assess the situation and come up with some sort of solution, which would probably involve another spacewalk. But they wouldn't unroll the array while the astronauts are out there because that poses a safety hazard. They wouldn't want the astronauts to be potentially, affected by the array rolling out, and they also wouldn't want the array to be potentially damaged by the astronauts moving around. So, 95% sure they're going to mount the array, but unroll it later once the astronauts are inside and safe. They don't typically do two things at once. Do the installation, finish the spacewalk, and then at a later time, once everybody has doffed their spacesuits and whatever, then unroll the array. Varshith Rayavarapu is asking, when does the coverage start? The NASA coverage, which will be right here on this stream, starts in 13 minutes. So I could put a timer up. Let me do that for you. So I wasn't sure how much time I would need or whether there would be more questions during the intro. So I started 30 minutes early, just in case, which is killing me because I got like almost no sleep. So I'm taking the hits for you here. Let's see. 06:30, 16:06. And there you go. There's a timer. Herman Ramos Berrocal asks, do I think the solar array will increase the brightness of the ISS as seen from Earth? I like that question. Actually, I suspect, well, so the solar panels are black, obviously. Black absorbs the most light. The solar panels have less shiny parts. The new IROSAs have less shiny parts than the old solar panels, which had sort of a shiny frame around it. But the solar panels are also glossy, as you can see in this picture, sort of mirror-like. So I am not sure. I mean, the goal is to absorb all of the sunlight possible. So, considering these are more efficient arrays, I would say maybe it won't affect the brightness. Maybe it'll actually reduce the brightness a tad bit, but not hugely so. Bog Shed asks, how long will the installation take approximately? The spacewalk is scheduled for 6.5 hours, as with pretty much all spacewalks. Again, it may take a little bit longer or a little bit less if if they experience delays or if they whiz through things. But they don't have they have a lot of work to do, but they don't have a lot of different things to work on. There's one task or rather one objective this spacewalk, and that is to install the IROSA on its mounting adapter. Varshith is asking, why are they adding a new solar panel? So this is the first of 6, remember. So there are 6 IROSAs that will eventually, 2 have been delivered to the ISS. The first of those 2 will be installed today. The second of those 2 will be installed Sunday. And the remaining 4 will be delivered by Cargo Dragon at a later date, at 2 later dates to be determined. But the question is, why are they adding a new panel? Because not only... So remember, the ISS was designed more than 20 years ago, and in fact it's more than 20 years old, most of it. And, you know, in the past 20 years, everything we know, all the devices we're accustomed to using, they consume more and more power. I mean, there's more devices, there's more, like the ISS is full of experiments, many of which require power. Additionally, there are new modules on the ISS which require more power. Plus, the old solar arrays, they do degrade over time. Hey, Benu, you want to come and visit? He's playing hard to get. He doesn't like to be picked up. Yes, he's rubbing my hand, but he won't let me pick him up. Come here. Come here, you. Nope. Okay. Benny's my cat. Named after the asteroid, of course. I lost my train of thought. I do that too much. So, yes. The solar panels do degrade over time. You know, they get, I mean, the hardware, you know, wears out, materials degrade, and, you know, the original solar arrays experience micrometeoroid hits, and you know, over time they generate less power than they did when they were brand new, and that's typical of all solar arrays. They don't last forever. They were rated. The original solar arrays were rated for a lifespan of 15 years. Well, it's been 20 years so far, and so they're past their warranty period, as it were. So additional power needs for the future, as well as the old arrays are not producing quite as much as they used to. John Sloan, does the ISS need more battery storage as the power is increasing by 30%? They actually have received more battery storage. So the main, like, there have been a lot of spacewalks in the past couple. I mean, they're always doing spacewalks. This is the 240th or something spacewalk overall you know, for ISS installation and maintenance. So, and that includes the U.S. and Russian spacewalks. So, they're always doing spacewalks for one thing or another. But in the past couple of years, the main focus has been in the power systems. So there were a long series of spacewalks to install new lithium-ion battery packs all along the ISS truss structure to replace the old nickel-hydrogen batteries that were from the original... Hey, there's Benu behind me. From the original design. And the lithium-ion batteries, they have greater capacity, they're smaller, more efficient, and they have a long shelf life. He's got the zoomies. So they have already received their new batteries, and now they're attaching the solar panels to charge them up. Drake Williams, they want to install a supercharger for that Tesla Roadster. I mean, I suppose if Starman visited the ISS... Now, I do actually have a command for that. It's intended for the Starman stream, which I have not a live stream, but a 24/7 stream of music that features Starman and Elon Musk's Tesla Roadster floating through space. But yes, there's a 1.13 in 10 billion chance. That's 1.13 times 10 to the negative 10th percent that the Tesla might hit the ISS in the next 1 million years, assuming the ISS is still orbiting then, which it won't be. But if the Roadster did come to visit, this new power array, or this new solar array, might just provide enough juice to charge it up. SJ asks, what is the size of these panels? What was it? 6 by 13 point something, 6 meters by 13.7 meters. That's about 20 feet by 50 feet in size. That's the size of the IROSAs. J-Charist, so you're saying there's a chance. That's right. There's always a chance. Just like your chances of being, killed by a duck are small, but never zero. Very dedicated duck with a knife. Bogshed asks, what happens to the old panels? The old panels will remain, and they'll continue generating power. The IROSAs will augment the power provided by the old panels. So a portion of the old panels will be covered up by the IROSAs, but most of the old panels will still be exposed to the sunlight, and they will continue generating power. Erna is asking, by the way, hello and welcome back. Is this the first time for Shane Kimbrough and Tomas Pesquet for their spacewalk today? Nope. Tomas Pesquet and Shane actually have done at least one spacewalk before. I don't have the statistics in front of me, but they probably have done a couple spacewalks before. But they actually did one together in 2017 on their previous flight to the ISS. They did a spacewalk together at that time. So we've got Milan Luchuman asking for a picture of the ISS. So here's a diagram of the ISS. And again, it's not entirely clear whether the IROSA deployment pattern that you see here is what they're going to do, or whether they're going to load all four of the initial IROSAs on the right side, and then just two on the left. I've seen both diagrams, so we'll see what the final pattern is. So we've got live coverage starting here very soon. So thank you for joining me, and I'm going to go ahead and queue up the NASA coverage. So enjoy the spacewalk, and I'll catch you on the flip side.
You're watching NASA TV.
Good day from Mission Control in Houston, and welcome to the International Space Station Flight Control Room here at the Johnson Space Center in Houston, and our coverage of U.S. Spacewalk number 74, to be conducted by Shane Kimbrough and Tomas Pesquet, a spacewalk that will begin the process of augmenting the power capability of the International Outpost. At this hour, aboard the International Space Station in the Quest airlock, you see with his back to the camera Russian cosmonaut Oleg Novitsky, and on the left NASA astronaut Megan McArthur, as they have worked throughout the course of the overnight hours to help prepare Tomas Pesquet of the European Space Agency, who's on the right side of your screen, and hidden from view at the moment, Shane Kimbrough on the left side of your screen, helping them to suit up in their U.S. extravehicular mobility units. They are in the equipment lock section of the two-compartment Quest airlock, ready to begin what is expected to be a 6.5 to 7 hour spacewalk to install new solar arrays called IROSAs. You'll hear that term referred to throughout the course of our coverage today. IROSA, the acronym for ISS Rollout Solar Arrays. These new arrays are designed not to replace the legacy or older solar array wings on the station, but rather augment their power capability for the rest of the lifetime of the International Space Station. Today's spacewalk will be the 239th spacewalk in support of ISS assembly, maintenance, and upgrades, the 7th spacewalk to be conducted out of the International Space Station this year, the 7th spacewalk in the career of Shane Kimbrough, who has accrued a total of 39 hours even on 6 previous spacewalks. He will be wearing a helmet camera bearing the number 22 during the course of today's spacewalk, helmet camera number 22, and this will be the 3rd spacewalk in the career of Tomas Pesquet, a former Air France pilot who is with the European Space Agency making his 2nd flight into space. His 2 previous spacewalks accrued a total of 12 hours and 32 minutes of spacewalking time. He'll be wearing a helmet camera bearing the number 20 during today's spacewalk. The 2 crew members will also be wearing HD helmet cameras, as well as the standard helmet cameras that you have become familiar with over the course of spacewalking coverage. That will provide more detailed looks from the crew members' perspective as they conduct all of their activities in support of today's spacewalk. The Orbit 1 team of flight controllers is on console at this hour as you look at an overhead view looking at Shane Kimbrough, who is again on the left side of the Quest airlock's equipment lock section, just over the shoulder of Tomas Pesquet, who's on the right side of your screen, lower right-hand side of your screen. They suited up with the assistance of Mark Vande Hei, NASA astronaut, and Megan McArthur earlier in the morning. Megan McArthur will be operating the Canadarm2, the space station's robotic arm, to transport Tomas Pesquet, who will haul these new the first set of IROSA solar arrays toward the work site on the far left side of the truss of the International Space Station. Today's work site will be managed by Flight Director Ron Spencer, and you'll be hearing the voice of Canadian Space Agency astronaut Jenny Sidey, who will be the so-called ground IV Capcom, or essentially the spacewalk choreographer, who will be discussing all of the procedures step by step with Pesquet and Kimbrough while they conduct their work outside of the Quest airlock. The crew inside the Quest's equipment lock has been breathing pure oxygen and conducting light exercise to increase their metabolic rate and increase the dispersion of nitrogen out of their bloodstreams to prevent any condition known as the bends or decompression sickness from occurring when they step out into the vacuum of space. Today's spacewalk is scheduled to begin about an hour and a half from now at 7 a.m. Central Time, 8 a.m. Eastern Time. A U.S.-based spacewalk out of the Quest airlock is measured at the beginning from the time that the crew switches their suits to internal battery power until the time of repressurization when they're back inside the airlock at the completion of an EVA. The first pair of these new ISS rollout solar arrays were delivered to the International Space Station just a week and a half ago with the arrival of the SpaceX Cargo Dragon vehicle that launched on a Falcon 9 rocket from the Kennedy Space Center in Florida. These rollout solar arrays, again, do not replace the current sets of solar arrays, but rather augment the power capability of the solar arrays. The IROSAs basically are an innovative new solar array design that uses high-strain one-piece carbon fiber composite booms. The stored energy of the booms as they're rolled up provides the actuation for their deployment once a series of bolts are released by the two spacewalkers during the course of the spacewalk. Once deployed, the booms will provide the array's structural stiffness and strength once they're tensioned, and will roll out to a length of about 60 feet. To augment, they'll be sitting adjacent to the current arrays on the P6 truss, the far port truss of the International Space Station. The two crew members will be working out at the P6 truss. This was the first truss segment and the first set of solar arrays that were delivered to the International Space Station aboard the Space Shuttle Endeavour in December of 2000 on the STS-97 mission that was commanded by former astronaut Brent Jett. In the forthcoming months, two additional pairs of IROSA solar arrays will be delivered. The next pair will be installed on the P4 and S4 starboard 4 truss of the station, and the final pair will be deployed on the S or starboard 6 truss and the starboard 4 truss. 6 of the 8 power channels for the International Space Station will have their power augmented by these new solar arrays. The current solar array wings, the huge wings that you see, there are 8 of them on the station, 2 for each of the photovoltaic power channels on the station. Each of the old legacy solar arrays have 32,800 solar cells total, assembled into 164 solar panels, the largest arrays ever designed and deployed in space to convert solar energy into electrical power. The normal electrical power output for each solar array wing at the beginning of its lifetime was 31 kilowatts for a total of some 248 kilowatts of total power. These new solar arrays, the IROSAs, that will be installed for 6 of the 8 power channels, are designed to provide an additional 20 kilowatts of electricity, eventually totaling some 120 kilowatts in all of augmented power during orbital daytime. In addition, the remaining uncovered solar array pair and partially uncovered original arrays will continue to generate some 95 kilowatts of power for a total of some 215 kilowatts of power for the rest of the lifetime of the International Space Station. This will accommodate more modules to be launched to the International Outpost and to provide the augmented power to the 6 power channels that have, through normal wear and tear over more than 2 decades of use, have seen some degradation in power output. This will bring the International Space Station back to an even more robust power capability than the original arrays were designed to provide. Kimbrough and Pesquet, interestingly enough, conducted a pair of spacewalks together several years ago during Expedition 50, the first on January 13th, 2017, where they worked on the most recently completed set of battery replacements, where nickel-hydrogen batteries were replaced by lithium-ion batteries on the International Space Station. They also worked a couple of months later during Expedition 50, going outside together on March 24th, 2017, to lubricate the latching end effector there at the end of the Canadarm2 and to prepare the Zenith port on the Harmony module of the International Space Station for the installation later on of the second of the two international docking adapters that are now used for commercial crew vehicles arriving at the International Space Station. So they are familiar with each other. They have their choreography pat, and they're ready to go outside once again to begin their third spacewalk together, the 239th in the history of space station assembly, maintenance, and upgrades. The clock's up on the wall here in Mission Control, counting backward for a go for the depressurization of the Quest airlock. Before long, you see in this view Mark Vande Hei, NASA astronaut, on the right side of your screen. Megan McArthur's on the left. You'll see them attach jet-powered backpacks to the two spacewalkers' extravehicular mobility units. They're called SAFERs. That's the acronym for Simplified Aid for EVA Rescue. Those are the jet-powered backpacks that would be used in the highly unlikely event either of the crew members would become detached from the tethers that hold them in place as they go about their work on the outside of the Quest airlock. They then, one by one, will be moved into the outermost compartment of the two-compartment Quest airlock called the crew lock that you see Vande Hei at the threshold of. That then will be followed by the closing of that hatch. The two spacewalkers will hook themselves up to umbilicals inside the crew lock and await the green light while the depressurization of the crew lock section brings it down to vacuum as the precursor to their placing their suits on battery power to mark the official start of today's spacewalk. Today's spacewalk is the first of two in the next 4 days by Pesquet and Kimbrough. They'll go outside once again on Sunday, on Father's Day, to install the second of the two IROSA solar arrays that arrived on the SpaceX Cargo Dragon vehicle about a week and a half ago. This first of the two IROSA arrays will be installed to service the so-called 2B channel of the P6 truss of the International Space Station. The work that they will conduct on Sunday will be the installation of the 4B power channel arrays. And you can see in this graphic how the ISS rollout solar array, these new arrays look like when they're deployed adjacent to the legacy arrays, which are about twice as long as the new arrays. And again, these are not designed to replace the older arrays, but rather to augment the power generation for the International Space Station. Today's work will concentrate on the array to be installed on the 2B channel for the International Space Station. It's intricate work that involves a lot of loosening of bolts and a lot of work with power tools, high-tech space power tools that the crew will have at their disposal. We have about a 7-minute animation narrated by the lead spacewalk officer for today's EVA, Keith Johnson, in which he describes in detail what Pesquet and Kimbrough will be doing once they move outside of the Quest airlock.
At the start of the EVA, EV1, Tomas Pesquet, comes out first, followed by
So space, night, death, darkness, not being there is an essential component of being there. You don't have the one without the other. That's the way being is made up.
That if all goes as planned, we should get some indication that the newly deployed ISS rollout solar array is generating the proper amount of power either before or during the time frame that the crew is re-entering the Quest airlock near the end of today's spacewalk. Once again, as you saw in the animation, IROSA, you'll be hearing that acronym frequently throughout the course of our coverage today. IROSA standing for ISS Rollout Solar Array. It will be positioned in front of the legacy solar arrays, or the older solar arrays, on the P6 truss of the station. It attaches to the existing beta gimbal assembly that permits it the use of existing sun tracking, power distribution, and the power distribution to the proper channel. In this case, the first array to be installed and deployed today will service the so-called 2B power channel, the first of 6 power channels to be augmented during the course of these IROSA installation and deployment activities. These arrays will shadow approximately 2/3 of the legacy arrays. They're connected to the same power system to augment the existing supply. The 2 arrays to be deployed, the first today and the second on Sunday, will be electrically combined and both provide power to the ISS, resulting in the increased power performance compared to the original legacy ISS solar array. And as we mentioned earlier, each of these new arrays will produce more than 20 kilowatts of power, and when all 6 are finally deployed and activated, they will total about 120 kilowatts of augmented power for the International Space Station. In the equipment lock section of the Quest airlock, Mark Vandehei on the right side of your screen and Megan MacArthur on the left are making final checks to the suits of Shane Kimbrough that you see in the middle of your view. You're looking over the shoulder of Tomas Pesquet. Pesquet, who will be wearing the suit bearing the red stripes today, is extravehicular crew member number 1, or EV1. And again, he'll be wearing the helmet camera bearing the number 20 in the lower right-hand side of your screen once they are turned on following the crew's exit from the crew lock section of the Quest airlock. Shane Kimbrough is designated today as EV2. He is wearing the unmarked suit and will have a helmet camera bearing the number 22 during the course of today's spacewalk. And as mentioned earlier, both spacewalkers will also be equipped with high-definition helmet cameras to provide even better views of some of the intricate work that they're going to be conducting to loosen up bolts and the installation of these new solar arrays on what are called mod kits, or modification kits, that were installed on previous spacewalks. The crew began their suit-up activities about 1 a.m. Central Time this morning. They again were assisted in being suited up by Mark Vande Hei, NASA astronaut that you see on the right side of your screen in the blue shirt. They then began to pre-breathe pure oxygen to cleanse their systems of nitrogen in the customary procedure that prevents any possibility of decompression sickness from setting in once they move out into the vacuum of space. A good view down the length of the equipment lock section of the Quest airlock, as you see Megan MacArthur checking out suit systems along with Vande Hei. She will be operating the Canadarm2 robotic arm from the workstation in the Destiny laboratory during the course of today's spacewalk. The money shot for today is likely to be the movement of Tomas Pesquet in a foot restraint at the end of the Canadarm2, like a telephone repairman at the end of a cherry picker, who will be hauling this first IROSA solar array to the work site.
Purge in step 20. The Bedox canisters are temp stowed node 1 deck 3, serial numbers 1033 and 1034.
We copy. You're go to proceed, and those are good numbers.
And we have resumed the pre-breathe clock.
Again, MacArthur will be the robotic arm operator during the course of today's spacewalk as she moves Tomas Pesquet to the worksite. But Pesquet will be carrying that IROSA solar array, which on Earth weighs 750 pounds. Of course, in weightlessness, it doesn't weigh anything other than the mass that he'll be hauling to a handoff to Shane Kimbrough, who will then hand it back to Pesquet, and the two spacewalkers will work in tandem to position that array for its installation on the modification kit, which is at the mast canister at the base of the P6 solar array. We're about 37 minutes away from beginning the depressurization of the crew lock section of the Quest airlock. Over the course of the next half hour, the simplified aid for EVA rescue backpacks will be affixed to the back of the spacesuits for Pesquet and Kimbrough, and they'll be moved into the Quest airlock. The hatch will then be closed, and they'll be isolated from the rest of the crew members on the International Outpost for the remainder of the day. At this hour, the International Space Station is flying 258 statute miles over the Ukraine, south of Kiev, moving from northwest to southeast in an orbit inclined 51.6 degrees to either side of the equator. Some of the timing of today's spacewalk is measured to be conducted during orbital nighttime, particularly the actual hookup of power connectors for the new solar arrays, so they're not hot, quote unquote, at the time that they're acquiring electrical power from the sun during an orbital daylight pass. So there will be times in which the crew, if they're running slightly ahead in the timeline, will be asked to simply stop so that the timing of certain tasks to be conducted deliberately during an orbital nighttime times out correctly to meet the particular technical requirements for the installation and deployment of the ISS rollout solar arrays. Inside the equipment lock section of the Quest airlock, Megan MacArthur and Mark Vandehei are beginning work to affix the first of the simplified aid for EVA rescue or safer backpacks to Tomas Pesquet's spacesuit. Shane Kimbrough will be next up to have his safer unit installed. Again, those jet-powered backpacks are designed to provide the capability, if necessary, in the unlikely possibility that a crew member would become detached or untethered during the course of the spacewalk, they could propel themselves back to the structure of the International Space Station and into safety. This is Mission Control Houston. In the field of view, in the foreground is Space Station Commander Aki Hoshide from the Japan Aerospace Exploration Agency, as Megan MacArthur and Mark Vandehei are finalizing the attachment of the jet-powered backpack called the Safer to Tomas Pesquet's spacesuit. Again, you see the red stripes on his legs. That's indicative of his designation as extravehicular crew member number 1, or EV1. He'll be first out of the crew lock section of the Quest airlock once the hatch is open and the suits are placed on internal battery power to begin the official start of today's excursion by him and Shane Kimbrough, the NASA flight engineer, who will spend 6.5 to 7 hours out in the void of space today, attaching the first of a half-dozen ISS rollout solar arrays to augment the power capability of the International Space Station. Tomas Pesquet is now inside the crew lock section of the Quest airlock. Shane Kimbrough now will be assisted in the donning of his Safer jet-powered backpack before being moved across the threshold into the crew lock section to join Pesquet. In the equipment lock section of the Quest airlock, a wealth of spacewalking experience abounds. Mark Vandehei with 4 spacewalks to his credit in his career. Aki Hoshide, with his back to the camera, has conducted 3 spacewalks before. Megan MacArthur's previous flight into space, of course, was part of the crew for the final servicing mission of the Hubble Space Telescope. She operated the shuttle's robotic arm to capture and later deploy the Hubble. She will be operating the Canadarm2, the space station's robotic arm, today to transport Tomas Pesquet around with the ISS rollout solar array to the work site at the far port section of the International Space Station, where he and Shane Kimbrough will work in tandem to install that solar array to a so-called mod kit that was hooked up on a previous spacewalk, and then, of course, to loosen bolts and other mechanisms to permit the deployment of that array. This is Mission Control Houston. You are looking live inside the equipment lock section of the Quest airlock of the International Space Station. You're looking at NASA flight engineer Shane Kimbrough and his extravehicular mobility unit. His crewmate, Megan MacArthur and Mark Vandehei, are across the threshold that separates the equipment lock from the crew lock section of Quest. Tomas Pesquet of the European Space Agency is already inside the crew lock. Shane Kimbrough soon to be moved inside to join his spacewalking colleague for today, as we are about 15 minutes away from the start of the depressurization of the crew lock section of Quest. That will be the precursor for the start of today's spacewalk by Pesquet and Kimbrough to install the first of a half-dozen new solar arrays to augment the power system of the International Space Station. Today's work to be conducted on the far left or port truss of the station at the P6 truss, the first truss element of the station to carry a solar array that was launched aboard the Space Shuttle Endeavour in December 2000 on the STS-97 mission. This is Mission Control Houston. Both Tomas Pesquet and Shane Kimbrough now inside the crew lock section of the Quest airlock. Aki Hoshide in the foreground, assisted by Mark Vandehei, now beginning to close the hatch. That will isolate the two spacewalkers for today. We're about 7 minutes away for a go for the depressurization of the crew lock section that will be done in a two-step fashion. While we have a moment, let's replay for you the 7-minute animation narrated by the lead spacewalk officer, Keith Johnson, who will outline all of the tasks that face Pesquet and Kimbrough in today's spacewalk.
At the start of the EVA, EV1, Tomas Pesquet, comes out first, followed by EV2, Shane Kimbrough. Tomas translates up to the front face of the truss and translates outboard. Tomas.
both of you monitor your seat pressure gauge is less than 5.5. And if it ever gets above 5.5, stop the depress.
Copy, EV1. Depress pump man ISO is open.
Copy, open. And let us know when the crew lock at 6.0. Expect an alert tone. You don't have to let us know, but expect an alert tone. Do let us know when you get to 5.0.
This is Mission Control Houston here in the Space Station Flight Control Room. Ron Spencer standing up. He is the flight director for today's spacewalk by Pesquet and Kimbrough. He is joined on console to his right by Canadian Space Agency astronaut Jenny Sidey, who is the ground IV, basically the spacewalk communicator, who will be running through all the procedures step by step with Pesquet and Kimbrough once they move outside of the Quest airlock. And to her right is veteran astronaut Drew Feustel. He has a very impressive spacewalking record in his career, 9 spacewalks for a total of 61 hours and 48 minutes of spacewalking time. He will basically run the procedures through the point at which the crew will place their suits on internal battery power to begin the official start of today's spacewalk, and then he'll hand over the communications chores to Jenny Sidey for the remainder of the spacewalk. Feustel will be available to talk to the other crew members inside the International Space Station during the course of today's activities. The depressurization of the crew lock section of Quest is underway. This will be conducted in a 2-step fashion. First, to bring the crew lock section down to 5 pounds per square inch of pressure. There will be leak checks, communications checks with the crew before the depressurization continues to bring the crew lock down to vacuum.
P4.8. Regulating.
To recap, this will be the 239th spacewalk in International Space Station history in support of assembly maintenance and upgrades. The 7th spacewalk for Shane Kimbrough, who will be wearing a helmet camera with the number 22 in the lower right-hand corner of your screen once it is turned on following the crew's exit from the crew lock section of Quest. This will be the 3rd spacewalk in Tomas Pesquet's career. He will be wearing helmet camera number 20, and both crew members outside will be also equipped with high-definition helmet cameras for even better enhanced views of the work that they'll be doing outside. Pesquet, as extravehicular crew member number 1, will wear the suit bearing the red stripes. Shane Kimbrough's suit as extravehicular crew member number 2 is unmarked.
10 PSI. PSI. It's under 5 on my suit. Yeah, same here. PSI on the DCM. Follow speed. Again, you guys are all over it, but when the crew lock is at 6.0, expect an alert tone. Copy. Copy.
Mark Vande Hei in the equipment lock section of Quest, monitoring the depressurization of the crew lock section, the outermost section of the two-compartment Quest airlock. It will be taken down to about 6 pounds of pressure per square inch, almost 5, before we pause to conduct leak checks on the crew members' suits, final communications checks before the green light is given for Pesquet and Kimbrough to open up the hatch on the crew lock section. The outer thermal cover will be opened as well, and the crew members then will be given the green light to place their suits on internal battery power, which will mark the official start of today's spacewalk.
One, approaching 6.0. Copy.
Once the two spacewalkers have placed their suits on internal battery power, Pesquet will be first out of the Quest airlock. He will be joined just a few moments after that by Kimbrough, and the two will begin to check out all of their equipment, make sure their tools and tethers are properly configured before they make their way over to the work site on the far left side of the truss of the International Space Station at the P6 truss of the complex.
iPhone 1. Yep. Five. Yep.
Copy 5.0, Shane, deep press pump manual isolation valve to close.
Close.
And expect an alert tone.
Alert for now.
Shane, did you get the depress pump manual isolation valve to close?
Yep, it's closed.
And I didn't copy.
Yes, closed.
Closed. Okay, for both of you, on your GCM, switch the display to status until leak check question mark is displayed, and then display to yes, hold for 2 seconds, and follow the displayed instructions.
Copy. Copy. Leak check question mark. Check complete. And for here, both suits for EVA. Okay. And white mark.
Copy, both of your leak checks are complete, and you're in the process of moving your O2 actuators to EVA.
EVA for EV1. Looks like I'm in EVA, but it's not showing it. My DCM. Good lock.
For Shane, depress pump manual isolation valve to open and expect an alert tone.
Yeah, it's open.
Copy, open. The emergency MPEV is now open. Monitor your suit pressure gauge stays less than 5.5.
Copy. Copy.
Mark Vande Hei continuing to monitor the procedures as we have now resumed the depressurization of the crew lock down to vacuum, which will be the precursor to the crew opening the outer hatch to the crew lock and placing their suits on internal battery power to begin today's spacewalk. Once the hatch is open and the spacewalk begins, Megan MacArthur will make her way to the robotics workstation inside the International Space Station. She'll be at the controls of the Canadarm2 robotic arm to drive Tomas Pesquet from one area to the work site on the P6 truss, the far left side of the truss backbone of the International Space Station. He will be carrying that first IROSA array, the ISS Rollout Solar Array, once it is removed from a flight support structure to which it is attached. The second of these two solar arrays, the first pair of solar arrays, will be the subject of Sunday's spacewalk, again by Pesquet and Kimbrough, as they work to hook that one up to the 4B channel of the P6 truss. The today's array work will service the 2B channel of the P6 truss. These are the first pair of 6 such IROSA solar arrays that will augment power for 6 of the 8 power channels on the International Space Station.
Copy 2.0, Shane, depress pump manual isolation valve to close.
Yeah, manual ISO valve is closed.
Shane, on the UIA, switch the depress pump power to off.
Depress pump power off.
Report the initial configuration for egress of your tethers.
Okay, I can do that. Let's see, on Shane's configuration on his right gearing extender, his safety tether, close and lock goes to the waist tether, close and lock goes to the airlock. Waist tether, close and lock on both sides. On his left gearing extender, he's got his red hook, closed and locked, goes to the red reel, which is unlocked. Yellow hook, closed and locked to his green reel, unlocked. His green reel goes to, his green hook goes to his red reel. Anchor hook.
European Space Agency astronaut Tomas Pesquet across that hatchway that you see Mark Van de Heye on this side of the hatch, as Pesquet and Kimbrough report the configuration of their tethers prior to the point at which the crew lock section of Quest reaches vacuum, which should be just a few moments from now.
He's on my red reel. Green reel, yeah, it's closed but not locked. And my anchor hook is on my main workstation.
All right, Tomas, could you confirm that your right and left waist, actually you have a hard time checking your short waist tether. Check that your waist tether on the same side as your safety tether pack. The waist tether small hook is closed and locked on the gearing extender.
That is correct, Mark. The left side where my safety tether pack is, and my waist tether closed and locked. And on the other side, on my gearing, closed and locked.
Would you confirm that the airlock waist tether, the one that's directly attached to the airlock gearing extender, has both of its hooks, the large and small hooks, closed and locked?
That is correct. Small hook closed and locked, and large hook closed and locked on Shane's large hook, closed and locked.
Hey, Houston, do you have anything you want to double check with them?
That is a good tether config. Thank you all.
All right, thanks. Good work, gentlemen. On both of your DCMs, when the crew lock DPDT is about 0, expect an alert tone. And then Tomas, when the EV hatch delta pressure is less than 0.5 psi, you are go to open and stow the EV hatch.
Mark. Do I check the MPEV open? Is that correct?
The emergency MPEV is open right now.
It is open, okay.
There's nothing on there about opening the EV hatches.
Okay.
MPEV.
Okay, drops really slowly.
Not open it, keep it closed. Let me say that one more time. When you get to less than 0.5 psi on the hatch, you'll open and stow the hatch, but keep the MPEV on that hatch closed.
Copy. When I get to less than 0.5 psid in the hatch, I open the hatch and MPEV closed.
Now, Airlock, Houston, we have about 8 to 10 minutes until we're at a time where the delta P is going to be less than 0.5. So we'll be following along with you, and I'll give you direction on that hatch when we're ready.
Okay, Jenny. Thanks.
Good morning, Jenny.
And hey, while we are waiting on this, big thank you to Mark and Megan and Aki for, I think, doing a fantastic job in getting us ready to go out the door. That was really nicely executed. And I'll extend this to all the prep shift. I don't know if those guys are still on console. If they are, congrats on the job well done. If they're not, please pass the word.
Hey, Tomas, thanks. It was certainly an honor for all of us to be able to participate in this event you're working on today to help improve the space station. We are all looking forward to continued success as you do your hard work today.
Mark.
With those words, Mark Van de Hei will turn the communications duties over to Jenny Seide, the Canadian Space Agency astronaut here in Mission Control, who is the ground IV or intravehicular crew member, essentially the spacewalk communicator for today's excursion outside by Pesquet and NASA astronaut Shane Kimbrough.
Tomas, just to put on the belt and suspenders to make sure we got everything possibly covered. What is the current status of the MPEV on the EV hatch?
It is closed, Mark, closed.
Okay, thanks.
Thanks for checking.
Ground copies, that's a good config.
We're in a brief handover between satellites on the tracking and data relay satellite system. We will regain our downlink television capability and communications with the crew momentarily. Everything has proceeded by the book throughout the overnight hours, setting the stage for the start of today's spacewalk, the 7th out of the International Space Station this calendar year.
Turn my lights on, come up.
What?
Really go turn my lights on and leave them.
This view from an external camera on the International Space Station focused on the Quest airlock of the complex. Inside the crew lock, Pesquet and Kimbrough soon to place their suits on battery power to begin the start of today's spacewalk. The International Space Station flying from southwest to northeast across the southeastern Pacific Ocean, soon to cross over Central America in an orbit inclined 51.6 degrees to either side of the equator.
Point 8, GSID on the hatch, manual gauge.
Copy, Tomas.
I have a reminder for Tomas. We're not at the point yet where we want you to actuate the hatch, but after you fully rotate the hatch handle, when we are at that point, we'll have you pause for 1 second before opening the hatch.
Copy, Jenny.
Hey, Jenny, it's Mark. Does Tomas go to start that process when he sees 0.5 psi delta P on the EV hatch? Or does he have to wait till you call him?
Checking.
I'll check with you, Jenny, in any case.
We're thinking that that hatch is going to lag, as you guys might be expecting. So if we see it first, we'll let you know. But if you see it, you can open the hatch. Just a reminder, after you fully rotate that handle, we're looking for a 1 second pause before opening.
Copy, Jenny. Second pause after rotating the handle. ISS point 6.
Copy, Tomas.
Flying into an orbital sunrise, the International Space Station's Quest airlock now clearly in view. Soon the outer thermal hatch will pop open, and the inner hatch for the crew lock section of Quest will be opened. We're just about down to vacuum, and you'll start to hear the calls for final communications and systems checks for the two spacewalkers for today, Tomas Pesquet of the European Space Agency and Shane Kimbrough from NASA. As mentioned earlier in the broadcast, these two astronauts conducted 2 spacewalks together during Expedition 50 in January and March of 2017. The first was work that was ongoing as part of the sequence of events that swapped out batteries for the power system on the International Space Station. The second of their 2 spacewalks together 4 years ago saw them lubricate and service the latching end effector on the Canadarm2 robotic arm and prepare the zenith or space-facing port on the Harmony module for the installation later on of the second of the 2 international docking adapters.
And Tomas, in the airlock, I'm showing the telemetry showing 5 psi.
Copy.
Correction.
0.5.
Less than 0.5 psi.
Copy, Mark.
Once you've opened the hatch, I'll go ahead and put the emergency MPEV to closed. And then Jenny, it'll be completely over to you.
Copy, and we concur. We see that pressure less than 0.5 psi.
And that's what I have on the manual gauge as well, Jenny. So if you concur, I'm going to go ahead and rotate that handle and pause for a second.
Affirm.
All right, unlock. Rotating clockwise to unlatch. Hard stop. I'm going to pause. And then pull the handle up. Nicely done.
And the hatch to the crew lock section of Quest now open at 7:09. We're standing by now for final systems checks and the suits being put on internal battery power to mark the official start of today's spacewalk.
Going to move it? Yeah, can you move a little bit to there you go, forward and if I get to it. No, you just move you, because I think I'm contacting you. Okay. If you go as much forward as you can, Shay. I'm full, all forward. There you go. Okay, hatch is open. Nice. Secured for the daylight.
Nicely done, Tomas. The emergency MPV is now closed. All right, Jenny. Good luck today, and look forward to talking to you at the end.
All right, ground copies. Thank you, Mark. Well done. I am ready to pick up with you guys on your DCMs. Switch power to BAT. Stagger your switch throws and expect a warning tone. Check display switch functional.
Copy. Power to BAT. Let's bring BAT. Power to BAT, EV2. Restart.
Copy, power to BATS. Looking for a good display on Shane as well.
Good display. Good reset.
On the UIA, switch power for EV1 and EV2 to off, OFF, and check for LEDs off, OFF.
Okay, powers EV1 and 2 are off, LEDs are off. Switches 2 off, expected.
Disconnect SCUs from your DCMs and install your DCM cover.
Dark. View disconnected, cover in place, and for EV2.
Copy both. Stow your SCUs in their pouches.
Yes. You want us to use in the pouch.
Copy.
This is Mission Control Houston. Tomas Pesquet of the European Space Agency and NASA's Shane Kimbrough have placed their suits on internal battery power at 7:11 a.m. Central Time, 8:11 a.m. Eastern Time, marking the official start of today's spacewalk, the 239th in support of space station assembly maintenance and upgrades. Again, start time for today's spacewalk officially measured at 7:11 a.m. Central, 8:11 a.m. Eastern Time.
Hot EV1, max hot EV2.
Switch water on, ON.
Water on EV1. Water on EV2.
Check DCM blank, bite off.
DCM blank and bite off EV1. DCM blank, bite off EV2.
Copy all. Temperature control valve set as desired.
The voice you're hearing here in Mission Control talking to the two spacewalkers is that of Canadian Space Agency astronaut Jenny Sidey. She is the ground IV, or the spacewalk choreographer, who will be working step by step through all of the procedures for today's spacewalk. The hatch is open to the Quest Airlock's crew lock section. You'll be seeing Tomas Pesquet wearing the suit bearing the red stripes as extravehicular crew member number 1. He'll be emerging just a few moments from now once he and Kimbrough have completed an inventory of all the tools they'll be taking outside with them.
All right, copy. And with that, we are ready, Tomas, for you to open the hatch thermal cover.
Copy, opening the hatch thermal cover. CAT. Goes to reviewing.
And Tomas, you'll be stowing the hook on the stiffener tether point and cinching the snap strap until snug.
Copy. The hook is on the tether point, and the strap is cinched. I see 6 black lines.
Copy. We are expecting.
And the thermal cover is open.
Copy.
The outer thermal cover on the Quest airlock opens just as the International Space Station flies 258 statute miles over Miami.
I go to egress. Ready?
Affirm, Tomas, you can egress the airlock with crew lock bag number 1. We'll have you verify the forward hatch pit pin is engaged.
Copy, I'm egressing the airlock. Forward hatch pit pin engaged. I put down a local feather. And my crew lock bag.
Copy. You can get that crew lock bag on your VRT, and when you're ready, give Shane a go for egress.
Copy. Come back in. A little bit. Good. You're right on that bag. Yeah. Okay, I got BRT right on it. BRT on the crew lock bag. Bring back out. And then I have the right on it, I have my BRT. You can release.
And our first view of Tomas Pesquet, extravehicular crew member number 1 today, wearing the suit with the red stripes, representing the European Space Agency today as he begins the 3rd spacewalk of his career.
Yeah, I got it. Got it. Nice. I have a ret on the IDA bag, cable bag, released from airlock tether. Copy.
Copy, Shane.
You know when you're ready, Tomas? I'm ready. You can come out. Okay. Didn't call him. Yeah. Straight, you'll be good. Yeah, nice. On the lights. Go ahead and close the whole cover with you. Yeah, I gotta come back. You gotta come back. That's right. The brats around my lights. Yeah.
Copy. Now that you're both egress, you can turn on your HECAs, and we're ready to copy
Rotate your right shoulder.
buddy checks when you are.
Stand by, Jenny. Rotate your right shoulder, Shane. What's that? To your right shoulder. Rotate. There you go. Got it. Thanks. Okay, Jenny, can you say that again?
Okay, I copy. You can turn on your HECAs when you're ready, and then I'll copy buddy checks when you're ready.
Hey. Guys on EV1. EDT. Let me get this thing untangled here. Come on. What? Get the red untangled around my checklist. Oh. Let's see. You have to go underneath. You have to bring it back to me. It's around my safety tether too. Yeah. Okay. And release from your left arm.
Once Kimbrough is outside to join Pesquet, we should be seeing our first view from helmet cameras. Each crew member has 2 types of helmet cameras, the conventional ones that you are accustomed to seeing, with Pesquet's number on his helmet camera of 20 in the lower right-hand corner once they're activated. Kimbrough's helmet camera number will be 22. They also will be turning on high-definition cameras that are mounted on their spacesuits for even better views of some of the work that they'll be doing once they reach the P6 truss on the far left section of the backbone of the International Space Station. Shane Kimbrough now on the right in the unmarked suit. Extravehicular crew member number 2 has joined Pesquet outside. They will make sure that they have all of their tools and tethers configured properly before they begin to make their way out to the P6 truss.
Okay. I think now we're good.
Sweet.
Yeah.
Nice work.
Okay. So, you ready for body checks?
Ready?
On you, I see 2 green LEDs. Then going down, I see 3 tabs up and a little bit to your left shoulder. 3 tabs up for BRT. 2 handles down, and I see the waist tether is going from your right steering extender locked black on black to the airlock waist tether locked black on black, both the big hook and the small hook. Looks like a good config. Okay. And you got the IDA bag on your mini workstation, right? Yeah, that's what it is.
All right, I see 2 green lights on you. Lights are on, visor down. Mini workstation tabs, 1 and 2 are up. BRT tab is up. Safer handles are down. And I see your safety tethers just out your left side there. It all looks clear. Your crew lock bag looks good behind you. Like you're in a good config.
Okay, sounds good. With that, Jenny, if you agree, I'll make my way to P1.
Copy. Good buddy checks. I'll just take a baseline HAP check from you, and then we can get to translating, Tomas.
Correct. And the HAP is dry for V1.
Dry HAP, BD2.
Copy dry HAP. With that, Tomas, you're right. You can translate to P1. We're looking for Bay 12. I'll have a mile marker for you when you're ready. And Shane, you'll be attaching the cable bag bundle to the APFR and airlock with 12.
Copy.
Shane Kimbrough reporting a good configuration of all the tools and tethers, the HAP reference made by them and Spacewalk communicator Jenny Seide here in Mission Control is the acronym for Helmet Absorption Pad. That is the device in the spacewalkers' helmets to do exactly what it's implied, and that is absorb any perspiration or other condensation that may build up inside their helmets during the course of the spacewalk. The 2 spacewalkers placed their suits on internal battery power at 7:11 a.m. Central Time, 8:11 a.m. Eastern Time to mark the official start of this spacewalk. The 239th for station assembly maintenance and upgrades, the 7th for Shane Kimbrough, and the 3rd for Tomas Pesquet.
All right, I'm on phase 1. The fixed tether is clear. To my report.
Copy, Tomas. You're looking for mile marker 9180.
9180, copy, Jenny. Thanks.
Good words. Just under the FHRC. Shane, once you've bundled that cable bag to the APFR, you can stow the APFR in your BRT.
Yeah. All right, it's bundled on there.
Our first helmet camera view from Tomas Pesquet as he begins to make his way down the port truss of the International Space Station, incrementally using handrails to make his way towards the ultimate destination, which is the P6 truss, where he and Kimbrough will begin to work to remove the IROSA, the ISS rollout solar array, from flight support equipment that's mounted on the truss of the station to begin the intricate process of unbolting a variety of mechanisms that will lead to the deployment of that array later in today's spacewalk.
Okay, my anchor hook on 652, closed and locked, black on black.
Copy. Good config for your anchor hooks. Looking for a check on your reels.
Copy, Jenny, and my green reel is unlocked. My red reel is unlocked.
Copy. Green and red reels unlocked. You can tether to EV2's anchor hook.
Copy. Okay, Jenny, I'm tethered to EV2's anchor hook. My left waist tether.
Copy, Tomas. You'll be attaching EV2's anchor hook to 3651, which is nadir of the handrail you placed your anchor hook on.
Copy, 3651. EV2 anchor hook.
Good words.
EV2 anchor hook is on 3651. The gate is closed, slide unlocked, black on black.
Copy. That is a good load path. With that, I see Shane has picked up the APFR at the airlock. So when you're ready, Tomas, you can give Shane the go to release his tether from the airlock waist tether.
Shane, you're tethered to 3651. The good anchor hook. You have the go to pick up your waist tether and begin the translation.
Okay, copy that. Thanks, Tomas.
And I'm resuming my translation to the southern Silicon.
Say your last. Could you repeat your last
Did you copy my last? I'm resuming my translation to the starboard Silicon.
Okay, copy, Tomas. You'll be translating to the FSE Stanton Delta. I have a warning and cautions for you when you're ready.
And Jenny, I'm at DMT. I am ready for the warning and caution.
Warning, grapple shaft and curvet coupling teeth are no touch zone. Caution, no sudden movements or quick stops on the FSE. We want you to be translating slowly. Wait until FSE motion dampens out before imparting any loads. When Shane is on the FSE as well, do not simultaneously impart loads and do not contact IROSA blankets.
Copy on Jenny, thanks. And I'm at the starboard shear cart.
Copy, Tomas.
I'll make my way up. Yes.
Any close on thermal cover? It doesn't seem to want to stay closed.
Copy, Shane. You're closing the thermal cover.
It's not staying closed though, Jenny.
Copy. We're looking into that, Shane. In the meantime, can I get check on your reels? We want them unlocked. And Tomas, we see you on the FSE. You're looking to stow your crew lock bag on the tower handrail.
Copy, stowing your crew lock bag on the tower handrail on the FSE.
Shane Kimbrough completing the configuration of the outer thermal hatch cover at the Quest airlock while his spacewalking crewmate, Tomas Pesquet of the European Space Agency, makes his way towards the flight support equipment, upon which the first pair of ISS rollout solar arrays are mounted. The International Space Station flying just beyond Paris.
That could be in the way. Can you get your eyes on anything that might be obstructing it?
Yeah, it's a waste tether, thanks.
Copy.
Okay, thermal cover is closed. Thank you.
Copy, Shane. You'll be translating to the FSE and stowing your PGT on the tower handrail.
Oh, doesn't want to stay closed again.
Copy. We're seeing that, Shane. We're talking it.
You want to stay here? Yeah, nothing blocking it.
Yeah, copy.
When Pesquet arrives at the site upon which the solar arrays are located on the flight support equipment that carried them to orbit in the trunk of the Crew Dragon that SpaceX launched to the station back on June 3rd, he will use a pistol grip tool, a high-tech screwdriver basically, to release bolts that are called outer hinge restraint bolts, holding the array in question that will be the subject of today's installation for the 2B channel power augmentation for the International Space Station. Kimbrough, meanwhile, will translate outboard to the P6 truss to await Pesquet carrying the solar array that will be installed on the P6 truss over to him. after Pesquet affixes an articulating portable foot restraint to the end of the Canadarm2 robotic arm.
And Shane, from what we see, it's holding well now. Do you think if you were to translate outboard, it would stay where it is? Looks pretty good to us.
Yeah, it looks good to me. I can't tell where it's attached or not, but it looks solid.
Copy. All right, Shane, you can start your translation out to the FSE.
Thanks.
Stand by, Shane. It looks like the thermal cover just opened.
Okay. Standing by.
Good, Jenny. My crew lock back is stowed. So I'll be ready for your PG steps.
Copy, Tomas. You can ready your PGT. You'll be working on the outer hinge restraint bolt R5.
Shane Kimbrough continuing work to try to close and secure the outer thermal hatch cover over the crew lock section of the Quest airlock before he begins his journey out to the far left section of the truss of the International Space Station. Tomas Pesquet making his way to the location where basically the carrier holding the first pair of IROSA ISS rollout solar arrays is located.
Hey, Jenny, it's closed again, and it seems to be holding for now.
Copy, Shane. We're having a discussion down here about whether we want you to put a tether on it. That's the holdup. So I'll have word for you on that soon.
Okay.
Jenny, I have my PGT and I'm ready for settings.
Bravo 2, counter 2.
Bravo 2, counter 2.
Good words. And Shane, we're going to have you put an adjustable equipment tether on the thermal cover to the circular handrail just to keep it closed.
And work.
Zania, Bravo 2, counter 2.
Copy. Those are good settings. You'll be releasing R5, 18 to 20 turns. The bolt will spring out when fully released, and we'll be checking for a release indicator ring.
You're releasing R5, 16 to 20 turns.
A-firm.
I get low torque on the PGT.
Say again, Tomas?
Get low torque on the PGT. I'm at 10 turns.
Copy.
Got 17 turns. See the ball stopped out. I'll give it a couple more turns if you'll allow me.
Copy, Tomas, checking.
All five is released.
Copy, R5 released. And Shane, we recommend not wrapping the adjustable too tightly around the thermal cover. We just want a simple hook on it to keep it pretty much closed, but we don't want anything that's going to be too difficult to undo if you have to get in there quickly.
Okay, copy.
Shane, we recommend hooking to the loop, which is by your right hand on the circular handrail. That looks like a good point if you like.
Copy.
And Tomas, with R5 released, your next step is going to be to stow your PGT, the red one.
Jenny, if you have words for me, I think I'm doing a socket swap, correct?
Affirm, that was a handover, guys, so I'm back with you now. Your next step, Tomas, is to stow your PGT on the tower handrail, and then we have you putting the socket on Shane's PGT. But we're talking next steps since we're having Shane troubleshoot that issue with the thermal cover.
Okay.
Okay, Jenny, that's adjustables on there, complete.
Copy, Shane. We're still getting your helmet cam back with us after the handover, so we'll get eyes on that adjustable shortly.
Okay. You need me to face it, Jenny, or you guys are looking at other stuff?
They're talking at Shane. Words shortly.
My PGT now is a red going to NRASIO 13 on the tower.
Copy, Tomas. We'll have next steps for you shortly. And Shane, we're taking our time here because we want to make sure that we're really in a good config. So we're going to have you tether it such that the tether point that you're using is far from the hinge on the thermal cover. So at the actual opening, so toward your left.
All right, I'll move it over there.
Copy. Thanks, Shane. That'll be using that hook right by your left hand. And that's not the correct hook, Shane. We're looking for the hook, which is by your right hand, to move to the hook on the circular handrail near your left hand.
Oh, okay, gotcha. Gotcha, wanted me to move the whole thing, I'm sorry.
No problem. We're on the right track.
With Tomas Pesquet having arrived at the work site where the ISS roll-up solar arrays are located. In this view from his helmet camera, high-definition view, Shane Kimbrough now working to tether down in place the outer thermal hatch cover on the Quest airlock that has been a bit bulky this morning. 35 minutes into the spacewalk, Pesquet will begin to set up shop to release an outer hinge restraint bolt that will free up the solar array that will be extracted, that he will haul over to the P6 truss and ultimately hand off to Shane Kimbrough. in a choreography that will ultimately result in that array being installed on a modification kit, a bracket basically, at the mast canister base of the P6 truss of the arrays, and then ultimately unfolded once a series of other bolts are released to enable the tension-laden solar array to unfurl.
All right, big picture for you two. We're having Shane translate out to the FSE, and he's going to drop his PGT there. Tomas, you'll be putting a socket on that PGT to continue with the anti-rotation device removal, the ARDs, so you can ready the 7/16 12-inch socket.
All right, 7/16 12-inch socket on Shane.
Tomas, we're going to have you stand by.
Standing by, Jenny.
Hey, Tomas, I'm on Spacewalk, coming your way.
Okay, I see you from distance. Been good.
And ground copy, Shane.
And Jenny, you're breaking up.
Copy, Tomas.
Oh, now you're coming in clear.
All right, keep me updated on it.
I will.
And Tomas, we're just keeping an eye on your Medox, wanting it to come down a little bit, which is why we had you stand by for a little while. We're pushing with the nominal timeline now, so we're seeing your Medox return to a good level now.
Okay, sounds good. Thanks for keeping me honest, Jenny.
No problem. Shane's around three minutes or so away.
Yeah, I see him coming in between the two IROSAs.
Nice.
Beautiful sight.
There's a good view of Tomas Pesquet at the flight support equipment carrier, if you will, in which the first pair of ISS rollout solar arrays are housed. He will begin work very soon to begin loosening bolts and anti-rotation devices, as they are called, basically launch constraints that held the arrays in place when they were launched back on June 3rd in the trunk of the Crew Dragon cargo vehicle that SpaceX launched on a Falcon 9 rocket from the Kennedy Space Center to bring to orbit. Those arrays arriving at the space station on June 5th and then robotically removed from the trunk of Cargo Dragon and mounted at that payload attachment fixture for the time being, awaiting the start of today's spacewalk. In the foreground is the trusty Canadarm2 robotic arm that astronaut Megan MacArthur will be operating a short time from now to move Tomas Pesquet to the P6 work site as he carries the arrays manually, the first solar array, to hand off to Shane Kimbrough before it is mounted on a bracket at the base, at the mast canister base of the P6 solar array structure.
All right, I got your tether in front of me here. I'm just at the starboard seat of carts. Copy?
Ground copies.
Your feet there, Tomas.
My feet. Nice.
All right, fourth seat of carts coming to you. What do you want me to do tomorrow? Come up there? And
yeah, if you can. I'll try to come your way and meet you halfway. I have to bring this bucket caddy.
So Shane,
it's attached to the bag.
Shane, you just need to get your PGT to Tomas. We have the published steps to stow it on the tower handrail, but if you can pass it to Tomas more easily, that's fine with us.
Yeah. I think that's what we'll try and do.
Just stay there, Tomas. I'm on the pallet now, too.
Okay.
I'll just come to you.
Okay.
Good with that?
Yeah, I'm good with that.
Okay.
Let's be gentle.
Nice and smooth.
All right, make it down, local tether.
All right, I've got a local tether down.
Nice. That's on a PGT. Have the PGT.
There you have it.
Gonna retrieve yours. Nice.
Got it.
Thank you. Thanks for the visit. Come back anytime.
Okay. All right. Let me move slowly off of here, and I'll let you know when I'm clear.
Yeah, I'll wait for you to be gone before I move.
All right. I'm just going to back out the same way I can. Still on.
Clear?
No.
Okay.
Get reoriented here.
"45 minutes into the spacewalk, Shane Kimbrough and Tomas Pesquet are at the flight support equipment structure, holding the first pair of ISS rollout solar arrays that were launched a couple of weeks ago aboard the SpaceX Cargo Dragon vehicle to the International Space Station. Each one of these arrays weighs 750 pounds of mass, of course weightless in orbit. Each new solar array will produce more than 20 kilowatts of electricity, eventually upping the power capability of the station by some 120 kilowatts. This is the first of 3 pairs of these arrays that will be installed at various truss structures of the station. Today and on Sunday, in the second of this first set of spacewalks, The 2B and 4B power channels of the P6 truss will be augmented by these arrays. They do not replace the older legacy solar arrays. They simply augment the power output of the existing arrays. The next two sets of arrays will be installed on the P4 and S4 trusses, and then ultimately the final pair on the S6 and S4 truss structures of the International Space Station. 6 of the 8 power channels on the station to be augmented. Those are the channels that have indicated the greatest set of degradation over the course of some 2 decades of use at the International Outpost, and also accommodate the highest usage loads for various payloads and scientific experiments and new modules to arrive at the International Space Station.
So those are your warnings. Your cautions are avoid contact with the deployed and stowed radiators, and the battery adapter plate cables on the IEA are a snag hazard.
Okay, copy that. Thank you.
Shane, you're translating outboard to P6. I'll check your gauntlets are down, and I have a green hook location when you're ready.
Okay, gauntlets are down and ready for the green hook location.
P6, handrail 5312.
P312, copy P6.
And Jenny, I have the 7/16 12-inch on the green PG2.
Copy, and I'll take a pull test.
And I have a good tool test on that socket.
Excellent. Next steps for you, Tomas, are to start releasing the anti-rotation devices. So I'll have you translate to the Charlie 1 bolt, which is zenith and outboard.
Translating to the Charlie 1 bolt, zenith, and outboard.
Affirm, that'll be stanchion Charlie.
Copy stanchion Charlie.
Tomas Pesquet will be attaching and articulating portable foot restraint at the end of the Canadarm2 robotic arm that he will ultimately plant his feet in to be driven by astronaut Megan MacArthur, who will operate the arm from a robotic workstation inside the station. He will carry the first ISS rollout solar array over to the P6 truss, where Shane Kimbrough will set up another articulating portable foot restraint, so he has stability in receiving a handoff of that array from Pesquet at the appropriate time.
To attach an adjustable equipment tether to the ARD tether point.
And the green hook is on 5312.
Copy, Shane. You can translate outboard to P6 with 18.
Jenny has an AT on the ARD tether point.
Excellent. Tomas, your PGT settings, when you're ready for them. Bravo 3, counter 2.
Bravo 3, counter 2. Copy.
Pesquet using a pistol grip tool. He will use it for about 18 to 20 turns until a outer hinge restraint bolt is released. That essentially is the first step in freeing the first ISS rollout solar array from its flight support equipment that it was launched on.
Obviously, you guys can see that it's nighttime. Just a reminder to adjust your visors if you need to.
Bravo 3, counter 2, Jenny.
Good words. You'll be releasing the stop block bolt, 10 turns only.
Copy. The stop block bolts called AR1, 10 turns only.
Affirm.
3, 4, 5. Ten turns.
Copy, 10 turns. You can release the ARD.
Jenny, I got 12 o'clock. Block on.
Okay, release the ARD.
Sorry, Jenny, 12 o'clock on the APFR and with 18. Block on black, good pull test, good twist test. I'm going to work on the settings now. That's right.
Copy, that's a good install. Clocking of 12. We're looking for Fox, Fox, Fox 4.
That's Shane Kimbrough installing his articulating portable foot restraint at the P6 truss work site. That will be the place where he receives the array from Tomas Pesquet once that array is freed from its flight support structure.
And Tomas, when you have a minute, we'll get you to power cycle your HECA as well.
Standby.
Jenny, this pitch knob is really stiff. Any ideas?
Checking.
Okay, I got the ARD. We'll bring it back to my main workstation.
Copy, Tomas. The mini workstation end effector might be useful here.
Okay, I got the ARD on my main workstation. You wanted a power cycle of the HECA?
Affirm.
HECA off. Green LED.
Jenny, I got the pitch knob.
Okay, copy, Shane.
And maybe to retorque the ARD bolt, Jenny, if you have settings.
Your settings are Bravo 1, clockwise 2.
Bravo 1, clockwise 2.
Good read back, and we're looking for turning this bolt to torque, like you say, expecting around 10 turns.
Copy, 10 turns.
Shane, once you have those APFR settings in, we're looking for a check that the pitch knob has popped out, and you can retrieve the cable bag bundle.
Okay. Working on the cable bag, and then I'll finish up the APFR settings if that's all right.
Copy, no problem.
Then you have green light, 11.9 on the torque. I only have 5.5 revs. But I think maybe you see my ECA, it's because the stop block has rotated a little bit. And now it's pushing against the bolt of that, the base of that extension that holds. So there's kind of a 6 millimeter difference from where it was before when it was flush against the beam. Does that make sense?
Yeah, I follow what you're saying, Tomas. We're checking on that, but for now I copy the torque of 11.9, a green light, and like you said, 5.5 turns to torque.
All right.
And Tomas, we talked that turn count down here. We're comfortable with you moving on in the procedure for now, so you can stow your PGT and translate to Charlie 2, which is Zenith and inboard stanchion Bravo.
Copy. Going to PG. 2. How are you doing, Shane?
I'm good. I'm finishing up the APFR. Got the crew or the cable bag. I'm on PRT now, and final settings here.
Awesome.
As we approach the 1 hour mark into today's spacewalk, Tomas Pesquet in this view from his helmet camera, continuing work with a pistol grip tool to free up a series of bolts that essentially were launch restraints for the first of the IROSA or ISS roll-up solar arrays as they were housed in the trunk of the Cargo Dragon vehicle that SpaceX launched to the station 2 weeks ago.
Which knob is top?
Copy. That is a good config, Shane. You can translate outboard to handrail 5307, where you'll be stowing the cable bag.
5307, copy.
Shane and Tomas, we're around 30 seconds from handover. I'll be back with you after that.
Happy journey, thanks.
Copy.
We're back with you after handover.
Hi, Jenny. I have my the free hook from my AET on my main workstation is now on the ARD.
Copy, Shane. Your end effector is still on the ARD?
Oh no, Jenny, this is Tomas. The free hook of my AET that was on my main workstation is now on the ARD.
Copy.
ARD2 at Charlie 2.
The ARD that you're hearing referred to is the acronym for an anti-rotation device. This is a feature on the flight support equipment holding the IROSA or ISS rollout solar arrays in place. That is essentially a launch restraint that needs to be removed prior to Pesquet using his pistol grip tool to break torque on the bolts that are holding the first of these two arrays in place.
Copy. We just wanted to triple check there. We understand, Tomas, that you're readied to the ARD on Charlie 2 and you're ready for your PGT settings.
Is correct.
Tomas, your settings are Bravo 3, counter 2.
Bravo 3, counter 2.
Good read back. And Shane, you'll be stowing the cable bag on handrails in that corner of the IEA around handrail 5307. Make sure that you position the hinge ISS inboard.
Copy. Working on that. So we got two tethers down, working on the third now.
Copy.
Jenny, I'm ready for 10 turns on the ARD bolts.
A-firm, 10 turns only. That'll release the ARD.
You try SSC 13, that's in node 2. Thanks.
Again, Pesquet right now using a pistol grip tool to release what is called an anti-rotation device. This is the mechanism that must be removed prior to breaking torque on the bolts holding the IROSA array in place on its flight support structure on the truss of the International Space Station. Meanwhile, Shane Kimbrough is out at the P6 truss stowing a bag of power cables on a handrail that will be used later in the spacewalk by Kimbrough and Pesquet to electrically connect the new array to the power system of the International Space Station.
I'm getting my crew lock bag out, and I'll head to the work site.
Copy. And Shane, we're also looking for a glove inspection, hap check, and gauntlets check from you.
Okay, white glove, no change, looks good. Left glove, no change, looks good. Dry hap and gauntlets are down.
Copy. Those are good checks, Shane. When you have the crew lock bag, you can translate to the left mod kit. I have some cautions for you when you're ready.
Okay, go with the cautions.
Standby 1, Shane. I see your ARD is released as reported. Tomas, your PGT settings to drive this stop block bolt to torque are Bravo 1, clockwise 2.
So ARD is released. There's a lot of friction on those ARDs. It's the same for both. This is a spec.
Copy. A lot of friction.
And can you give me those settings again, Jenny? please.
Bravo 1, clockwise 2.
Bravo 1, clockwise 2. Copy.
Cautions for you, Shane. No sudden movements on the mass canister or mod kit. We'll have you translate slowly and avoid cyclic loading.
Copy all.
You'll be stowing the crew lock bag on the left lower strut handrail closest to the mounting bracket, the lower handrail stanchion.
Yeah. And then you have a good torque, 12 turns, and torque, sorry, 9.16 turns, and 12.0 torque and good green light.
Copy, green light, 12 on the torque and 12 turns. Tomas, you can stow your PGT, and then we'll put you back to the crew lock bag to stow those ARDs, retrieve the scoop, and do a socket swap.
Bring the PGT in back to a crew lock bag.
Good words, Tomas.
How's that bag, Shane?
What's that?
How's that bag?
Oh, it's good. We got the crew lock bag out now, working on that.
All right.
Ground copies.
Okay, Jenny, I'm back at the crew lock bag, and I'm getting ready to stow the two scoops on the three reds out of the crew lock bag. I mean, the two ARDs. Right.
Copy, those are good words, Tomas. You'll also be retrieving the scoop with the long-duration tie-down tether and stowing that on your mini workstation.
Copy.
This is Mission Control Houston, 1 hour, 12 minutes into today's spacewalk by Tomas Pesquet and Shane Kimbrough. The two spacewalkers are working in the very, very early stages of their respective tasks that will result in the removal of the first IROSA roll-up solar array from its flight support structure. You can see in this image that large support structure that was housed in the trunk of the SpaceX Cargo Dragon vehicle that carried it to orbit back on June 3rd when it was launched from the Kennedy Space Center, arriving at the International Space Station 2 days later.
Make sure it stays redded to the crew lock bag, and you'll install it with the handle pointing inboard.
Copy.
Pesquet next will use a pistol grip tool to break torque on 2 bolts on that flight support equipment structure holding the IROSA array in place. Shane Kimbrough is still working in the final steps of setting up shop at the P6 truss with an articulating portable foot restraint that he will be awaiting the arrival of Pesquet in. Pesquet will set up a foot restraint of his own at the end of the Canadarm2 robotic arm and then place his feet in that foot restraint, pull the array out of the flight support equipment structure and haul it over to where Kimbrough is for a handoff. Kimbrough will then rotate that array in the proper orientation to await Pesquet's arrival so that the 2 crew members can work with each other for the ultimate installation of that array on a modification kit, essentially a bracket that was installed at the base of the mast canister of the P6 truss array structure on a previous spacewalk.
Okay, I see the microsquare here.
Copy, Tomas. Yeah, we see that in your WVS. Make sure that you have the scoop with the long-duration tie-down tether, which you do, and that goes in on your mini workstation.
That was shared, Jenny, but I'm working on this.
Copy.
Okay.
So then, Shane, I copied
All right,
it.
Shane, if you have a...
You have the scoop, which is staying ready to the bag, and you're going to be installing it on the root beam microsquare.
Jenny, and I have the scoop. With the long duration on the crew lock bag. Put that on my mini workstation.
Copy, Tomas. Following that, we'll have you do a socket swap.
Scoop is on my mini workstation and socket swap for 5/8.
That's exactly right, Tomas. We're looking for the 5/8 12-inch socket on the PGT.
Copy. 5/8 12-inch socket for Shane.
Okay, Jenny, the square scoops installed. Handle is inboard.
Copy, Shane. That's a good config. You can get started on routing the right wire harnesses from the cable bag. Let me know if you need additional words on reading to them or routing them.
Okay, copy that.
Johnny, the 716, 12 inches back on the socket caddy with a good pull test, working on the 5/8, 12 inch on Shane's PG.
I copy a good pull test on the 7/16 12 inch on the socket caddy, and you're working on the 5/8 12 inch on the PGT.
That is correct. Alright, the 5/8 12 inch is on the PGT with a good pull test.
Copy, good pull test on the 5/8 12 inch on the PGT. Your next steps, Tomas, are to break torque on the IROSA FSE bolts, Charlie 2 and Charlie 1.
Copy.
Jenny, I have a ret on the red cables. So I'm going to release the ret from the back and then take them up to the live kit right side.
Copy, Shane. That's a good config. And Tomas, while you're buttoning up this crew lock bag, I just wanted to let you know that occasionally your comm is coming through muffled. I understand there's not much that you can do about that at this point. Your mic booms are set, but that's why I'm repeating calls back to you, and just correct me if we ever get it wrong.
Yeah, that sounds good, Jenny, and I'll try to be clear. And Shane, do you copy me, or is it the same for you?
No, I'm copying you good.
Okay. Copying you good, too.
Copy all.
And you're sure it's not my French accent that's throwing you off? You're Canadian, you can handle it. All right.
Tomas, you'll be translating to Charlie 2 to break torque.
Copy, Charlie 2 to break torque.
A-firm, that's Zenith, and inboard or stanchion Bravo.
Spacewalk communicator Jenny Seide, a Canadian Space Agency astronaut, talking to Tomas Pesquet as he uses a pistol grip tool to break torque on a pair of bolts holding this first IROSA rollout solar array in place on its flight support equipment on the truss of the station. A distinct Canadian flavor to today's spacewalk, with Seide talking directly to the two spacewalkers outside. Next to her is veteran astronaut and veteran spacewalker Drew Feustel, who was educated, amongst other places, at Queen's University in Kingston, Ontario, Canada. The space station's robotic arm, the Canadarm2, will be used to move Tomas Pesquet, holding the IROSA solar array, over to Shane Kimbrough, where they will work in concert with one another to install it at the mast canister base of the P6 solar array truss structure. The P6 truss arrays were delivered to the International Space Station on the STS-97 mission aboard the shuttle Endeavour in December of 2000. That also featured the presence on board of Canadian Space Agency astronaut Marc Garneau, the first Canadian to fly in space.
Tomas, now that you're at Charlie 2, let me know when you're ready for PGT settings.
Okay. Jenny, I'm at Charlie 2, Shane's PGT, the green PGT, 5/8 times 12 inches, 12 inches, and I'm ready for settings.
Copy. You're in a good config, Tomas. Your settings are Bravo 3, counter 2. You'll be releasing Charlie 2, less than half a turn.
Bravo 3, counter 2, less than half a turn.
Affirm.
Okay, less than half a turn on Charlie 2.
Copy. Half a turn on Charlie 2. You can stow your PGT and translate to Charlie 1.
Copy, stowing and moving on to Charlie 1. How you doing, Shane? Good. I got the first cable tied down and just looking at the distance before I do 3 turns on it. But good. Nice. Nice work.
Ground copy, Shane.
The second one, I'm going to have to move out quite a bit. So, got a red on that and undo it.
This is Mission Control Houston, approaching the 1 hour, 30-minute mark into today's spacewalk. A good view of European Space Agency astronaut Tomas Pesquet by the flight support equipment, and you are getting a great view of the 2 pairs of folded ISS rollout solar arrays, one of which will be extracted from that flight support equipment a short time from now and moved by Pesquet at the end of the station's robotic arm over to hand off to Shane Kimbrough at the P6 truss of the station, where it ultimately will be installed and mounted in place for its deployment later in today's spacewalk. The International Space Station is flying into an orbital sunrise over the Pacific Ocean, soon to cross the coast of Mexico, flying 258 statute miles above the Earth in an orbit inclined 51.6 degrees to either side of the equator, this track carrying it from southwest to northeast.
Okay, Jenny, I'm in position for Charlie 1.
Copy. You'll be braking torque on Charlie 1, less than half a turn. Let me know when you're ready for settings.
Braking torque on Charlie 1, less than half a turn. I'm ready for settings.
Bravo 3, counter 2.
Bravo 3, counter 2.
Good read back.
Work. Less than half a turn on C1. So, let me do that again. I got low torque. Torque of 9.4 for 18.4 is not great. Moved by less than half a turn, but want me to give it a little bit more, Jenny, or not?
Checking, Tomas.
Okay. And I saw it moved then by less than half a turn.
Yeah, we're happy with that, Tomas. As long as it moved, we're just braking torque at this point.
Okay. Thank you.
So now you'll be releasing Charlie 1 27 turns only, and I have new settings for you.
Copy 27 turns on Charlie 1, and I'm ready for settings.
Bravo 3, counter 3.
Bravo 3, counter 3. And Jenny, I just saw that my PGT in counter 1, so maybe it skipped when I had to set it to counter 2 before. It seems like I turned Charlie 1, but I'm counterclockwise 1, I think. Braking torque. Need to go back at counterclockwise 2?
I'm checking for you, Tomas.
Thank you.
Tomas, you can continue. Again, we just wanted to brake torque there, so as long as the bolt moved, we're happy for you to press.
Okay, perfect. So Bravo 3, counter 3, correct?
Affirm, those are good settings. You'll be releasing Charlie 1 27 turns only, so not fully released.
Copy, looking for 27 turns on Charlie 1.
Good read back.
You need right side cables are done. I'm going for the left ones now.
Copy, Shane. The right wire harnesses are complete. You are moving on to retrieve the left ones.
Right.
Ready at 27 turns on Charlie 1.
Copy, 27 turns on Charlie 1. You can stow your PGT, and we'll have you translate back to Charlie 2.
Copy, stowing the PGT and back to Charlie 2.
A great view of Tomas Pesquet using his equipment to brake torque on a pair of bolts holding the IROSA solar array in place on its flight support equipment. Meanwhile, Shane Kimbrough at his work site at the P6 truss of the station, the far left side of the backbone of the station, is routing a series of harnesses that will be associated with the power connectors that will hook up the electrical connections for the new solar array to the power system at the mast canister base of the solar array.
Jenny, I got a ret on white cables in cab side. I'll release the ret from the pad.
Copy, Shane. Shane, Tomas, I'm back with you after a handover. I copied the RET config for the wire harness for Shane.
Jenny, I am ready for settings on the PG for Charlie 2 for turns.
Bravo 3, counter 3.
Bravo 3, counterclockwise 3.
Affirm, and you'll be releasing Charlie 2, 51 to 54 turns. The bolt will spring out when fully released.
51 to 64 turns, copy. On Charlie 2.
Affirm.
As we hit the 1 hour 36-minute mark into the spacewalk, this view from Shane Kimbrough's helmet camera, he and Pesquet and the rest of the crew members on the International Space Station are crossing the coast of Mexico north of Guadalajara, orbiting 258 statute miles above the Earth. Pesquet using a pistol grip tool to break torque on a pair of bolts holding the ISS rollout solar array in place on a flight support cradle that was delivered to the station with the first pair of solar arrays on the SpaceX Cargo Dragon vehicle 2 weeks ago. Kimbrough, meanwhile, is routing a series of cables that will ultimately be used to hook up electrical connections between the new array and the electrical ports at the base of the P6 solar array truss structure.
Actual was 6.9. At the end, it was very, very low torque. It was higher at the beginning.
Okay, Tomas, I copy Charlie 2 released with 57 turns. You can stow your PGT.
Copy, stowing your PGT. Again, Jenny, as a piece of data, the first 10 turns where I could tell the torque was really high, and then it kind of moved a little bit, and then the rest was really weak.
Okay, we copy, Tomas, the change in torque you felt when you were releasing that bolt. Tomas, your next step is to install the scoop on the root beam microsquare near Charlie 2.
Copy, installing the scoop on the root beam microsquare at Charlie 2.
Affirm.
Yep.
And remember that scoop is going to be installed at a 45-degree angle toward you.
45-degree angle.
Jenny, I got the first cable wire tied down. I'm going to have to move the second one. I'm just like the other one, so give me a minute here.
Copy, Shane.
And Jenny, that scoop is at a 45-degree angle. I'm going to take my rod back. And it's secured in place.
Copy. We can see that. It looks good. Tomas, you can release your rut.
Okay, and I'm going to go back to the other side, Jenny, if that's correct.
Affirm.
Yeah, both sides.
That is right, Tomas. You are headed back to the tower handrail where you will swap PGTs. So stow Shane's, retrieve yours, and then I'll take a glove inspection half check.
Good. The cable, Shane.
Just moving this wire tie again, and then I'll tap this one down and we'll be good to go.
Jenny, I have a Shane's PGT with the 5/8 12-inch wobble socket on handrail 0013 on the tower, and I'll go ahead and retrieve my rod from that PGT.
Copy. Good words, Tomas.
Beginning, the are down with 2 wire ties on the mid-strut handrail, 1 on the lower strut handrail.
Copy, Shane. 2 wire ties down for the left wire harness.
Do a little cleanup here before I head back.
Shane, before we do anything else, heading back inboard, we want you to check that the soft capture features are armed and down.
Okay, the one right in front of me, the left one is not, so I'll put it there.
Copy.
Shane Kimbrough at the base of the P6 solar arrays that were delivered to the International Space Station.
A little bit of sticking up.
The first set of solar arrays to arrive at the station back in December of 2000 on the STS-97 mission aboard the shuttle Endeavour.
Verified that the strut MLI is clear for IROSA install.
Okay, strut MLI. Yep, it's well below the plane there, so I think we're good.
Copy, Shane. It looks like the mounting bracket is in a good config. So with that, I will have you head inboard, retrieving your green hook on the way.
Okay, I'm going to tie up this screw lock guide a little bit better, and then I'll be heading back.
Copy. That sounds good.
And then you have my PGT on the 9-mean workstation and Shane's PGT on the handrail to the right.
Copy, Tomas. That's a good config. I'll take a glove inspection and a HAP check.
Okay, gloves are good, no change, absolutely no damage whatsoever, and the HAP is dry.
Copy, no change to your gloves and a dry HAP. You can move on to SSRMS setup steps, which has you first translating to the starboard seat of cart.
Copy, inward translating to the starboard seat of cart.
1 hour, 46 minutes into the spacewalk, Pesquet has released these 2 bolts holding the IROSA solar array that he is just behind on its flight support equipment structure. 2 bolts that he used a pistol grip tool to release. Next up for Pesquet will be the setup of an articulating portable foot restraint at the end of the Canadarm2 robotic arm as the International Space Station passes just over the capital of Canada, Ottawa.
Copy, Shane.
It looks like you'll have turn here, Shane, because I'm not in the APSR yet.
No worries. Long ride.
The ISS rollout solar arrays, the IROSA. This is a new design that uses a one-piece carbon fiber composite boom that is essentially folded up into halves. Those 2 halves will unfold at the hinge. A bolt holding that hinge in place was released earlier in the spacewalk by Pesquet. This enables stored energy on the 2 halves of the boom to actuate the deployment sequence later in the spacewalk.
Hi, Jenny, I'm at the Cedar Cart. Starboard Cedar Cart, I see APFR in width 5, which is the medium-most one.
Good words, Tomas. That APFR should have an ingress aid. You're to retrieve it and translate back outboard.
Copy.
Pesquet again about to set up a portable foot restraint at the end of the Canadarm2 robotic arm that will be operated inside at a robotic workstation by Megan MacArthur. She will drive the arm with Pesquet at the end of it. He'll be holding the IROSA solar array and will bring it toward Shane Kimbrough, who's awaiting its arrival at the base of the P6 solar array truss structure after routing 2 sets of wire harnesses that house connections, electrical connections, that will hook up the array to the electrical system of the International Space Station's 2B power channel.
Okay, I have my BRT rep on the APFR tether point.
Copy, Tomas.
I have the APFR. Throw it on my BRT. Okay, APFR is on my BRT, and I'm making my way back to the FSE.
Copy, Tomas.
I'm here at the Port Cedar Cart, Tomas.
Hi, Shane.
And so you want me to wait on you?
So Shane,
I don't go back to the FSE.
Shane, you can translate.
Yeah, FSRNS.
You can translate to the FSE. You'll be at the grapple tower, and Tomas, you're actually just translating to the Port Cedar Cart, where you'll give SSRMS a go for the install position.
Yeah. Right.
All right, sounds good. Okay, I'm on the FSC.
Copy, Shane. Shane, I'll take a glove inspection and a HAP check from you, and then we're talking about next steps.
Okay.
Okay, I'm at the port, see the card. I'll try to stay away from it.
I'll see you there, Tomas.
Okay?
My safety tether's just on your back of your plus.
I'm sorry, what?
My safety tether's on the back of your plus, but you're okay right now.
Okay, it's going up.
There you go. Nice.
Okay.
I have a big picture update for both of you when you're ready.
Ready?
Ready?
Okay, so the next steps for Tomas are going to be to configure the arm. That means that we have about 20 to 30 minutes before we're ready for release from the SSE, which, Shane, are going to be your next steps per the nominal timeline. So we're polling you two on how you would feel about get-aheads on the R bolts on the lower IROSA for Shane at this time, while Tomas, you push with the arm reconfig and the nominal R bolts for the upper IROSA.
And Jenny, is it something that we can break out at any point and leave the IROSA in whichever intermediate configuration we're in, or do we have to get to a certain point with those get-aheads?
We can break out from those R bolts at any time.
Yep, same as usual.
I need about 5 minutes here to reconfigure my waist tether. So once I'm done with that, I can do whatever. But,
Okay, copy. That sounds really good to us. And there is no rush. You take your time, Shane, to configure your tethers, and Tomas will push with your nominal steps. Shane, let me know when you're ready.
Okay, that sounds good. And I'll be ready, Megan, if you're with us. Megan and Mark, I'll be ready for the maneuver to the HFR install position.
Okay, Tomas, Megan's ready as well. This public position would be 50 centimeters station zenith. Do I understand correctly that you're go for GCA, or should we wait for other comms?
No, go for GCA, and I think Shane is happy to come here for now.
Okay, let's start GCA. Bring motion.
Good motion.
Good motion. Centimeters to publish.
Continue. Continue motion.
5.
We can stop motion.
Okay, I heard you say stop motion. Is this a good position?
If you can give me maybe 10 to 15, let's say 20 station aft, sorry, and 20 more station zenith.
Is it okay if we go with the zenith first? So 20 more station zenith?
Yeah, 20 more zenith is fine.
Starting motion.
Station zenith.
Copy. Starting motion.
Good motion.
Good motion. 5 to go.
Good position, stop motion.
Copy, stop motion, and you wanted 20 centimeters station aft, is that correct?
That is correct.
Motion.
Good motion.
Big good motion.
And stop motion.
Motion.
Okay, that's a good Shane, GCA complete.
GCA complete. Brakes are on, go for APFR install.
Copy, go for APFR install.
Tomas, we understand brakes on. You do have a go to install that APFR. Let me know when you're ready for settings.
Copy, go to install the APFR. 5 minutes for settings.
And Shane, when you have a spare minute, understand you're working with your tethers now. Could you please power cycle your HECA?
I got a green light now.
Copy.
Jenny, I'm ready for settings on the APFR.
Looking for an install, clocking of 12.
Then give me the rest. Jenny, go ahead with the rest of the settings, please.
Papa Papa, Fox 6.
Papa Papa, Foxtrot 6. Copy. The clocking of 12. Okay, Jenny, I have 12, Papa Papa, Foxtrot 6, and sorry, I have Papa Papa, Foxtrot 6. I'm going to go ahead and install with a clocking of 12.
Copy, good words.
Jenny, I have a clocking of 12, and a good full impact test, black on black, on the clocking collar.
Copy, those are good checks, and let's ensure the pitch knob is popped out.
And the pitch knob is popped out. Actually, I haven't touched it. It was a Papa Papa.
Copy, that's a good config, Tomas. I can talk you through your safety tether swap to the SSRMS now.
Give me just 1 second.
Let me know when you're ready.
I will.
Okay, Jenny, I got my tether stuff figured out, so what the timing looks like.
Copy, Shane. The timing still looks good, so I'll get a glove inspection and a HAP check from you, and then I have your first get-ahead words ready.
Okay, left glove's good. Right glove, I have a little black smudge on the middle finger. See that? It's a little bit no damage or anything. Looks like just a grease smudge or something.
Copy.
Dry hat.
Copy, and dry HAP.
And Jenny, I'm ready for the search tether swap words on the SSRMS.
Copy, Tomas. First, you'll lock your green tether reel and check your green hook is locked.
Green reel is locked. And sorry, what was the other check?
Check your green hook is locked.
2 hours, 5 minutes into today's spacewalk, continuing to receive breathtaking views of Tomas Pesquet at the flight support equipment structure on the truss of the station, housing the first pair of IROSA or ISS rollout solar arrays, one of which will be installed at the base of the P6 solar array truss structure this morning to begin the augmentation of power capability for the international outpost. Pesquet is about to enter an articulating portable foot restraint he has attached at the end of the station's robotic arm, the Canadarm2. That will be operated by astronaut Megan MacArthur, who will transport Pesquet and the first of the 2 solar arrays over to Shane Kimbrough at the P6 truss to begin the installation of that array at the mast canister work site location at the base of P6.
Green hook is attached to the port for the car major handrail, and I'm going to go ahead and unlock my green reel.
Good words.
It's done.
I got a good eye on me there, Tomas, looking good.
And Shane, we're just finishing up with Tomas' tether swap at this time, but I can send you to the crew lock bag to retrieve the socket caddy. You'll be installing a socket on the spare PGT.
All right, that sounds like a lot.
And with that, I think we can move on to the ingress position. No, I'll have to extend the ingress aid. Yeah, let's do that now.
Tomas, understand you've attached your green hook to structure, unlocked your green tether reel, so that's right. Once comm is clear, you have a go to work with SSRMS to GCA to the ingress position.
Copy. And Mark, are you with me? Mark from Tomas.
Go ahead, Tomas. I was calling the wrong loop. We've got a published position 10 centimeters station forward and 50 centimeters station nadir, if that works for you.
That seems to be perfect. So with that, you can, is that a GCA? I think it's a GCA.
Affirmative is a GCA. With that, we'll consider that start GCA.
That is a start GCA.
Sorry, motion. First motion is 10 centimeters station forward.
Sounds good. That's a good motion.
Copy, good motion. Okay, to my correction, we're going 70 centimeters station nadir.
Copy 70, and this is good motion, station nadir.
Copy, good motion.
I think it's stop motion here, Mark.
Motion.
All right. Looks like I can enter the HFR from here without too many problems, so I'll call that GCA complete.
Copy, GCA complete. Brakes are on. Go for APFR ingress.
Copy, brakes are on. Go for APFR ingress.
Understand brakes.
Jenny to Shane. Hey,
Understand brakes on. Toma, I'm going to get you to attach your waist tether to the APFR, and then you are go for ingress. And Shane, I'm back with you. You're installing the 7/16 6-inch wobble on the spare PGT.
okay, and I was just going to call you and see about the timing because it seems like you get pretty close, but maybe I don't have a big picture.
Yeah, so big picture, I can fill you in there. We still have a couple of arm motions and also those bolts which require 245 turns. So those will take a couple minutes each. And since we can break out of doing the R bolts at any time, we still think it's worth getting one or two. But we're keeping an eye on things. Let us know if anything changes for you.
Okay, so I'm going to put this 7/16 6-inch wobble on the spare PGT, is that right?
That's exactly right.
Copy.
Okay, so it looks like both heels are in. That's what it feels like. That's my waist tether on the ISS, Jenny.
Copy. And if your tools and tethers are clear and your ingress aid is stowed, you can maneuver to the back off position.
My ingress aid is stowed, tools and tethers are cleared. There's a Shane set tether here, but I'll try to keep it out of the way. And Shane, I don't know if you have a visual.
I don't know. I can be there in just a minute if I break out of this.
Just to have a look that your set tether is clear and everything's looking good. See the line here.
A good pull test on the 7/16 on the spare PGT.
Copy. Looking for a good pull test.
Pull test is good.
Copy, Shane. Good pull test.
Hey, Tomas, the way we see it on the arm is we've got to move you a little bit to get to a spot that'll still be a GCA because you're so close to structure. So we've got about 30 centimeters to do as a GCA, and then after that we'll just do a manual back off maneuver.
Okay, that sounds good, and that would be nadir, right? That GCA.
Affirmative. Let me know when you want to start that GCA.
Prior to GCA, I'm going to pass instructions to Shane.
Go ahead, Jamie.
Thank you, Shane. You're going to be working near stanchion Bravo, which is inboard and zenith. and we're going to be releasing R5. And Shane, I can hold on settings for you until you're ready. We're about 20 seconds from handover as well.
Yeah, just hold off. Okay. And but during the handover, I think we can start the GCA or Mark, if you agree.
We agree, and we're starting at GCA, 30 centimeter station nadir.
Copy, 30 centimeter station nadir.
Two hours, 15 minutes into today's spacewalk, Tomas, Pesquet, and Shane Kimbrough are working together on different tasks, but essentially it's all the same work to prepare for and conduct the release of a series of bolts for the IROSA, or the ISS Rollout Solar Arrays Boom Deployment System, and a launch restraint that is holding the boom in place on the flight support equipment pallet, if you will, that the arrays were carried up on during launch 2 weeks ago on the SpaceX Cargo Dragon vehicle. There are two bolts that must be released for the boom deployment restraint system. There is an additional pair of bolts that release an outer deployment restraint capability. Basically, they're freeing up the IROSA array, the first of the two sets of arrays carried to orbit, so that Pesquet can transport the first of the arrays over to Kimbrough at the P6 worksite for its installation on a bracket, or a modification kit, as it is called, that was erected and installed on the International Space Station on a previous EVA.
Have a view, it's better, but I think it's good.
I do not have a view right now.
Yeah, I think it's good, Mark. We can proceed. I have it right in front of me.
Okay, we're working on that. And we're starting motion, Tomas. We're going away from the station.
Good motion.
And just a reminder, this is not a GCA, so the comm is still open.
We
Mark.
agree. Shane, let me know when you're ready for PGT settings.
Closing out the bag, so I just got the PGT on my workstation.
Copy.
Inside the International Space Station, NASA astronaut Mark Vande Hei has joined Megan MacArthur at the robotics workstation. MacArthur is the prime crew member to maneuver Pesquet from the flight support equipment housing the solar array over to the work site at the P6 truss, where Kimbrough is conducting some advance work for Sunday's second spacewalk in this series, in which the second of the two ISS rollout solar arrays will be removed from its flight support equipment and maneuvered to the other side of the P6 truss to hook up to the 4B power channel. Today's work involves hooking up the first of the two solar arrays to the 2B power channel on the P6 truss.
doing, Shane?
Good. How are you, Tomas?
I'm good.
I see you there. My tether's well clear now.
Nice. Thanks.
Yep. Coming over to the Bravo side.
See you next, Becca. Brings back some memories.
All right, Tomas, we're setting up for a joint hole cast.
Copy, Mark. I'm ready for motion.
Okay, Jenny, direct me to R5, please.
Copy. R5 is at Stanchion Bravo on the root beam close to the FSE.
Okay, and which way, if I'm driving it, is it driving it nadir or outboard?
The bolt should be pointing toward you, Shane. Looks like you're in the right position to see it.
And I'm on the zenith.
A-firm, you're on the zenith.
Is it label?
Zenith inboard side. So it's on the root beam facing you, close to Stanchion Bravo.
Correct.
Hey, Tomas, we're ready for motion. It's going to be about a 2-minute joint hole cast to the nadir back off.
I am ready for motion, Mark. Thanks for the heads up.
I don't see it there. Is it in between the stanchions, you think, Jenny?
It should be in between the stanchion and the POA on the root beam. And it should be just closer to the stanchion than a handrail, which is also on the root beam.
I see a bolt right next to the handrail. Is that it?
A-firm, that should be it.
Okay, copy.
And that should be
BRT setup.
that should be labeled, Shane, if you can get eyes on it.
Shane Kimbrough at the flight support equipment housing the ISS rollout solar arrays as he tries to loosen up a couple of additional bolts that will assist in the removal of the first of the 2 arrays that Tomas Pesquet will haul over to the P6 truss while affixed to a foot restraint at the end of the station's Canadarm2 robotic arm.
A 2-minute heads up for you guys. We're headed toward a night pass.
And the Heka is back on, Jenny.
Copy. Thank you, Tomas.
Okay, Jenny, I'm ready for settings.
Bravo 2, counter 2. And you'll be releasing that bolt 18 to 20 turns. It'll pop out when released.
Okay, Bravo 2, counter 2. Sets and 18 to 20 turns. It should pop out.
A-firm. Those are good words. We'll also be checking for a release indicator ring.
Okay. Getting access in there is going to be different.
Yeah.
Switch my BRT. Sorry, Jenny.
Copy. No problem.
No rush at all, Shane. This is already a get ahead.
All right, Tomas, our next step will be a GCA to published. The published gives you 75 centimeters, which is body in, 75 centimeters body in. Does that work for you?
Works fine for me, Mark.
Okay, I'll wait for your command to start that GCA.
Okay, you can start GCA.
Okay, starting GCA.
Motion.
Motion. Happy, good motion.
Continue.
Continuing. 50 centimeters to go.
Copy 50.
25 centimeters to go.
Motion, Mark.
Motion.
I think that's good as far as body in, but I'll need, since I'm expecting R1, R2, R3, R4, I need some station forward or motion towards my head. Good. Oh.
Okay, Tomas, we copy. Continue the GCA. Body up. How far?
Copy, and I'm stand by. Jenny, you confirm I'm starting by R1?
Checking. A-firm, you will be starting with R1, followed by R2.
Okay, because I'm actually now in a good position for R3 and R4, but I'll go ahead and DCA 50 centimeter head direction for R1.
Was that 15 or 50?
50, really good clarification marks. 50 centimeter, motion, body up.
Break,
Okay,
Tomas.
Stand by, Mark.
Tomas, stand by on the GCA. You can also do R3 and R4 if you're in a better position for those now. Save the GCA.
I'm actually in a good position to do this. So with that, Mark, I'll call GCA complete for now.
Copy, GCA complete.
The reference by Spacewalk communicator Jenny Seide of R1, 2, 3, and 4 refer to a quartet of bolts that are associated with the boom deployment restraints holding the ISS rollout solar array in place during the launch phase, which now must be loosened to enable the boom itself to unfold from its folded position, and then for the array ultimately to unfurl to its distance of about 60 feet later in the spacewalk today.
Copy. Alpha 3, clockwise 3, and then PGT 30, sorry, should be 0.
Good words.
Jenny, I can't reach that R5 with any position I've found so far.
Copy, Shane. We're talking that.
The POA blocks me here. You know, the POA blocks. All right.
Jenny, I'm going to go ahead and start R3. 245 turns, is that correct? 245?
A-firm, 245 turns on R3. If you call out your turns, we'll keep it in sync with you in the ground.
Okay, Alpha 3, clockwise 3, 245 turns on R3. Give you a frequent turn count at the beginning and then less frequent as I progress.
Copy.
All right, 3, 4.
And Shane, we're talking that issue down here on the ground. Again, we're in no rush for our get-ahead, so we're taking that into consideration, and we're around 30 seconds from handover.
Approaching the 2.5-hour mark into the spacewalk, Shane Kimbrough working with the pistol grip tool, or rather Tomas Pesquet working with the pistol grip tool to release a series of bolts for the boom deployment mechanism on the IROSA solar array.
Shane.
I'm good. I'm just hanging out. I can't access this bolt, so they're thinking about it.
Yeah, that's what I was hearing. I didn't see it when I was there.
It's just too deep, and the power blocks me getting in there.
You think we can get to it once the upper IROSA is gone?
I think we'll need a longer extension.
Oh.
And we're back with you after the handover.
No turns.
Shane, we copy. You think you might need a longer socket for that bolt, is that right?
Yeah, I'm just going to have to be, like, I don't think 12 will get there. I think it'll have to be longer than that.
Okay, copy.
Okay, do you want me to show you how far the 6-inch level gets?
We don't have your helmet cam yet after the handover, but I'll let you know. We're just talking that.
Okay.
More than 50 turns.
Copy, Tomas. Shane, we have your helmet cam back if you can show us.
Yeah, I'm showing you now. It's probably 6 to 7 inches short, I think. I'm wedged in here against the power and the B side beam.
Okay, copy, Shane. Thank you. And Shane, do you think any reorientation of the PGT would help? I understand you've tried a lot of different positions. We just want to be thorough here.
I mean, at least with my reach, I can't get the PGT any closer than this, no matter what orientation is. Doesn't matter. That's not the limiting factor for me.
Okay, I copy, Shane. Thanks for letting us know.
Through 30 turns, 230. Four, 0, 1, 2, 3, 4, 5. 245 turns on R3. I'm not in a position to see the indicator right now. Nope, can't see it.
Okay, I copy 245 turns, Tomas. We know that was a lot. Well done. And that you can't, from your current position, cannot see the base of the root beam. So with that, we will move on to R4. I have new settings for you.
Okay, R4, I need some GCA, Mark and Megan, if you guys are here. I need to go body right for at least, I'll say 20 centimeters maybe. So.
Tomas, prior to taking COM for GCA, just some words for Shane. We're not sure if the longer socket would help with reach, but at this point we're going to send you back to the crew lock bag to do a socket swap to the 12-inch socket and assess that reach, and that'll be the only get-ahead that we're working in this time.
Okay, copy.
As we follow along with Pesquet and Kimbrough, not only are they working to release the final bolts for the first of the two solar arrays, the IROSA arrays that are housed on the flight support structure. On the truss of the station, there's a good view of the two arrays. The first pair launched on the SpaceX Cargo Dragon flight 2 weeks ago, but they have been working on some get-ahead work to try to loosen up bolts for Sunday's next spacewalk that will have the second of the two arrays released from that flight support equipment structure and mounted on the P6 truss.
I'm sorry, Tomas, I didn't copy. Was that a stop
motion?
GCA complete?
Can we stop motion? Did you stop motion?
Yes, stop motion.
Okay, so GCA complete, thank you.
GCA complete.
All right, and I'm ready for settings on R4, Jenny.
And brakes are on.
And brakes are on, thank you, copy.
Copy, brakes on. Your settings for R4 are Alpha 3, Counter 3.
Alpha 3, Counter 3.
Affirm. And we'll verify
turn count.
Your...
Right.
Oh, go ahead. Your PG turn count
is
to be 0. Affirm. We copy 0 on the turn count. You can release R4 245 turns. We're following along with you.
Alpha 3, Counter 3, 245 turns. Holding now.
Copy.
That's 50 turns. Five. Hundred turns.
Two hours, 37 minutes into the spacewalk. Pesquet and Kimbrough still working to release the final bolts that will free up the first of the two IROSA solar arrays from its flight support structure. That will enable Pesquet to begin transporting that array over to the P6 truss for its installation.
A lot of turns, Shane. Five zero. Zero. Nine zero. Good. Thank you. Zero.
Full test on the 12-inch and the 6-inch on the socket caddy.
3, 4, 5.
Copy, Shane.
45 turns on R4.
Copy, 245 turns on R4, Tomas.
All right. Shane, if you're good to the comms, I'll need some more GCF for R2 on R1.
You got it.
All right. Mark, you ready?
And your go for the GCA. We'll have Shane move back to the R5 socket or R5 bolt and test that socket for reach. Otherwise, you can GCA to R1 and R2.
Until I was on the wrong loop again, I am ready for the GCA now that the comm's been used.
Copy. And for that GCA, I'll need you to take me to 40 centimeters, body up or station forward. Body up.
Copy, 40 centimeters, body up, starting motion.
Good read back. And I see good motion.
Copy, good motion.
Stop motion.
Stopping motion.
It's a good position. GCA complete for R2.
Copy, GCA complete. Brakes are on.
Copy, brakes on.
Understand.
Jenny, do you have settings for me for R2?
Affirm. Your settings for R2 are alpha 4, clockwise 2.
Alpha 4, clockwise. Copy.
Affirm. You'll be releasing R2 10 to 13 turns, and the bolt will spring out when fully released.
Copy. Alpha 4, clockwise 2, 10 to 13 turns on 3 on R2.
And for R2, stand by, Tomas. It's alpha 4, counter 2.
Alpha 4, counter 2, good catch. Alpha 4, counter 2, 10 to 13 turns.
Affirm, 10 to 13 turns.
Good work.
And Shane, now that you're back at the R5 bolt, how does that reach look with the new socket?
Getting it out now. I'll let you know here shortly.
Copy.
Jenny, R2 popped out. Got 10 turns, R2.
Copy, 10 turns, R2 released. Now we're looking to release R1.
Need to do the BDS on that side or go to R1 now?
So you can do the BDS now that you've released R2, or you can do them both together afterward. It just depends on your reach with the arm.
Okay, I'll do R2 now that I'm here. I might have to move to get to R1.
Okay, copy. So if you rotate it now, just keep in mind that you need to rotate it slowly to the deployed position. And after rotation, it might not rest fully on the blanket in the rotated position.
Copy, rotating slowly to the deployed position.
Good words.
Jenny, I can barely get there, but I think once I get it on, I'll be able to turn it.
Okay, copy, Shane.
Stay on and give me a turn.
We have time to do that bolt now. So your settings are Bravo 2, counter 2.
That's it.
You'll be releasing.
Slowly but surely, Tomas Pesquet is rotating the boom deployment system handle.
Release indicator ring.
That will ultimately enable the array to be unfurled, and for the array itself, which is basically folded up in its two sections of the boom folded up in half, will enable the boom to unfurl at the point at which it is installed at the base of the P6 solar array truss.
Cam, that looks like a great view for us. You're welcome to move on to R1.
Okay. And I'm ready to, Mark, if you can give me, okay, Shane, you're ready to give me GCA?
Yeah, you got it.
Okay, Mark, if you're ready, I would need 20 centimeters of body left.
Copy, Houston, you need to come?
Your go for GCA. You can take the comp.
Okay, we're starting the GCA, 20 centimeters, body left. Starting motion.
Read back.
You have good motion?
I got good motion.
Good motion. Okay, that's the 20 centimeters you asked for.
And you can stop motion. It's a good position. I call GCA complete.
The GCA complete.
Okay, Jenny, I got 20 turns on there. It looks like it's popped on. I can't completely see it just due to the lighting right now.
John.
Okay, copy brakes on, Mark.
Copy, Shane. I'll have words for you shortly. And copy brakes on for Tomas. Your settings for R1 are alpha 4, counter 2.
Got alpha 4, counterclockwise 2.
A-firm, you'll be releasing R1 10 to 13 turns, and the bolt will spring out when released.
13 turns, and the bolt will spring out and work.
Jimmy, looks like the bolt is out to me. Get some little better lighting here.
Copy, Shane. That sounds good to us. That's the completion of the get-aheads that we're going to do in this time, so you can stow that PGT. And then we're going to send you to look at the indicator on the base of the root beam that would have popped out when Tomas released R3 and R4.
Okay. Jenny, 11 turns on R1, and the bolt popped out. It popped up. It looks fully released.
Copy. R1 popped out 11 turns. Same way that you did with the R2 boom deployment system, you can rotate the BDS associated with R1 to the deployed position slowly, and keep in mind it might not contact the blanket in the fully deployed position.
Okay, I'm rotating R1 BDS.
Hey, Jenny, where would you like me to go?
Checking.
The R1 BDS is fully deployed.
Okay, copy, Tomas. You can give SSRMS a go to maneuver to the nadir back-off position. We'll be preparing for IROSA release. If you need a GCA prior to taking the comm, I'll give next steps to Shane.
Okay, I don't think it's a GCA, Mark, unless you need...
Nope, not a GCA. Once we get your go, we'll start that motion.
Love my go.
And we're working it.
Your go.
Please. motion.
Copy.
Two hours, 50 minutes into today's spacewalk by Tomas, Pesquet, and Shane Kimbrough. The bolts holding the first of the two ISS rollout solar arrays have been disengaged. The boom deployment system handles have been properly configured. You see Tomas Pesquet in this view with the red stripes on his suit at the end of the station's Canadian-built robotic arm in a foot restraint as we await the actual release of this solar array from its flight support equipment structure.
And Shane, we're going to send you back to the crew lock bag, which is on the nadir outboard side of the FSE. That should set you up well for the next steps at the crew lock bag, and you should also be able to get in a good position to look at the base of the root beam of the upper IROSA.
Okay, and Jenny, I just got an audible warning. I got nothing on my DCM. It's blank.
Copy of blank DCM. We're looking into it.
Did you status it?
What's that?
Did you status?
I can't see anything. It's blank. Like it's off.
Yeah, but if you status it, it stays blank?
Yes.
Yeah.
Shane, confirm that your DCM is still blank after the status.
Correct.
Copy.
Looks like it's off.
Contrast to max.
It was on 5.
And Shane, whether you go forward or back on that switch on your DCM, it's the same result?
That's affirmative.
Copy.
Mark, are we still moving? I have a hard time actually realizing because it's slow and it's at night.
Hey, Tomas, yeah, I think we're setting up for a joint OCAS, and once we're sure that Shane's okay as well.
Okay, sounds good. So for now, we're staying in that position.
And we're going to set up the joint OCAS, but we won't execute it until we confirm with everybody that we should.
Sounds like a good plan.
Ground copies, we're working it. Shane, can you check your display intensity knob, and turning it to the left should increase it.
Okay, yeah, just take a look, but I'll see that again. Okay, it's fully to the left and nothing.
Copy, Shane.
You want me to scare this 12-inch socket?
Checking.
All right, Tomas, we are going to do the first of 3 joint OCASs. This one will be 2 minutes long, starting that motion.
Okay, and Jenny's on board with that frame.
Shane, you can stow
Now the ground told us that we should do that.
Okay.
Shane, you can stow the PGT on the tower handrail. No socket swap required. We're still working your suit issue.
Okay. In motion.
Additional words for you, Shane. We're going to put the socket back on the socket caddy while we're working this issue.
Where do you want the PGT to go?
You just temp stow it on the tower handrail.
Okay.
Tomas, we're set up for the second of 3 joint OCASs.
Copy.
And Shane, just checking in with you. We're still talking about that suit issue. Hopefully we have words for you shortly. Understand you're working the socket?
Yep, the PGT's on the handrail and working the socket now.
Tomas, we're starting that second of 3 joint OCASs. This one is 3 minutes.
Copy, I'm ready.
This is Mission Control Houston, approaching the 3-hour mark into today's spacewalk. The view of Tomas Pesquet in a foot restraint at the end of the Canadarm2 robotic arm as he is poised to begin the extraction of the IROSA roll-up solar array from its flight support structure. However, a couple of data dropouts have been noticed in Shane Kimbrough's extravehicular mobility unit suit. associated with his sublimator, which provides cooling for the suit, and the display control module that provides him with an observation capability for the data that the suit is producing. This may only be instrumentation at this point, but we're double checking to make sure that there's no issue that would prevent the array itself from being extracted from its flight support equipment.
How you doing, Tomas?
I'm doing good. I'm passing right overhead from you. Doing cool.
Shane and Tomas, I have a big picture update for both of you. We are not committing to releasing IROSA from the FSD at this time until we have a really strong lock on exactly what is happening with your suit, Shane. So we're working that problem still down here. Just so you know, the next steps would be getting Tomas into position to release the IROSA, and we're not going to move ahead with that until we know exactly what's going on.
Okay, that sounds good, Jenny, and let's post it.
Copy all.
And Jenny, just for my say, if we had to do a warmer start on Shane's DCM, you would have to go back to the airlock and hook on the FAU, correct?
We're talking about that now, actually. I'll be able to let you know soon.
Yeah, sounds good.
Spacewalk communicator Jenny Seide here in Mission Control, providing the two spacewalkers the big picture as we are at the point of releasing the IROSA solar array, but it is contingent on the flight control team being comfortable with the condition of Shane Kimbrough's suit and his ability to read data from his display control module, which is essentially a menu of suit system status that he has access to right in front of him to be able to monitor the condition of his suit, just as the flight control team here in Mission Control can monitor all of the systems for both Kimbrough's suit and Tomas Pesquet's suit.
Well, we just finished that last joint OCAS. We are setting up for the next motion, which would be a GCA, but we'll talk about that in a moment.
Yeah, it sounds good, and I'm right overhead the IROSA, and yeah, for your words on the GCA. I see you.
Hi, Shane and Tomas. I have next steps and an answer for you on the suit for now, Shane. What we are going to do is have you return to the airlock at this time and connect to the SCU for a warm restart. Then we can assess the sublimator P issue, but we think that that will at least help us diagnose and get a good feel for exactly what's happening with your DCM. Tomas, we are going to continue with the nominal procedure and hold until Shane is back and we sort out what's happening with his suit.
Copy. All right. Sorry, Shane, that you have to go back by yourself. No problem.
The words from Spacewalk communicator Jenny Seide to the crew outside the International Space Station. The decision by Flight Director Ron Spencer here in Mission Control to have Shane Kimbrough return for a few minutes back to the Quest airlock to hook himself back up to an umbilical and do a restart of the display control module, which is a data center, if you will, attached to his extravehicular mobility unit. Ron Spencer, with his back to the camera in the blue shirt, Drew Feustel, veteran astronaut and veteran spacewalker, talking to Spacewalk lead officer Keith Johnson in the back row. As they prepare for the next set of steps, this is essentially a diagnostic effort to restart this display control module, which is important, providing data to the crew members while they are outside in the void of space.
Hey, Tomas, we'll tag up. Actually, we can tag up right here. So Houston Station on 1. Just want to make sure we're in sync. We're going to go ahead and execute step 12 of the robo procedure to get Tomas to the IROSA Zenith manual maneuver, or IROSA Zenith position, and want to check with you all before we press.
Yeah, Station Houston, you are correct. We'll have you finish up 11 and 12. That would have us in a good position if we were needing to execute any additional steps to assist Shane, but for now that also puts you in a good position to continue procedures, nominal procedures. And Shane will go back to the airlock. We'll get him on the SU. We're going to check out a restart on the DCM, and we'll go from there. So we think that puts us in the best config to sort out the problem and then decide if we're going to carry on. Shane will be in a safe place.
Okay, Tomas, we're standing by for your command for the GCA.
Okay, and Mark, just to clarify, you confirmed that in case I had to go assist Shane, I would have to egress the arm here at the FSC and climb down on the pull-off. Is that correct? Or climb down on a cedar cart?
You would provide this GCA and then egress the APFR in order to assist EV2.
Because there's really not that many good handrails for me to egress at the FSC. I mean, on that phase that I'm on. I think it's doable, but I think better egress would be at a cedar cart before we started all this. But okay, now that we're here, I'm ready for GCA to the FSC.
We copy all, and we understand we're putting ourselves in the best position. Copy your comments about the necessity to get off the arm if we are in that case, Tomas. I just want to remind Shane, again, heading back to the airlock, about that adjustable, which is on the thermal cover that he's going to have to remove in order to get back in there and connect to the SCU.
Copy. Thanks, Jenny.
This is Mission Control Houston. The big picture here is that Shane Kimbrough is in absolutely no danger whatsoever. He is fine out there, just simply making his way back to the Quest airlock, to the crew lock section. We'll hook his suit back up to an umbilical and do a restart of the display control module, which is a data center, if you will, providing information to him while he's outside of the International Space Station on the condition of suit systems.
$25 centimeters.
Copy. All
10.
Copy.
5.
And I think it's a good motion if you start the motion and call it GCA complete.
Nicely done. That's the position. Copy GCA complete. Brakes are on.
Your brakes are on.
Copy GCA complete. At this time, Tomas, we'll get you to standby.
Copy.
All right, Tomas, I'm getting to the seat of spur.
Okay.
And Shane, we're about 50 seconds from a handover. Now that you're getting up to the airlock, I'll tell you when we're back with you, but we're going to have you ingress the airlock and hook up to the SCU. We'll be with you to perform a warm restart after the handover. And Tomas, if you want to follow along, we're on page 28 of the CUF checklist.
Copy 28, one more stop for CUF failure.
Copy all.
This is Mission Control Houston, 3 hours, 13 minutes into today's spacewalk by Pesquet and Kimbrough. We've temporarily lost our downlink from the International Space Station as we hand over between satellites on the Tracking and Data Relay Satellite System. Shane Kimbrough is almost back at the Quest airlock, where he will enter the crew lock section, put a suit on an umbilical, and do what is called a hot restart of his display control module. This is essentially a data box on the suit that provides suit data for him and other spacewalking crew members while they're outside of the International Space Station. There were some intermittent dropouts of data, and we want to make sure that that suit is providing cohesive and continuous data for the crew member outside before we press ahead with Pesquet, removing the IROSA solar array from its flight support equipment located on the truss of the station. All of the bolts have been released for that IROSA array. The next step, assuming everything goes as planned with the restart of this display control module, would have Pesquet removing the array from the flight support equipment and moving it at the end of the station's robotic arm over to the P6 truss, where he and Kimbrough would then work in concert with one another to install it at the base of the P6 solar array.
Hi, Jenny. I'm connected to the RCU, and I'm on page 28.
Okay, copy, Shane. So we're going to perform a warm restart now that you have that cuff checklist page open. And again, that's page 28 for Tomas to follow along. You will not be performing that cuff checklist. I'll be talking you through it. In a warm restart for comm failure, I'll lead you through the following steps, which will be step 4.3 to the end of the page to reset your DCM display. If you unexpectedly lose comm or encounter any issues, you can use the cuff checklist to complete the response. In this procedure, the fan and power will be taken off OFF for 7 seconds. While the fan is off, you'll be without cooling and CO2 removal. Overheating and loss of visibility from fogging are possible, and there will be no comm until you take the power back to BAT. If fan operation is delayed or not restored, or power is not restored after switching back to BAT, open and lock the helmet purge valve to restore vent flow.
Copy.
Okay. Take a moment to confirm power and fan switch access. The specific actions will be to switch fan off, OFF, switch power to SCU, wait 7 seconds, switch power back to BAT, and switch fan back to on. When complete with the warm restart actions, all switches will be toward you.
Okay, copy, Jenny. I'm going to go in this order. It'll be, I'm not doing it now, but I'm talking through it. Fan off, power to SCU, wait 7 seconds, and then power back to BAT, and fan on.
Copy. That's correct.
Okay. Let me know when you're ready.
Look up. Okay, Shane, we're ready for those steps, so you can switch fan to off OFF. Expect fan switch off tone, 7 seconds.
Okay, Jenny, hopefully I'm back with you.
Copy. We have you loud and clear.
I have in status, so I have things on my DCM now, which is great.
Copy. You have things on your DCM. That's good news. And Shane, we're just talking the other issue you had, the sublimator P issue.
What you guys saw down there was sub P.
Say again, Shane?
What you saw, sublimator P.
Yeah, we're just talking on the other issue that we had, but I'm glad that you can report that your DCM's back.
He talked to me about the sublimator P because I obviously didn't see it. That's what I got.
We're talking. It's still Shane. I'll have something for you soon.
Okay.
This is Mission Control Houston, 3 hours, 22 minutes into the spacewalk. Shane Kimbrough back in the Quest airlock, standing by for further words.
Comfortable with your current position with your DCM. We did see a spike in sublimator pressure. And we're looking at the data now and still analyzing whether we want to push forward with removing the IROSA from the FSE, but things have leveled off for now. So we're still looking at that, and we'll keep you updated. For now, with a good config on your DCM, we're going to have you head back out to the work site.
Okay, copy that.
So those words from Spacewalk communicator Jenny Seide, returning to the Quest airlock, did the trick in restarting his Kimbrough's display control module, which is essentially a data box on his extravehicular mobility unit spacesuit, providing suit data for him while he's outside of the International Space Station. You're looking at a view from Kimbrough's helmet camera as he will now remove the umbilical that he hooked himself up to a moment ago for the restart of that so-called DCM, which is the acronym for Display Control Module. The other issue that we're taking a look at is pressure in the suit's sublimator, which provides the proper cooling for the spacesuit. There was a momentary blip in data a short time ago, and that's under analysis by engineers here in Mission Control, and that will be a determinant factor in whether we proceed in removing the IROSA solar array from its flight support structure on the truss of the station. This view of Shane Kimbrough now re-emerging from the airlock, and he will go out to the support structure on the port truss of the station to rejoin Tomas Pesquet and await further words from the flight control team here in Houston.
And Shane, understand you're working on closing the thermal cover at this time. We're also going to have you power cycle your HECA when you have a spare moment. So on and off, and confirm you have a green light.
Okay.
Tomorrow, an update for you. Again, we're holding prior to releasing the IROSA from the FSE. We've still not made that decision, and we want to be really safe before we make it. The next step I have for you would to be attach a RET to the microsquare, the scoop on the microsquare. We'll hold for that for now, but I will take a glove inspection and a hat check.
Good. Gloves are good. No change. Park is right. I copy. The next would be a RET on the scoop that's on the microsquare.
Copy. Those are good checks, Tomas.
The thermal cover is closed. The adjustable is in place.
Copy, Shane.
All right, Tomas, I'm on the seat of spare heading your way.
Okay. I'm right where you left me, Shane. Anything else? Quite literally.
All right, Shane, we have next steps for you. We're going to be back in the cuff checklist to address the Sublime P message. We're going to have you pause your translation here, put down a local, and then I have a page for you. We're looking for page.
Okay, Jimmy, I got a local.
Copy, we see it. Page 1919, Sublime P. We'll have you start step 1.
I'm there. Okay, I'm there. So we turn my water off.
Affirm.
Check water. Okay, comes water off.
Copy.
I just got a water off message. That's expected.
Affirm.
Okay, so your statement, no. And let me check the sub P out.
Affirm.
.7. What I'm showing.
Copy, Shane, 1.5.
1.5.
Copy. It'll take a little while to stabilize, so we'll hold here and see what we level off at.
Okay. Okay, it's below 1 now.
Copy. We'll give it another 20 seconds.
All right, it's 0.6.
Copy, 0.6.
0.5 now.
Copy, 0.5.
Let me continue step 3.
Checking.
0.3 now.
Copy. We're still looking for that to stabilize, so I copy 0.3. Let's give it a little longer. All right, Shane, let's push with step 3. If you give me a reading, we're comfortable with you setting your TCV to max hot.
It's max hot. Water coming on. Ready for that?
Ready.
Okay, water is on.
Copy.
TCV is set.
Copy.
How you doing out there?
Good, Mark.
Thanks.
Thanks for checking. Jenny, am I clear to head back out?
You are. We were just talking that down here, and if your cooling is sufficient, we can continue. Thanks for those checks, Shane.
Yeah, no, thank you, guys. Okay, I'm going to head back out.
Copy. And you're both doing a great job. We just want to be super safe here. So well done.
Understand. Yep.
Tomas, checking in with you. How are you doing?
Good, thanks. Just waiting on Shane, no rush, and I'm here, good config, good position. Everything's fine.
Copy. Glad to hear it. Thanks, Tomas.
It's a mom at the FHRC. Yep.
Shane, once you're back on the FSE, we'll send you to the tower handrail.
Okay, copy.
I see you coming back, Shane.
Here's your green hook, I see it.
This is Mission Control, Houston. 3 hours, 36 minutes into the spacewalk. Shane Kimbrough now back outside of the Quest airlock after spending a few minutes on an umbilical to perform what is called a warm restart of his data display. That's a display control module, or DCM by its acronym, that provides him suit status and other data information about the condition of his suit. The other thing that has been discussed here in Mission Control and with flight control engineers is a temporary blip, a quick spike in the reading of pressure for his suit sublimator that provides cooling for his spacesuit. It appears as if that has now stabilized. The discussion currently underway before we commit to removing the IROSA solar array from its flight support equipment structure is whether or not the sublimator now has stabilized and whether we have confidence that this is only a sensor issue perhaps and not a real issue with the sublimator itself.
Since we have you back at the tower handrail, again, you'll be retrieving your PGT, so the green PGT. But first, before you do that, we're going to have you cycle your HECA again. So power cycle on and off and confirm a green light.
Off, no light. On, green light.
Copy, green light. Shane, we're just wanting to get a couple more data points on the DCM issue. Had you checked your DCM at all since the depress and exiting the, egressing the airlock?
I don't think I looked at it, no.
Copy. That's what we figured. We just wanted to double check if you'd looked at it before you got that message.
Okay, I've got the green PGT Reddit to my swing arm, and I'm putting the PGT in the swing arm.
Copy. The PGT is on your swing arm. Could I confirm, I gave you this step before, but we did have that suit issue, so confirm that the square scoop from the crew lock bag is on your mini workstation?
Yes, it is.
Okay, copy. We are going to get you in position at Charlie 1, which is at stanchion Charlie, Zenith outboard.
Okay, I'll head there now.
And Shane, another point of clarification. Before the DCM went blank, did you see the message pop up or you heard a tone?
All I heard was a tone. I never saw a message.
Okay, copy. So you never saw a message. We understand.
Yeah, that's why I was wondering how you maybe saw a P, because I didn't see it.
Copy.
Okay, I see C1.
Copy, Shane. And just so you know, we saw a spike in the sublim P data. That's why we're talking about that.
Okay.
And Shane and Tomas, big picture, we're just getting a final confirmation that we are in a good config to release this IROSA.
Copy, JD, thanks. I'll get set up here tomorrow.
And Shane, I have a go back for you. When we got your issue, we were sending you to check the status of the indicator on the base of the root beam. We've still not gotten that check, and we need it prior to releasing anyway. So while we're talking this down here, we're going to send you to check out the base of the root beam close to the R bolts. See if you see that indicator. It should be just further away from the blankets than the handrail.
Is it on the end I'm on now or the other end? Or the other end?
We're going to have you do that right now because the position that you're in now is to release IROSA.
But Johnny, just to be clear, the indicator is at the nadir end of the upper IROSA. That's where you want Shane to go.
Yeah, we want Shane to head to a position where he can see the blanket end, the boom end of the upper IROSA. He's going to be looking on the root beam.
Yeah, and that's nadir.
A-firm.
Okay, I see the little thing sticking out the bottom on both sides. Is that what we need to look for? Yeah.
Yep, that's exactly what we need to look for. That sounds like a good check.
I don't know if you can see it in my helmet camera.
We're looking.
I see two silver things, one on each It looks like.
Copy, Shane. I'm just checking for next steps for you. All right, Shane, thanks again. Those are a good check on those indicators. We're going to send you back to position at the final bolt. Stanchion Charlie, bolt Charlie 1.
This is Mission Control Houston, 3 hours, 45 minutes into the spacewalk. We should be hearing big picture words momentarily from spacewalk communicator Jenny Seide about proceeding with today's activities.
On that square scoop yet?
Yep, that's right, Tomas. It looks like we're talking about releasing IROSA, but I don't have the go yet. So we are still holding at this point. All right, good news, Shane and Tomas.
Settings for me, just in case we do.
We are go for our IROSA release. I have next steps for you. What was your last?
PGT settings.
This is Mission Control Houston. So to recap where we've been for the past hour, about an hour ago there were two separate issues technically with Shane Kimbrough's suit. One involved a loss of data to his display unit called a display control module, or DCM, that provides any spacewalker with insight into the condition of his suit while out in the void of space. He was ordered to return to the Quest airlock. He went back on an umbilical, did what is called a warm restart of that display unit, and it came back to life. The other issue has been the evaluation of a momentary, minor blip and a spike of pressure for the sublimator unit in Kimbrough's suit, which provides cooling for the crew member. That sublimator reading spiked ever so slightly for just a moment and then returned to normal. So after a series of tests with that equipment, the suit is holding steady and is apparently in good shape now, and Flight Director Ron Spencer has directed that we proceed with the spacewalk as planned, Kimbrough's suit in good shape. He was never in any danger during the course of this diagnostic evaluation, while Tomas Pesquet, as you see on the right-hand side of your screen, has been hanging out in a foot restraint at the end of the Canadarm2 robotic arm, waiting for the green light to proceed with the extraction of the ISS rollout solar array from its flight support equipment.
Cooling and glove heaters are good. I'll keep the divers down for now.
Copy. Ensure your heels are secure in the APFR and your gauntlets are down.
Yeah, the heel seems secure. I'm sure Shane can have an eye on them, but it's all good. And gauntlets are covering the restraints.
Copy. Maintain control of IROSA while Shane releases the final FSE bolt and installs the scoop and repositions for your upcoming GCA. You can give them a go when you're ready.
Let's have a hand on the hinge. And I have control of IROSA.
Hey, Tomas, I'm going to drive the bolt.
Go for it.
How many turns am I looking for?
24 to 26. The bolt will spring out when released.
Copy. Okay, there's 24 turns. I'm going to give a few more on it.
We copy 24 turns, and you're giving it a couple more.
Okay. Put away, come on, I'll get this scoop set up for you.
I copy Charlie 1 is fully released. Was that any more than 24 turns?
Yep, 27.
Copy 27 turns. So you're stowing your PGT, and you're right, you can install the square scoop. Make sure the handle is pointing zenith toward Tomas.
Okay, where's it at, Tomas? Near your hand?
Oh, no, it's near your hand.
This guy right here?
Yeah.
Okay, got it. Seems a bit far away for you, that's what I was asking.
Yeah, it is. It's actually wide. And the other one is on my far left. This one is on my far right, but it'll be okay. Whoa, don't push too much. I think you got it off. Got it off the hinge.
Sorry about that. Unlock. Do you have it?
Yeah, I have it.
Sorry about that.
No, don't worry. I have it.
Get my red off of this.
Don't pull.
Yeah, you want my red off, okay. All right, I'm clear.
Okay.
Yeah, it's definitely off. Taking off, easy.
And I copy that IROSA is off of the FSE. Shane, I need you to remove your ret from the scoop and get in a position to monitor the clearance of the blanket to the grapple tower fixture.
That is done, Jenny.
So ret's removed. I'm going to go to the nadir side here to get a better look. Okay, I'm in a good position. And so Mark and Megan, I think we're ready for you guys.
Copy, go for the upper IROSA back off. We're getting into mode.
Okay. Tomas, you look good right there.
Yeah.
You get about 10 centimeters clearance to the tower. How's it feel?
Oh, it's a big RU, but it's okay.
All right, cool.
Okay, we're getting ready to start this manual maneuver. It's not a GCA, and again, I want to check for your go.
I'll go, Mark.
Starting motion. I know it's hard to tell, but the motion has started.
Good motion.
And again, we're backing away from structure, so it's not a GCA. You can talk about other stuff.
Understood. Shane, we just want you to keep an eye on the tower grapple fixture and the clearance with the top of the IROSA blanket. Let Tomas know if he needs to adjust it in any way to clear.
I'm tracking, thanks. Looks really good right now.
This is Mission Control Houston. We're closing in on the 4-hour mark in today's spacewalk. To bring you up to date, the two spacewalkers, Tomas Pesquet and Shane Kimbrough, put their suits on internal battery power at 7:11 a.m. Central Time, 8:11 a.m. Eastern Time to begin work to release and install at the P6 truss the first of the two IROSA or ISS rollout solar arrays delivered to the station 2 weeks ago on the SpaceX Cargo Dragon vehicle. The most of the work throughout the day has been the use of a pistol grip tool to release a series of bolts that were essentially launch restraints for the array, the first of these two arrays, as they sat in the flight support equipment that you see Tomas Pesquet hovering over at the end of the Canadarm2 robotic arm. About an hour and 10 minutes ago, two issues were detected with Shane Kimbrough's suit, not yet fully explainable. One was the loss of data on his display control module, which is essentially a data box on his spacesuit that provides information about the condition of his suit systems. The other issue was a momentary blip in sublimator pressure, the sublimator being the device in the suit that provides cooling for the crew member while outside in the void of space. Kimbrough was directed by flight controllers here in Mission Control to return to the Quest airlock. He hooked up an umbilical in the crew lock section of Quest, did a restart of his display control module data package, and it came back to life. And he recharged his sublimator, and that seemed to stabilize the situation, with rock-solid readings now being received both on suit data and the sublimator in particular. So Flight Director Ron Spencer directed Kimbrough to go back outside, rejoin Pesquet at the IROSA array flight support equipment, and we are now standing by for the release of that IROSA array from the flight support equipment, where Pesquet then will transfer manually the array from the flight support equipment over to the work site at the P6 truss on the far left section of the truss of the International Space Station to begin its installation and deployment.
So Jenny, to answer your question, it's clear of the tower.
Okay, copy, and I'm back with you after a short handover there. That's a good report. Clear of the tower. We're going to push you to next steps, Shane. We're going to get a glove and hap check from you now.
Okay, left glove good, right glove just a few of those black smudges on there, but no damage to the glove. Hap is dry.
Copy. And so you know, Shane, we're monitoring your suit data, and everything looks as expected. So with that, we are going to have you retrieve the socket caddy from the crew lock bag.
Okay, great.
And you will be removing the 5/8 12-inch socket from your PGT and stowing it back in the caddy.
Come on, have a good ride. All right.
And Shane, you'll be installing the 5/8 2-inch socket on your PGT.
Tomas, we are setting up for a couple joint LCASs.
Copy, I'm ready.
Okay, good pull test on the 12-inch on the socket caddy.
Copy. Good pull test, 12-inch on the socket caddy.
And Mark, keep me posted on the motion, because it's hard to tell actually when I'm moving and when I'm not in the dark and with those rates.
Completely understand that as a timely call, where this is our first of 2 joint LCASs. This one will take 2 minutes starting motion in course.
Copy. I see good motion, I can tell it's in course.
If you need us to stop, just say the word.
For now.
Affixed to the end of the Canadarm2 robotic arm, Tomas Pesquet holding the 750-pound IROSA solar array, the first of 6 such augmenting arrays that will be installed on the International Space Station to enhance the power capability for the complex for the rest of its lifetime. He will be driven over to the P6 truss worksite. Megan MacArthur is at the controls of the robotic arm, being assisted by Mark Vandehei from a robotics workstation inside the Destiny Laboratory of the International Space Station.
EDT on my PGT, good pull test.
Copy. You can stow the green PGT on your swing arm, and then we will have you retrieve Tomas' green hook.
Okay.
Set up that second joint LCAS, Tomas.
Copy, I'm ready.
Tomorrow we're starting the second of 2 joint OCASs in course. This will take 3 minutes.
Copy, 3 minutes in course. I'm ready.
Course started.
Yeah, I'm off the FSC, going to get Tomas green hook.
Affirm, Shane. When you pick up that green hook, make sure you attach it to a waist tether, D-ring extender, or your green reel.
Okay, copy. Okay, got the green hook on my D-ring, left D-ring extender.
Copy, and check the reel is unlocked, and you can continue upward.
Checking. Reel is unlocked and I'm heading outboard.
Copy. You're looking for the first handrail outboard of P5. So that's P6 handrail 5309, and we're going to drop green hooks at that location.
Tomas, that joint OCAS is finished. We're working on setting up for a manual maneuver.
Copy.
And Shane, I'll take a gauntlet check as well.
And Station Houston for the EV and
Gauntlets are in position.
for EV and IV crew, just a heads up. Tomorrow you're likely going to be in position. We'll need to stand by on the manual maneuver until Shane is ready for the handoff. So we might be a little waiting here.
That sounds good. I'll just say.
And robotics copies as well. We're waiting for your go.
Copy all, and we copy the gauntlets checked, Shane.
Good, Tomas?
Doing good. I'm in position, Shane. I see your APFR from here. I'm in the dark.
Oh, you're already there.
Yeah, I'm already there.
Sweet. Okay, I'm at 5309. That's where I'm going to put your green hook down.
Good words, and check the reel is unlocked.
Okay. Okay, green hook is on 5309. Copy. Wheels unlocked.
Copy. And you can attach your green hook, Shane, to 5312.
Okay, I'm on 5312, my green hook.
Copy. And we'll check your reel is unlocked.
Okay, you're talking green hook reel?
Affirm. You're going to attach your green hook 5312 and check the reel is unlocked.
Yeah. And both are unlocked.
Copy. I have a big picture update for both of you. So at this point, we're working to get IROSA installed on the mod kit and unfolded. We believe in the next eclipse we will have time for our connections, and then we'll assess deployment following that.
Okay, thanks, Jenny.
Copy.
No problem. And Shane, as written in the procedure, your next steps would be to do some worksite setup, including dropping your PGT on the mod kit. But considering that the arm is already in position, we're going to skip forward a couple of steps and have you translate just outboard of your APFR in WIF 18.
Okay, copy that.
Essentially, we're just skipping those
I'm
setups.
there now, but let me get in a better position.
Copy.
Yeah, so you're looking good, but your space together is behind your place. Yeah.
All right. Thank you.
And Shane, could you double check your
turn
left?
towards your left shoulder.
Shane, double check your left gauntlet, please.
Okay, will do. Oh, you want me to rotate to the left?
Yeah. Do 180 to your left. Be right there.
I don't know if I can do that from here.
Oh, you'll have to go. When you do APFR ingress, going to be okay if you go towards your right. Like around the APFR, your right.
Okay, to my right. Clear it there, right?
Yeah, I think it's clear good.
Yep. See it now. You want to get my gauntlet down on the left? You can see about that.
Copy.
Check what's pulling it. It's going to take a little more time. Just a second. for now.
Copy, Shane. Your next step is to put in a fair lead in your safety tether, just outboard of your APFR.
Okay.
We're looking for handrail 5345, which is on the MMOD side.
That's out in sight. Alright, and I guess I'll use a rep for this since my adjustable's gone.
Is your 4-man?
Yeah, Shane, we're thinking this is just a poor man to deconflict your safety tether for the APFR yaw. Just so you guys know, 15 seconds to hand over.
Yeah, I'll just put it right on it. Takes a long to get over there, Tomas.
I'll be happy to pass it on to you and
Back with you after handover. Next step for you, Shane, provided that fair lead is in, is to verify roll and yaw settings. Let me know when you're ready.
Okay, I'm ready.
Looking for Fox 4.
Copy. Box 4 is verified. Got to get the
I'm ready for you to ingress the APFR.
side out. We're stuck on there pretty good.
This is Mission Control Houston, 4 hours, 17 minutes into the spacewalk today by Tomas Pesquet and Shane Kimbrough as we regain our downlink television capability from the International Space Station. Pesquet has finished his journey at the end of the Canadarm2 robotic arm holding the IROSA solar array. Shane Kimbrough is putting his feet in a portable foot restraint on the P6 truss, ready to receive a handoff of the array from Pesquet, while Pesquet then will dismount, if you will, from the end of the robotic arm to put himself in a position to assist Kimbrough with the installation of the IROSA array on the so-called mod kit, which is a bracket upon which the array will be mounted and bolted into place. That mod kit was installed at the base of the P6 array on a previous spacewalk.
Okay, I'm in.
all right.
Ingress 8 is tucked in.
Copy. You are in the APFR and the ingress aid is stowed. I have some other checks for you. Make sure your tools and tethers are clear.
Okay, tools and tethers are clear.
We have about 12 minutes until installation, so make sure your visor, glove heaters, and cooling are set.
Okay, I'll put my visor down. And Everything else I'll keep.
Copy. Ensure your heels are secure in the APFR and your gauntlets are down.
Those are secure. Gauntlets down. Now it's coming back up again. I'll fix it. Okay.
Yeah. No further action on your left gauntlet, Shane. We're satisfied there. I think those are good checks. So you can work with SSRMS to move IROSA in proximity for the handoff.
Okay, Megan and Mark, I'm ready for the handoff position.
Copy. This is a GCA to a published. It'll be 1.7 meters body in for Tomas. And Shane, we don't have any good clearance views for the IROSA itself, so we're counting on you for that. And we'll start the GCA on your command.
I am ready for the GCA.
And I'm ready for GCA. Start motion.
It's a good motion.
Roger, tell.
Copy. Good motion from Tomas.
And I see good motion now.
Good motion from Shane.
With Mark Vandehei providing visual cues, Megan MacArthur is maneuvering the Canadarm2 robotic arm very slowly, very surely, to put Pesquet in the right orientation to hand off the IROSA roll-up solar array over to Shane Kimbrough. Kimbrough's suit is performing normally, following a brief interlude in the spacewalk as we analyzed and dealt with two separate technical issues. Kimbrough was never in any trouble, never in any danger. His display control module unit lost data. He was ordered to go back into the Quest airlock by flight controllers to get on an umbilical to restart the control box that provides suit data information to him while he's outside in the void of space. That all worked fine. And flight controllers then evaluated a temporary blip in sublimator pressure, the sublimator being the unit that cools the spacesuit for a spacewalking astronaut, and it has held steady ever since.
What are you thinking about rolling this tomorrow?
I think it's going to be okay, but not now.
Yeah, I'm just thinking which way you want to go.
Oh, it doesn't matter for me.
Here to go. .50 centimeters.
Okay. Yeah.
Pull it a little bit towards you, Shane, because I'm counting all the way to my back arm.
I have a hand on it now.
Okay.
Can we put a red on?
Not yet.
Okay.
I think now the IROSA is not moving, it's just me going back in the arm. I think we could stop here.
Stop there, Mark.
Okay, we are stopping motion.
Copy. You happy with your control, Shane, at that position?
Yeah, I'm going to have to move it a little bit, obviously. We're going to rotate it, right?
Yeah.
Do you want to keep your red on? And
while we're rotating it, I can keep my red on, or you can put yours.
I'll put mine on, too.
All right, is that a good position? Can we call this GCA complete?
Complete.
Copy, GCA complete.
Ground copies, GCA complete. A warning for both of you, don't put your fingers.
Red on it, Tomas.
Go ahead, Jenny.
I need to read you guys a warning not to put your fingers in the IROSA pin slots. Other than that, you are go to perform your ret swap, and you guys are exactly right. You are going to be reorienting IROSA to blankets heads up position and transferring control to EV2.
Yeah. I'm going to remove my red, Shane. You have a red on it.
I have a red.
Which I'll keep it really, really stable.
It looks like it's straight to you, but we'll rotate since it's biased to me a little bit. To your left.
Yeah, to my left, to your right.
Okay. Ready?
No, I'm removing my red. Stand by.
Okay.
Now my red is gone. My left to your right, really slowly. You ready?
Ready.
Going.
Mass.
Zoom. Slowly.
Yeah, I have it, Tomas.
You have it? Is it in the right orientation for you?
Yes.
Okay, you have control.
I have control.
I keep it really stable.
Ground copies.
Right. And Mark and Megan, I'll be happy to go to the egress back off position now.
Copy, Tomas. Sound like the ground had something for you. All right, nothing heard. We got copy to go for the post handoff back off.
Copy.
Start in motion. Not a GCA.
We'll see you in a minute, Tomas.
See you in a minute. Feel good motion.
Copy.
Doing good, Shane. Very stable.
Yeah, it's nice and stable.
Tomas, we are setting up a joint cast.
Copy. I'm ready.
Tomas, this is one joint OCAS in course. It'll take 3 minutes.
Copy. Ready.
This is Mission Control Houston, 4 hours, 31 minutes into today's spacewalk. Shane Kimbrough now has possession of the first IROSA rollout solar array. He is going to hang on to that until Tomas Pesquet has left the foot restraint at the end of the station's robotic arm. Pesquet hauled the array over from its flight support equipment structure on the truss of the station over to the P6 worksite. And now the two crew members will begin the installation of this array to the P6 2B channel mast canister mounting bracket, or a mod kit as it is called, that was installed to accommodate this first IROSA array on a previous spacewalk. The second of these two IROSA arrays for the 4B channel on the P6 truss is scheduled to be attended to by Pesquet and Kimbrough during the next spacewalk that is scheduled for Sunday.
Well, we just finished the joint OCAS. We're setting up for the manual maneuver.
Copy.
This one eventually will be a GCA.
Yep. I'm ready when you're ready.
All right, Tomas, on your go, we will do the GCA to the published egress manual maneuver position, which is 4 meters, body in.
Go for 4 meters, body in.
Okay, we'll call that start GCA, starting motion.
Second motion.
And Tomas, was that good motion?
Yeah, that was good motion.
Continuing.
A good view of European Space Agency astronaut Tomas Pesquet being maneuvered at the end of the Canadarm2 robotic arm by Megan MacArthur with assistance from Mark Vande Hei at the robotic workstation inside the International Space Station to an area that will enable him to leave the portable foot restraint at the end of the arm to assist Shane Kimbrough with the start of the actual mounting of the IROSA array on the P6 truss 2B channel mounting bracket.
Copy, continue motion.
Continuing.
How you doing, Shane?
Sounds like you're almost there.
Yeah.
One meter.
Copy, continue.
.50 centimeters.
Continue.
.25.
Yeah.
Centimeters.
Yeah.
5.
And stop motion.
And stop in motion.
GCA complete to good position.
Copy, GCA complete. Brakes on.
Brakes on.
The procedure, robo procedure says SRS brakes on. Go for egress and APFR reclocking.
Copy.
Understand, brakes are on. You can egress the APFR, Tomas.
Okay. And I've egressed the APFR. I have a local, no truss.
Copy. Place a waist tether on handrail 5309 and lock it.
That's used by long waist tether. I'm not sure this one is long enough. This one's not long enough. I'm going to use my left.
Copy, Tomas. Our next step is to...
My left waist tether on 5309 and locked.
Copy. So that's your new load path to structure. Now we need to build back your tether pack. You'll need to reach your yellow hook from the SSRMS Lee. You might need to GCA to reach it. Let me know if you do.
Yeah, that would actually be nice to get 2 centimeters or few dozens of centimeters station zenith. Let's say 40 centimeters station zenith for the GCA.
Sorry, Tomas, was that for us?
Yes, that's for you, 40 centimeters station S for GCA mark.
The view from the HD camera on Tomas Pesquet's spacesuit, looking down at the Pacific Ocean as the International Space Station has entered an orbital sunrise at an altitude of 258 statute miles, now 4 hours, 40 minutes into today's spacewalk.
Copy, thanks.
I'm sure it's going to take a couple more minutes. Yeah, I heard, no problem.
All right, Tomas, we're going to call it a start GCA, 40 centimeters, body up on the hand controller.
Copy, start GCA.
Starting motion.
Good motion.
$20 centimeters to go.
Actually, you might even pass 40 centimeters. I'll tell you stop. Continue.
And that's what you asked for. You want us to continue?
Yes, please continue.
Say again, Tomas, was that a stop motion?
No, it's a continue.
How much farther would you want us to go?
20 more centimeters or 30.
20 centimeters, continuing.
Let's make it 30.
Copy, 30 centimeters, continuing.
Nice, and you can stop motion zenith. If you could give me a 20 centimeters station aft, that'd be great. Sorry to be demanding.
Copy, 20 centimeters, station aft.
Good read back. I'm going to have to recall this APFR.
Tomas, we're doing 20 centimeters, station aft.
Copy. I'm not sure I see motion. That's a good motion.
Good motion, thanks. 10 centimeters to go.
To the end.
Sorry, say again.
Continue to the 10.
Okay, another 10 to go.
And you can stop motion.
Stop motion.
Jenny, so my step is to retrieve my yellow hook, correct?
That's a
Affirm, Tomas.
You can set the brakes on.
You'll be retrieving your yellow hook.
ETA complete, brakes on.
I copy, brakes on. You'll retrieve your yellow hook and attach it to your green tether reel. And then I'll take your checks.
Okay, my yellow hook closed and locked. My green safety tether reel, she's unlocked. And my red reel is unlocked. And the red hook goes to my left dealing extender and it's locked black on black.
Copy. That is a good tether config. You can stow the ingress aid and fold it to the boot plate, and then we'll have you ret to the APFR and reinstall it with a new clocking.
Okay. Work. Okay, I have a red on the APFR.
Copy, Tomas. We're looking to reinstall that APFR with a clocking of 6. Shane, just want to check in with you. How are you doing?
Well, thanks, Jimmy. You know, from Here's magic.
Copy.
And the collar is very sticky. I have a hard time rotating it, working on it.
Okay, copy the sticky collar, Tomas.
Okay, I got it. It's a clocking of 6. Have a good pull and torque test. A good install.
Copy, Tomas. Retrieve your ret. Check your tools and tethers are clear. Around 30 seconds till handover.
Copy. Okay.
Back with you after handover.
The tools and tethers are clear. And I see the clocking of 6. You are go for the the back-off position, Mark and Megan.
Copy. Megan is doing that maneuver to the P6 back-off position.
Copy. All right, over to Shane.
All right, I'm ready.
Break on motion, standby.
Copy, standby.
Could we just get a double check on the APFR settings? We may have missed them, and we just want to verify that we're as expected with the clocking, new clocking and the other settings.
Clocking is at 6. And the other settings, it's Papa. There might be a bit of yaw, but it's less than 10 degrees. It's 10 or 20 degrees yaw. The English service are pointing towards the lee. I can fix that if you want, but I think it looks okay.
And Tomas, we need a yaw of Foxtrot.
Yeah, we have. Okay, I'll go back.
And the brakes are on.
Brakes are on. Hi, Shane.
No worries. I'll be here.
Okay, settings are 12, Papa Papa, Foxtrot, and 6. Correct, oh, that might be 12 for yaw. 6 is facing towards the lee.
Tomas, those are good settings. We are happy to continue.
Okay. Just want to check.
Tomas, we're still standing by for your go for the P6 backoff position. We want to make sure your tethers and rest of you are clear.
Yeah, not yet.
All right.
Marking now to go for the P6 egress backoff position.
Jenny, before we do that, it sounded like you wanted to chime in.
I wanted to tell Tomas that he can translate to EV2's APFR, and I have some warnings and cautions when he's ready.
Ready.
Let's start the motion.
Affirm.
Ready, Jenny.
Warning, there's a sharp edge hazard on the empty rail attachment lug near the 2 Bravo IEA inboard radiator corner, and another sharp edge hazard, the pit pins on the ticker and the sticker do not meet EVA kick loads.
Copy.
2 cautions, avoid contact with the deployed and stowed radiators, and the battery adapter plate cables on the IEA are a snag hazard.
Copy.
Okay, you will be incrementally yawing the boot plate of Shane's APFR to a setting of 10.
Copy. Incrementally yawing the boot plate to a setting of 10.
Hey, Tom, I'll feel you there.
Yep. Coming up. Shane, yaw your right boot.
Okay.
Station ready.
I'm ready.
I'm going to try and yaw you very slowly. Ready?
Ready.
Tethers depressed.
Still moving slowly. That's good pace. At the first slot.
Yes. You pitch the IROSA up, Shane. Pitch it up.
Fine.
Pitch it up.
Fine.
That's your first slot. Yes, here.
Okay.
Stop. You see clearance with the...
Action.
Sorry, I'm yelling the wrong side. My bad. So good.
You done?
I'm yelling you back to the outside. Back to your... I'm yelling you to your right. Right?
No.
Yeah. There's a solar right to your left.
Yeah.
Don't let the clearance to your left. Yeah, Jenny, can you double check me on this? The solar array looks really close.
We're checking now, Tomas.
I was going to the left, but it feels like the IROSA has to put the needle between what used to be, I think, the ticker and the solar array ring. Doesn't look good.
Copy, Tomas. We're glad you're letting us know we're talking it.
My heel still look good?
Yeah, no, your right heel is popped out.
Right it out.
Right.
Feels solid.
I'll try to put it back in.
On my left.
My left. Rotate inboard.
That's good.
No, it's not.
Alright. Now
Go deep. Still on the ledge. Go deeper. Now you go back. No. Back. Back. With your heel and then rotate. Too high. You're too high. The right heel is solid.
okay. Thanks.
not in. And you have to go back. Yes. Wait, you're in. Nicely done.
All right, you guys were talking what you mentioned down here, and we really don't have as good situational awareness on this yaw as you do, so your eyes are better than any camera views that we have. So we agree getting Shane to lean back is a good idea, but beyond that, we can't offer any additional views or clearances better than what you have eyes on right now.
Yeah, I understand that, Jenny. How about going in through his right shoulder? There's nothing there. Shane, what do you think of the clearance with the solar array?
I can't tell.
You can tell.
I can't see it.
It's right. Come to the solar array, right in like 10 o'clock for you.
I see the one below me, but I can't see the one above me.
The one pointing to the earth, you mean?
So towards my feet, I can see that.
You can see this one towards your feet, but not the other one?
Correct.
Okay, that's the other one that we have a clearance problem with.
And to confirm, you guys can go whichever way you choose here, where you have the best clearances. We just have to make sure that the tether is clear and that you have eyes on it.
Which tether you're talking about, Jenny? Shane's safety tether?
Yep, you can move to Shane's left or Shane's right to a setting of yaw 10. We just have to make sure that Shane's safety tether check, which you'll be keeping an eye on, Tomas, is clear.
Okay, Shane, how about I yaw you to your right?
Okay, and keep the same position?
Yeah, keep the same position.
Okay.
And we're going for one click.
Copy.
Going. It's one click.
Okay, let me ramp that out. Okay, I'm ready.
Second click. Oh, yeah,
Okay, let me ramp that out a bit. Okay, I'm ready.
Click.
That looks good. I can't see anything, Tomas. Another question.
What are you talking about?
Clearance look okay?
There's nothing there. You're in free space.
Copy.
Actually, it's the same, I think. Can't see to the solar array to your right. I mean, it is tight. Let's keep going. Anyway, you have to send it off to me over there, right?
Correct.
We copy, Tomas. You're saying you have the same clearance concern going in this direction.
Do you guys agree that this is a good clearance? I just want to be sure we're doing the right thing.
I'm checking for you, Tomas.
That's it.
Yeah, you might have to do one more and then go out and look at it.
Yeah. Let me look at the other side too. Sure.
Are we going?
No, we're not going.
Okay.
So our information is telling us that we do have the clearance. Shane can, again, lean back in order to help. But we should have the clearance to continue. If you really think it's no-go, that's a different situation because you have eyes on it.
No, I think it's going to be okay. Shane leans back, and we'll go really slowly. Okay, Shane, you ready?
Ready.
Okay, it's a little bit. Before one click.
Yeah, we're clear. Clear, at least on the corner. We just passed.
Yeah, I think it's really, there's a lot of clearance. Okay, that's a setting of 8. Okay, put you to 9.
Ready?
Copy all.
Lots of clearance, Jenny.
Copy.
It's going to be 10, sorry, 9. And Jenny, what's my final setting, just for sanity check?
Setting of 10.
So next click is the last, Shane.
Copy, I'm ready.
All right, here comes the click. You're at 10.
Okay, we're looking at your APFR. That's good.
Okay.
Well done.
All right, copy. We understand you're at a setting of 10, and as a sanity check, Tomas, that looks good for you for the alignment for the next handoff, correct?
It does. Looks great.
Excellent. We're really happy to hear that. Well done, you two. Tomas, you can double-check Shane's tether. All we're looking for there is for you to verify that it's clear and give him words about how to deconflict it when he egresses the APFR after the next handoff, and then I can get you to translate to your APFR.
Yeah. So your set tether is clear, Shane. It's kind of going back and around the APFR, and then to your lead, but that's not going to be a problem, I think.
Okay, thanks.
Copy all.
And now with that, I'm crossing over to the other side of the IEA.
A firm, you can fair lead around the IEA corner. Let me know if you need handrail numbers for that fair lead.
I think I'll be good, Jenny. Thanks.
No problem. You're headed just outboard of your APFR to fair lead before checking settings.
Yeah. I'm at the APFR.
Copy, Tomas. You'll be fair leading on handrail 5361, which is on the radiator side.
This is Mission Control Houston, 5 hours, 6 minutes into today's spacewalk. Tomas Pesquet is positioning himself at the far end of the P6 truss structure on the International Space Station, having joined Shane Kimbrough, ready to take a handoff of the IROSA rollout solar array back from Kimbrough. Pesquet handed the array off to Kimbrough after delivering it to the NASA astronaut while transiting at the end of the station's robotic arm that was being driven by Megan MacArthur from a robotics workstation inside the International Space Station. Now we're at the second handoff position where Pesquet will receive the array once again as the two crew members will prepare to install the array on a mounting bracket at the base, basically the mast canister portion of the P6 solar array truss structure.
Can I do it on 5358? It makes my life easier.
Copy.
That's going to be a 4-man fair lead.
Okay, firm. That's fine.
Which settings do you want on the APFR?
Fox 12.
Fox 12, so I'm guessing the clocking doesn't change. The pitch is India, India. It's on Fox 12.
Okay, firm.
So that's what it's at, Jenny. That's Fox 12.
Copy, good settings. You can ingress the APFR, Tomas, and I have a big picture update for both of you.
Copy. I'm ready, Jenny, whenever.
Okay, big picture is that we are just over 20 minutes until our working eclipse starts. So we are going to do this handoff, work on getting IROSA installed on the mounting bracket and unfolded. Then we'll assess where we are. We might jump straight to our cable connections if we are in that working eclipse, and then we'll come back to the bolts later on, and we're still assessing deployment at this time. The limiting consumable is 7 hours EV2 MEDOX.
Copy. Jenny has the good settings. Have a local tether to the APFR. Extended the English.
The big picture words from Spacewalk communicator Jenny Seide to Tomas Pesquet and Shane Kimbrough at the P6 solar array truss structure as they are about to enter a nighttime pass, during which time the connectors, the electrical connectors, can be mated to provide electrical continuity between the new solar array and the integrated electronics assembly, basically the guts of the electronic system for the P6 solar array power channels, those being the 2B and 4B power channels. We lost an hour while we were evaluating the condition of Shane Kimbrough's suit while he had to restart his display control module that had an issue of undetermined nature, and making sure that his cooling system in his suit, basically called the sublimator, was operating properly, and that cost the crew time. So downstream here for the remainder of the spacewalk, we are watching consumables, and later we'll determine whether we can complete all of the work associated with the unfolding of the array, which is basically folded up in half. It must unfold the two sections of this boom, and then ultimately, at the end of all of the work, it needs to be deployed to its full length of 60 feet and tensioned properly to provide the proper electrical continuity and output that the array was intended for.
I'm in. Nice. Okay, my two antennas are cleared. Cooling is good for now.
Copy. Ensure your visors and glove heaters are set.
Heaters are off and visors down.
Copy. I understand your heels are secure in the APFR, and we'll do a gauntlets check.
Copy, and our gauntlets are down.
Okay, copy. I'll let you work with Shane to take control of IROSA. You will be performing a RET swap, and it's important, Tomas, that you attach your mini workstation RET to the scoop, which will be in your left hand.
Copy. Shane, can you yaw the IROSA to your left a little bit? That looks good. Bring it back to your left a little bit and up. Bye. Okay, I have a red on it. Nice work. I have my hand on it. Come back to the right? Yeah. What do you need? Wait. Just put my hand differently. There you go, now I have a solid hand on it. If you can rotate to your right a bit more. Yeah. Oh. Wait. Okay, I have two hands on it. I think I have control.
Okay, you have control. I'll take my red off.
I have control.
All right, Tomas, the red is gone. You have control.
I have control.
Ground copies, RET swap complete.
Got to stabilize.
Tomas has control. Shane, you can egress the APFR and release your fare lead.
Copy. Right click, if not, let me come up. I'm up.
Copy, Shane. Shane, after your tether is cleared, you will be translating to the left side of the mounting bracket. I have a warning and some cautions for you both.
Okay. Work on this tether first.
I think we're ready to copy the warning and cautions, Jenny.
Copy. Warning, when you're on the aft side of the mod kit or outboard, avoid contacting the legacy blanket boxes and protruding trunnions.
Copy.
And cautions, while you're both working on the mod kit, you must not simultaneously impart loads. Sudden stops and quick grabs are not allowed, and there is a 30-pound maximum lateral load on the mod kit during and after IROSA soft capture.
Copy.
Copy. I'm getting my tether back up fairly. Tomas, I'll be right there.
Okay, sounds good, Shane.
Ground copies.
At the 5-hour, 17-minute mark in the spacewalk, a good look at the first IROSA ISS rollout solar array that is being mounted to a mod kit, as it's called, basically a mounting bracket at the base of the P6 solar array truss structure. These so-called legacy arrays, the original arrays for the P6 truss,
If you're translating outboard, you'll be looking
are part of the largest arrays ever built to convert solar energy into electrical power.
Previously are still armed.
27,000 square feet in total for the old arrays, more than half of the area of a football field, 112 feet long, 39 feet wide. Once they unfurl, the IROSA arrays will be about 60 feet long, each to provide 20 additional kilowatts of power for station operations.
Shane did not stow his PGT on the crew lock bag handrail, and he did not retrieve a long-duration tie-down tether, which is a contingency item.
It's something we do now or we do after?
And we're not concerned about that at this time. We're just going to go for install on the mounting bracket.
Yep.
All right, so let me check the mounting brackets.
So the IROSA is right next.
Okay, everything looks good there.
Okay, copy. And Shane, you want to position yourself on the outboard side of the mounting bracket. Copy your good checks.
I'll bring it really slowly.
Okay.
I have a note and a caution for you. We're pressing to install. Tomas, you can use the adjustable equipment tether hook, the long side, which is stowed on the mounting bracket scoop, to remove the tether on the root beam, which is closest to the mounting bracket.
Copy.
And Shane, you can help stabilize.
Shane, can you check my yaw? A yaw pedal that it's locked?
I have a hand on it.
What?
I have a hand on a IROSA.
Okay, I was talking about the yaw VHA outputs. Okay.
Oh, I'm sorry. What about it?
Oh, it feels like, no, it's not moving.
You good?
Yeah, it's working.
We need to come up a little bit.
Yeah, we need to remove the scoop.
Okay, I'll hold right here.
Okay, you're holding it?
I have it.
I'm letting go completely.
Okay, I have it. You have a red on it, right?
Yes, I do. Okay, now there's the AET that goes to the other scoop, goes to the scoop from the mounting bracket, goes to the IROSA scoop, and the red goes to the gearing up defaging and goes to the bag.
Hey, firm, that's a good config. You'll be removing the scoops that you just redded to. You can tend it back to the scoop on the mounting bracket.
You remove the scoop.
Nice.
Back. Okay. Now, I can't really gauge the alignment, Shane.
Towards you, just about 10 centimeters.
Okay. Like that.
Make sure that when you're doing this, the bottom of the root beam has to be aligned with the mounting bracket alignment features prior to install to avoid prematurely capturing those soft capture features.
Okay.
Towards you some more.
Towards me some more.
That should be good right there.
Okay.
I have it kind of holding it down on the platform, the mounting bracket platform. Now it's roll it to your right.
Roll it to my right now. It's too low. Mine is not on the mounting. Something is contacting.
You taking it off?
Okay.
Low there.
It's a bit low on your side, I see.
Yep, now I'm good.
Okay, now I'm on the ledge. Wait.
Towards you just a little.
Okay.
I think we're good whenever you want to press it.
You ready to slide it?
Yep.
Okay, 3, 2, 1. Right. Now it's going up.
Too high.
Too high.
Yep. Can we roll it to your right at all or not?
Yeah.
Keep it down.
I can put one finger on it.
And towards you. Towards you. Towards you more. Okay, that should be good. Ready? Yeah, I'm in on my side.
I don't know.
It came out of the slot.
Now.
Yep.
Have to re-engage the bolts.
You have the IROSA?
Yeah, I have the IROSA.
I'll check.
The helmet is closed.
Oh, that's still good.
All good?
Still good. Yep. I have a hand back on it now. We're lined up nicely.
Okay.
Gotta keep contact on it. Ready?
Yeah, slowly.
Well,
I'm blocked by something. Got some contact. Nothing will line up.
Yeah, we're right in the hole on my side.
I'm hitting something on my side.
Huh. Let's see. Now you're in. Your side's in.
I'm in?
Yep. Keep coming.
Can't.
Yeah, huh?
I have solid contact.
Oh. There you go.
Now I'm in.
Now you're in. And you need to get, when you get my side in, all the way.
But I don't think the T-Tech is in, Shane. It's still moving.
No. Your side got to the end, and then mine's still out.
Is the ball depend still out? Maybe we triggered it the first time.
Check. Yeah, the IROSA. Okay, this one is out. Okay, they're both ready now.
Okay.
Copy. We're following along with you guys.
Yeah, the hand back on it. We're both in the slots right now.
Okay, so we just slide it outboard, right?
Yep.
Slowly.
Ready?
Go.
Right.
No, mine is. I'll let it going anywhere.
Huh.
And now it's getting. And now I'm in, I think. In?
You're almost in, and I'm not there yet. I'm a little further off than you. I'm an hour, I think. Keep it off. I can't put much more force on it, so I don't know.
Maybe we triggered those because.
Can you yaw to your right?
Yaw to my right? Yeah, but that gets me out. Now I'm completely out.
Oh, you're out. Okay.
Yeah.
We need to have mine in first, maybe. Because you're right there. You can put more force on it. You're close.
Yeah, but I would have to yaw the APFR, which I can do, but I have to IROSA for a moment.
Okay. Yeah, I can hold it.
Hold it. I'll try to.
Got it.
Got it. The top 1 foot.
Okay. Let me know when you have it again, and then I'll go check to make sure we're in the arm position.
Okay. Okay, my heel's back in. Via Rosa again.
Yeah, via Rosa. Yeah, I triggered.
And I see nothing from where I am, Shane. Let me back it out so that we don't trigger it just.
Yeah, they both got triggered on that last one. Okay, they're in a good position now.
Okay. You know, when you have control, I might yaw back. It's actually not making it better.
I have control.
I have control. Okay. Okay, it's yawed back. Position, I'll put my foot back in. You want to stay in?
There you go.
Okay.
Are you ready?
Ready. The alignment in station forward aft.
Alignment looks great.
Good.
Keep it down. Are you ready?
Yeah, well, slowly.
Okay, we're both in. Coming. We're 4 or 5 centimeters.
Now that's when I hate to stop right here. I think we're in, but I'm too much either forward or aft. Yeah. I can't go anywhere from here. So, we have some margin forward or aft.
Yeah, we have margin my way.
Go away?
Yep. And which means you probably do on your side too.
I don't see, but okay. Let me push it towards you.
No, it's going to go towards you.
Oh, okay, my way, so towards me. Okay, that's what it seems. And then,
there we go.
And then outboard, but I think we've triggered it again.
You have the IROSA?
I have IROSA. I think I might be in. You see on my side what's going on? Because I have zero views thing, I'm sorry.
No, I'm not either, that's the problem. But
hold your head on the other side.
Okay. Well, mine is not triggered, yours is not triggered.
Okay. How about the lateral alignment? Is it good?
Yeah, I mean, we're going right in the hole.
Every time it just stops for me.
And we copy you too that the alignment features are aligned, but the soft capture features are not triggering to secure IROSA. We are talking that down here.
Okay. You want to go your side first, Jim, maybe?
Yeah. They triggered a couple times, Jenny, but didn't capture it.
Yeah, we did see them trigger a couple of times, once on the first try and then prematurely trigger in later on. But we agree with you guys what you guys are doing, and we're talking other options.
Go for it, Shane.
Yeah. So we're lined up really well right there, Tomas.
Yeah. I go.
Ready?
5, 3, 2, 1.
not moving it. There we go.
I'm in, I think.
I think I'm in too. Have the IROSA?
Have the IROSA.
I'm going to check, see if the pins. Pull it.
And Shane, if you get one of the soft capture features deployed properly, you can try and push the other one in, so manually trigger it.
Okay, they're both in right now, Jenny, so I think we got it on that last try.
Nice.
Okay, copy. Great job. Great job, you two. I understand that we are installed with the soft captures triggered. So with that, Shane, I'm going to have you finger start M31 through 34, which are the M bolts on the bottom side of the mounting bracket.
Got it.
And so we are all on the same page. We are working toward getting IROSA in a structurally sound config, and we will not be doing electrical connectors during this EVA.
Okay. And what's my next step, Jenny?
EVA.
Retrieve the scoop.
Tomas, you are going to be releasing your RET and removing the scoop, which is in your left hand. To do that, you're going to be using the other side of the adjustable equipment tether on the root beam scoop.
Copy.
This is Mission Control Houston, 5 hours, 33 minutes into today's spacewalk. Those words from spacewalk communicator Jenny Seide to the two spacewalkers, Tomas Pesquet and Shane Kimbrough, indicating that we will not be able to have enough time today to finish up all of the work associated with the installation and deployment of this first ISS rollout solar array. Now, where we wind up is yet to be determined, and how much work is left to be conducted on the next spacewalk is TBD at this point, but we will not be finishing up all of the work associated with this first array during this initial spacewalk. The next spacewalk is scheduled for Sunday by Pesquet and Kimbrough, but what that will consist of, whether we will press ahead to complete this power channels work with this particular array or leave it in a tied down configuration and move ahead from scratch with the next solar array for the 4B power channel is a subject for future discussion.
Is release. Back to the crew load bag, Shane.
Copy, Tomas.
Jenny, I might go to egress my APFR.
Affirm, egress your APFR, Tomas. We're talking next steps here.
Okay.
Okay, Jenny, I got 31, 33, and 34. Work on 32.
Copy, Shane. The reason why we're pausing here is we're trying to determine whether we're going to unfold IROSA or not. So I will have next steps for you both soon, but it is the correct direction that we've gotten those M bolts. Thank you, Shane.
Okay, all four of those bolts are in. 3 times. Sorry, put stuff in the crew load bag, Tomas.
And Tomas, could you repeat your last? We want to make sure that you're in the right position to do this. We need you to release the final hinge restraint bolt, which is R6.
My last was just addressing the APFR, Jenny.
Okay, Tomas, that was a go back. We're going to have you get back into the APFR to release that bolt. And Tomas, that was a quick handover, guys. I'm back with you. Tomas, we were last talking about releasing that R6 bolt. Correction, you can be in the APFR to do that. You can also be free float to do that as long as you can actually release the bolt.
I think it's better in the APFR, Johnny. I'll set back up.
And Tomas, if you can reach the bolt otherwise and successfully release it without being in the APFR, that is also fine. We're just looking at your reach to R6.
Yeah, I copy Jenny, and I think it's better in the APFR.
Copy. Let me know when you're ready for settings.
Hey, Jenny, I'm one foot in the APFR. It's going to be okay. I'm ready for setting.
Bravo 2, counter 2.
Bravo 2, counter 2.
Good readback. You'll be releasing R6, 18 to 20 turns, and the bolt will spring out when fully released.
One. No. Pass, Bravo 2, counter 2.
5 hours, 40 minutes into the spacewalk, Tomas Pesquet using a pistol grip tool to release a final hinge restraint bolt. One of the final steps before the IROSA solar array can unfold. It's basically folded in half. Needs to unfold first as they continue work to mount it to a modification kit mounting bracket at the base of the P6 solar array truss structure.
18 to 20, copy, thank you.
Shane, I'll take a glove inspection hap check from you when you have the time.
Okay, gloves look good, no change, and dry hap.
Copy, good checks. Thanks, Shane.
I just kind of packed up the crew like bag there, struggled with that for a bit, as you probably saw, but we're in there now.
No problem.
Turns on R6. Popped out.
Copy. R6 is released. You can stow your PGT, Tomas. At this point, we are going to push to unfold IROSA.
I go to egress the APSR this time, Jenny.
Yes, Tomas. Now you egress the APFR, retract and stow the ingress aid to the boot plate.
Cool. All right.
Nice work, Tomas.
On. Ingress aid is retracted.
Copy, Tomas. You can release your fair lead, and you'll be repositioning to the outboard side of the mounting bracket. While you're there, check that the soft capture feature on your side is down or armed.
Okay. Lead is released, and I'm translating to the outboard side of the mounting bracket. I'll take your next words, Jenny, once I'm there.
You want more level saw to get it through, Tomas?
Yep.
Copy. A warning for you both when you're ready.
Down local. Ready? Ready?
Keep clear of rotating IROSA. It's a potential pinch point. It looks like you are both in a good config, as long as you're mindful of unfolding it. Shane, you can initiate and pivot IROSA to the unfolded position. We're looking to engage the right alignment tab and right side soft capture closest to Tomas.
Okay, and I'm just supposed to push it, or do I kind of ride it a little bit, or what's the technique?
Thank you. Manage it as much as possible.
You can push it and get it going, Shane.
At least until I get some good hand on it.
Okay, you ready for that?
Yeah. Actually, I can rotate it myself, Shane. I got it.
Do you?
Yeah.
Okay, it's already going. I can't reach it now.
No, it's okay. I got it.
Nice.
So you come here, maybe assist for the end.
Oh yeah.
No, just for safety.
If I can.
Very nicely for now.
Looking good, Tomas.
Seeing something.
Yeah, I think you just got to keep going. I think it's just hitting that the 10. There we go.
Yeah.
No, it's push that handle up, Tomas. It's right here behind the strut.
Is it in?
No, it's not completely in yet. No.
Is the handle out? I don't see it.
No, handle, it's in arm position. Slightly misaligned maybe there. Yeah, we're just not flush. Close.
Oh.
You push it this way at all towards me?
I think it's hitting something in the back.
Oh, there's nothing back there, but...
Yeah, but I don't have a stable position. Let me rotate. Move towards me.
I'll move out of the way. You going that way?
Yeah, sorry. Okay. towards you or your previous position.
Yep.
And towards the...
Yep. Going towards me.
Yeah, I know, it's not really a line. It hits the wall.
Yeah, wow.
There's a half an inch missing.
So it needs to come my way?
Yeah. Your way, this way.
Maybe we can take it out a little bit more and then try to do it that way. Come back in. Okay. Swing it back out and then
No, it's not gonna change much. We need to, as we swing it open, we need to push it towards you.
Okay.
Pull towards you.
Okay, I can pull it. I got a pretty good position to pull towards me here.
Okay. So if you're ready on the count of 3, let's try. Okay. 1, 2, 3.
Just like 1/8 of an inch.
Almost. No, it's not. Still, there's quite a bit missing. Do we have some play on the other side?
I have about 1.5 inch gap before the other one, if that's what you're asking.
Yeah, but can we compress that gap, or is it solid?
That I don't know. Yeah.
Yeah, no, I don't think we can do anything about it.
I think that one's solid.
Yeah, because we're missing like 1/8 of an inch. Come look, I'll show you.
I understand. I totally understand. We just got to come my way to get it in the hole.
And the other half of the IROSA, we move it by any means, or is it?
No, it doesn't matter. There's R8 up there. Solid up top. It's a solid connection where the IROSAs are already.
Yeah.
But down here, there's about 1 inch to 1.5 inch gap at the bottom. I thought we could play with, but it looks like no gap up top. Well, that's just the rotating mechanism up there. Yeah, it looks like it should fit right in there, slide right in.
Oh, it hits every time.
I think it's hitting on something up here.
No, I know exactly where it's sitting. It's right in front of me.
Okay.
So that's a guide pin or whatever it's called that we were trying to slide into that slot.
Yep.
It's too much to the right, and it's hitting on the wall of the slot. So there's at least 1/8 of an inch missing. Probably the ground is a good view with my headcat. Jenny, did you confirm that?
We copy all.
Keep tracking this, Jenny?
Yeah, we're seeing what you're seeing, Shane, and we're talking it. We're following along.
Jenny, if I feel on my headcat, that should be seeing something.
Shane, we can't see from your helmet cam in your current position. Sorry.
Jenny, this is Tomas. This is actually from my headcat.
Tomas, we can't see from your current position. We have a good view from Shane's helmet cam.
So what you need to see is on my side. What can I do to give you a good view?
You need to tilt your head down, so pitch forward a little bit if you can.
Okay, do you see now? Slot?
All right, that's better. We're looking.
You see the slot, Jenny?
Yeah, they're checking it.
Yeah.
We can see the alignment feature on the mod kit, the mounting bracket, but we can't see the slot on the IROSA root beam.
Okay, so what do I need to do to give you a view of this? No?
Actually, that's good. That's helping. Whatever you're doing now, we can now see it. Yeah. Thanks, Tomas.
Okay, so you see what's happening? The bracket alignment feature is hitting the wall, that slot, and by quite some margin.
We see that. Thanks, Tomas.
We've tried try to slide it as much as we can to the right on your view. But see, there's a lot missing.
Copy. Guys, we're talking about a plan down here.
Can you see my safety tether? You got right behind me when I after that handoff.
No, I don't see it, Shane. I think it's behind you.
All right. Check it out when the sun comes up.
When it's day, maybe. Right now, I cannot really move because I have my hand on the IROSA.
Yeah, no worries. Just don't know if you can see it.
Tomas, that's a great view that you're giving us right now. We're still talking down here.
Where maybe?
All right, guys, we have a forward plan. We're going to ask you to take pictures of the misalignment at a bunch of different angles. We really like the angle you're giving us now, Tomas, but as many as you can manage, we would really appreciate. And then at this point, we are going to refold IROSA and redrive R6 and leave it in a folded position.
But Jenny, copy the plan. It's going to be difficult for me to take pictures. Let go of one hand, and it IROSA kind of opens up again. Folds back again.
See if I can hold it.
So it's staying here because I'm maintaining it with my two hands, like one on the mounting bracket and one on IROSA.
I can push it towards the mounting brackets now.
Got it? Oh,
Okay.
nice.
Got it.
We copy, Tomas.
Let's try pictures.
This is Mission Control Houston, approaching the 6-hour mark into today's spacewalk. Tomas Pesquet and Shane Kimbrough have begun work to attempt to unfold the two halves of the folded IROSA roll-up solar array that has been mounted on a mounting bracket on the base of the P6 truss structure. However, they have encountered some interference with a piece of equipment on that mounting bracket, and so the recommendation is to refold the array back into its folded position and then bolted in place to leave it for further analysis on a subsequent spacewalk. So we will not be completing all of the work associated with the deployment of this array today. That was determined after spending almost an hour troubleshooting a couple of issues with Shane Kimbrough's suit, one with a display control module, basically a data box on his extravehicular mobility unit suit, and a momentary spike in pressure in his cooling mechanism called a sublimator in his suit. His suit has been functioning perfectly since that troubleshooting occurred, but we lost time in the process of doing that troubleshooting, and that cost the two spacewalkers valuable time in being able to complete all of the work for today. When that work will be picked up will be the subject of further discussions in the next day or so.
Oh, it's pretty nice. My helmet light. Yeah, and as I'm taking pictures, I'm blocking it. I think there's a single good one.
I got good video, though. They can definitely use that.
Yeah.
Hey, firm, I'll mention again, we had a really good view from your helmet cam, Tomas. Best effort here.
Okay, so pictures. Yeah, pictures, Jenny. Not easy. By night with helmet light, that's not working.
Copy. Shane will also get you to look up, if you can. Understand you're maintaining control right now. If you can look up so we get a better view of the hinge, that would also be helpful for us.
I can put a hand on it, Shane. Okay, I got IROSA. Got it? Okay.
Thank you, Shane. And Shane, we'll have you pitch back again, looking back at the hinge. Just pitch up a little bit, and then I think we'll have what we need.
Once again, we've just crossed the 6-hour mark into today's spacewalk. Pesquet and Kimbrough attempted to unfold the IROSA solar array at the mounting bracket at the base of the P6 solar array truss structure to its fully unfolded configuration, but they have run into a bit of interference with a mechanism on that mounting bracket, and as a result, the recommendation to the crew is to refold the solar array and to bolt it in place to leave it for another day when we can evaluate not only the timing of the next spacewalk, but exactly what we will expect to accomplish.
It's not unfolding. Oh, yes.
There we go.
Towards you.
I'm not too bad about out here.
You have a hand on it?
No, I don't have anything to grab. A little closer I can.
Underneath.
Okay. we're lined up.
Okay. And now we're going to go drive R6.
Affirm, Tomas. You can use your APFR if you need to. Let me know when you're ready for settings.
Yeah, we'll meet you, Jenny.
All right, big picture next steps.
You're out there, Tomas.
Big picture next steps for you guys. I see Tomas getting in the APFR. Shane, we're going to have you hold that position to help Tomas until he can drive R6, and then we're probably going to have you torque down the M bolts that you finger started previously. You'll use your PGT for that, Shane.
Copy. Thanks, Tomas. Don't go back anymore. Bend your knees and go to your left.
See my safety data pulling on me.
Well,
It's real. Do it again.
you want to to your right. You kind of you're hitting it when you come up.
I know if I should have come up, my safety data is pulling me. That twists me.
Oh, gotcha. Okay.
It's pulling me. Yeah.
Wow.
It's happening before. No, it's still pulling me. I say,
No worries. All right.
Charlie.
Find him, Tom.
I can try without being in an SR maybe.
And put a waist tether on that scoop there, maybe. Yeah.
6 hours and 8 minutes into today's spacewalk, a view of NASA astronaut Shane Kimbrough from an HD helmet camera worn by European Space Agency astronaut Tomas Pesquet, with the challenges of today's spacewalk. The crew is in the process of folding up and bolting into place the first IROSA ISS rollout solar array that was removed from a flight support structure on the truss of the International Space Station, having been delivered with one of two such arrays on the SpaceX Cargo Dragon vehicle 2 weeks ago, that was launched from the Kennedy Space Center in Florida on the latest SpaceX resupply mission to the station. This IROSA array, as it is called, was removed from the flight support structure on the truss of the station, brought over to the base of the P6 solar array mast, and work began to unfold the array. However, a small interference has prevented a complete unfolding of the array. That's as far as we would have gotten anyway with today's spacewalk, having lost time to troubleshoot some minor issues with Shane Kimbrough's spacesuit earlier in the day. So the two crew members have folded up the array and are bolting it in place in a safe configuration. And where we go from here with the next spacewalk in this series to get these solar arrays installed and unfurled to begin the augmentation of power to the International Space Station will be a subject of further discussion by mission managers. There is no urgency to get these arrays mounted and unfolded and activated. These arrays are designed to augment the current power supply of the existing legacy solar arrays, not to replace them. The station is operating in perfect fashion with the electrical output currently being generated by the station. The augmentation is required to handle the future loads for both science utilization and additional modules to be launched to the International Space Station in the months and years to come.
Okay. It's above my head.
Still. Excellent. Deeper.
Deeper?
Yeah, there you go.
Okay. Got 1 foot, that'll be enough.
Yep.
Once again, the two spacewalkers were able to soft dock the IROSA rollout solar array to the mounting bracket at the base of the P6 solar array truss structure. And then they made an attempt to unfold the two halves of the boom, if you will, for the solar array. They were unable to completely unfold and line up the bolts. So after using some time to troubleshoot that issue, they folded the array back, and you can see that in the view from a truss camera on the International Space Station. Shane Kimbrough on the left, Tomas Pesquet on the right, and they're bolting the array in place to put it in a safe configuration so that they can attend to it on a subsequent spacewalk.
I am ready for settings, Jenny.
Alpha 3, clockwise 2, 18 to 20 turns.
Alpha 3, clockwise 2.
Affirm.
Good turn on number 6. In work. Alright, change it nicely aligned.
This is aligned, yep.
Three, 4, 5. Get the green light, 4.8 for the torque, and 19.88 turn, Jenny.
Copy. Green light, good torque, and 19.8 on the turns, Tomas. You can stow your PGT. Tomas, I'm going to get a glove inspection, hap check, and gauntlet check from you. And Shane, now that IROSA, that hinge bolt is secure, you can ready your PGT and we'll drive the M bolts to torque, which you finger started previously.
Those are good, hap is dry, and gauntlets are covering the wrist.
Copy, Tomas.
All right, just give me a second on the EDT, Jenny.
Copy, Shane, no problem. Tomas, for you, now that we've gotten those good checks, we are going to send you to the Y cable connector ends, and to get ourselves in a good config to leave these cables out here, we need you to mate the Y cable ends together.
Copy. In work.
This is Mission Control Houston, 6 hours, 16 minutes into the spacewalk today by Pesquet and Kimbrough. They're in the process of driving the final bolts to structurally secure the IROSA rollout solar array to the mounting bracket at the base of the P6 solar array truss structure. You see those huge solar arrays that are deployed out of the top of your screen on this view from an external truss camera on the station. The actual unfolding of the two halves of the solar array boom and its ultimate unfurling of the array after it's electrically mated to the integrated electronics assembly on the International Space Station is forward work that will be left to a future spacewalk.
Number 5, clockwise 2.
Correction, Shane, we're changing the settings. Alpha 6, clockwise 2.
Copy, Alpha 6, clockwise 2.
Affirm.
Okay, that's set.
Copy. We understand these bolts have been finger started, but nominally we would expect 11 to 13 turns. We're driving them all to hard stop with the black line flush.
Copy.
And Jenny, I'm at the Y cables.
Copy, Tomas.
clockwise 2. Set.
Affirm.
Okay. A low torque message on the PGT there. That was at for 11.96 turns.
Copy, Shane. And which bolt was that?
Did I get a green light there or not? 34.
That was M34. And that was a low torque?
Yes.
Copy. I'm checking for you. And Tomas, I can give you your cable connections. You can start when you're ready. You'll be mating P9 alpha to J9 alpha. And likewise, P23 alpha is going to go to J23 alpha.
Copy. P9 alpha to J9 alpha, P23 alpha to J alpha.
That's a good read back, Tomas.
P9 alpha to J9 alpha connected.
Copy.
Did you get the same message on M33? 12.08 turns.
Copy. Same message on M33.
P23 alpha, A23 alpha is mated, Jenny.
Copy. Good work, Tomas.
You got a green light on M32 with 11.5 turns.
Copy. Green light on M30.
24 on the torque.
M32. That's good torque and a green light. And Shane, I can confirm now we're going to need a green light on all of those bolts. So we might have to go back to 33, 34.
Okay, I'll do that now. Okay, you got a torque 1.6 turns on M33 with the green lights, 24 torque. Nicely done.
Copy. Good torque, green light on M33, an additional 1.6 turns. Tomas, next steps for you coming shortly.
Green light and about half a turn on M34.
Nice.
Copy. Green light, half a turn, M34. Just looking for M31 now.
Okay. All right, low torque on that one. Let me try it again.
Copy, Shane. Low torque, trying M31.
That was 11 and a half turns.
Copy, 11 and a half.
Torque train.
tough angle on this one. Let's see if we can come the other way. I got a green light on M31 with about another quarter turn there.
Copy, Shane.
Hold on.
This is another point for you, Tomas and Shane. We're just syncing up, making sure I have your next steps. Understand you're standing by for me to tell you what to do, but I'll have words shortly.
Okay, so the cables, and you're right on the other side. We could do that.
Yeah, we have to do this. The RTO.
Checking.
Safety tether behind me?
Yeah, it's actually to your left, along your left leg. It's nice.
Okay, good. Couldn't see it, or I think it's just right down the leg.
It goes to the corner where your fair ladies, I think, maybe?
I didn't, but it must have just caught on something. That's good.
Yeah. It's good.
Thank you.
Yeah, I didn't remember before.
Shane, I can confirm that you'll be headed outboard to connect your Y cables to one another to leave us in a good config.
Anything you want me to do, Jenny? Just the time.
Tomas, I need 1 more minute to confirm.
Okay, no problem. Full DXFI ingress aid.
I'm ready for connectors when you are.
Tomas, I have next steps for you. You can head to the cable bag. You'll be retrieving the NZGL caps, and we'll cap the NZGL side of the connectors.
Okay. Any standing by for your connections, Danny?
Copy, Shane. You'll be mating P7 alpha to J7 alpha and P21 alpha to J21 alpha.
Okay, let me look for those and I'll confirm with you.
Right below your Shane.
Copy. Okay, I have A21 and P21.
Copy.
Both sides look good, no side, no pins, and EMI band looks good.
Copy, Shane.
Any of those caps, they're on the cap keeper, is that correct?
Yeah, there's 2 on each one. Remember that, 2.
Okay.
That's right.
Can I put all of them on the same cap keeper and take the cap keeper with me?
Yep, you can do that, Tomas. We just need all 4 connectors capped.
Okay. 3. How you doing, Shane?
Yeah, just can't get it lined up correctly.
Alright. Now look at the keying inside.
Yeah, that's what I just did. Thanks.
Only.
That'll help. There we go.
Copy, Shane. Around 45 seconds till handover.
Okay, that one's done, Jenny, and the next one is P7 to J7 Alpha.
Hey, firm, we're looking for P7 Alpha to J7 Alpha.
P7 Alpha to J7 Alpha, copy. Everything looks good. No 5, no pin pins. Me and my van.
Copy all. Short handover.
Yeah, full.
Okay.
No, so talking about the one up here? Or the one you brought over?
I can pass it to you right here for information.
Yeah, I got 2 right here at least. Let me get on.
You know what? I'll just take it with me.
Well, better position for you.
Back with you after the handrail.
Okay, I have my red. I have my red on the cap keeper. I release the AT from the bag and go back up with the cap keeper with those 4 and the GL caps. Manager.
And break.
Well, actually,
we're going to stop your capping ops now. We are going to pick up the crew lock bags and the PGTs and head inboard. We are creeping towards our MEDOX limit.
Okay.
All right, so AT still on the cap keeper. And I'm going to release that. Maybe it's your foot.
Yep, I see you down there.
Send it back inside of the bag. Okay. Back inside the bag.
Okay.
That's ready to go inboard.
Copy, Tomas. We'll have you stop at the FSE to pick up the crew lock bag and the spare PGT, and then continue inboard. And Shane, understand you're currently getting the crew lock bag at the mod kit on your BRT.
Correct.
Okay, all right, you're good to go, Shane. I'm going to go ahead and
Yep.
you'll be right behind.
Yep. Well.
All right, Shane, I see you have the crew lock bag.
Yep.
Copy, Shane. Shane, you'll be headed straight back to the airlock. Again, Tomas, you will be stopping at the FSE.
Copy.
And reminder, you'll be picking up your green hooks on the way inboard.
Okay, I see your green wheel, your green wheel, the green hook, Shane. Okay. My 5309, Jenny, I'm going to pick up my green hook and then attach it to my head wheel.
Good words, Tomas.
This is Mission Control Houston, 6 hours, 35 minutes and counting in today's spacewalk by Pesquet and Kimbrough. They now have left the IROSA rollout solar array in a safe configuration on the mounting bracket at the base of the P6 solar array truss structure, and will now begin to make their way back to the Quest airlock, collecting tools and tethers and making inventory of all of the items they took outside with them for this first spacewalk in support of the augmentation of the power system on the International Space Station.
Your tethers are a little bit one above the other, Shane.
Okay, I'll keep an eye on it.
Yeah.
And my green hook is on my red wheel, and both are unlocked.
Copy. That is a good config, Shane. You can continue your translation inboard. You will be headed direct to the airlock.
Copy.
I'm crossing over to the FSC, Jenny.
Copy, Tomas. You'll be picking up the crew lock bag and spare PGT and stowing them on your BRT.
There's a red on that handrail too. I think it goes to the crew lock bag. See it? Copy.
And I think I have your together up around something, so I'll come back down.
Okay. Let's see. I'm right.
To the left.
Oh yeah. It's your camera, I think. Reach it. There's a couple twists in there.
This is Mission Control Houston, approaching the 6-hour, 40-minute mark in the spacewalk. Just to recap, Shane Kimbrough and Tomas Pesquet placed their spacesuits on internal battery power at 7:11 a.m. Central Time, 8:11 a.m. Eastern Time today to begin the 239th spacewalk in support of space station assembly, maintenance, and upgrades. The focus for today was the first in an ongoing series of spacewalks to install and deploy and activate new solar arrays called IROSAs, ISS Rollout Solar Arrays, to augment 6 of the 8 power channels on the International Outpost. The 2 crew members worked to prepare the first of the IROSA arrays and to get it out of a flight support structure on the truss of the International Space Station, where it was delivered after its launch 2 weeks ago on a SpaceX cargo vehicle from the Kennedy Space Center. About 3 hours into the spacewalk, a couple of minor problems were detected with Shane Kimbrough's spacesuit. One was the loss of data on a display control unit that provides spacewalking astronauts insight into the health of their suit's systems. He was directed to go back into the airlock, put himself on an umbilical, and restart the display unit, and it has been operating just fine ever since. The other issue that was addressed but cost the crew members time outside was a momentary spike in pressure readings in Kimbrough's suit sublimator, a cooling unit for his spacesuit, but it also has stabilized and caused no further problems during the course of today's excursion. But all the time that was lost dealing with Kimbrough's suit resulted in the first of these 2 IROSA solar array units being removed from the flight support system and moved over to the base of the P6 truss to a mounting bracket. It was installed on the mounting bracket. The 2 crew members tried to unfold the boom, basically the array itself, which is folded in half, but they couldn't unfold it to its full extension because of an interference problem with a mechanism on that mounting bracket, and so they were directed to refold it and bolt it in place in a safe configuration, which is where they're going to leave it for today. There will be discussions over the next day or so by mission managers and spacewalking engineers as to what the next course of action will be. Whether we press ahead with the completion of this particular IROSA array's installation and activation, maybe move on perhaps to the next array that goes on the opposite side of the P6 truss for the 4B power channel, or whether we defer this work to a future spacewalk altogether. It is not an urgent concern for NASA at this point in time. These IROSA arrays are designed to augment, not replace, any of the existing arrays, which are functioning just fine, providing all of the power required for station systems. The IROSA arrays are designed to add, each of the new 6 IROSA arrays are designed to add about 20 kilowatts of power to the existing power output for station systems, thus putting the station in a better posture electrically to support new science payloads and new modules that will be launched to the International Space Station.
Okay, crew back on the BRT. Find me.
Copy, Tomas.
Now I'm gonna retrieve the PG.
Copy.
Have a right on the feet.
Copy, Tomas.
This done. And it's gonna go to my swing arm, and then I'm gonna go back. EV2's on the seat of spur.
Copy. Shane, when you are back at the airlock, a reminder that adjustable on the thermal cover is still there, and we will have you put your waist tether on the airlock D-ring extender waist tether.
Okay, copy. We take the adjustable off.
We're checking for you, Shane.
Okay.
Yeah, Shane, you'll be bringing that inside with you, that adjustable.
Okay, copy that. Okay, I have the adjustable thermal cover coming open.
Copy,
Then,
Shane.
okay, I have the spare PGT and the cooler bag. I'm making my way to the airlock. Okay, Tomas, good deal.
We copy, Tomas. That sounds good.
I have a waist. Go ahead. The waist tether is to the airlock waist tether, which is to the D-ring. All three hooks are locked.
Copy, Shane. Tomas, make sure on your way inboard, you press the inboard port and starboard seat of brake handle releases twice.
Okay. Inboard seat cart. Get it correct?
Both seat carts, but looking for the inboardmost brake release paddle twice.
So the pedal twice on the outboard or not?
Just the inboard pedals, but on both the port and the starboard seat cart.
Okay. Okay, inboard brake pedals on both the cart.
Affirm.
Tuning for EV2, I'm in the airlock. The crew lock bag is on a brett attached to the airlock.
Copy, Shane.
Pedals depressed on the port seat cart. Wing under the MT.
Copy, Tomas.
The starboard sphere card.
And you want me to hang tight till Tomas gets here, right?
Copy, Tomas, and say your last, Shane.
We just hang tight till Tomas gets here, right?
Affirm. So our next steps are for, we see that double brake release. Thank you, Tomas. You can continue inboard to the airlock. Our next steps are to do the tether reconfig once Tomas is back at the airlock.
Copy.
Okay. I see my green hook here. Actually twisted here. I'm at my green hook location, Jenny. Sorry, my anchor hook location, 3562.
Tomas, you are translating all the way back to the airlock, and your anchor hooks will stay at this location. We are reconfiguring back at the airlock on the external airlock D-rings.
Okay, and from what I see here, our safety pedal are wrapped around each other, so I'm going to have to clear that too.
Yeah, I thought they cleared at the very end, but you can't say that.
Then a shoe twist. No, it's still wrapped.
All right?
Yeah.
So we are able to clear that next time we come out.
Okay, all right. Want me to do it now? It's going to take 1 minute. Let me go ahead and do it now, Jenny. That's fine.
Copy, Tomas. If you are going to clear it now, that's fine. You need to put a tether on that hook.
Okay. So I have my waist tether to 3562 box, black on black.
Copy.
I'll put my other waist tether on that hook.
Copy, Tomas. That's a good config.
I'm going to put it on the other hook. Then I'm going to release my anchor hook. Okay, I'm going to attach it to 3562, locked, black on black. I'm going to go ahead and retrieve my waist tether.
Copy, Tomas. Good words.
Hi, how you doing, Shane, at the airlock?
Just right, Tomas.
You're breaking up, sorry. Just to be sure for next time, anchor hook is locked black on 3562. Shane's anchor hook locked black on 3561.
Copy. Good status of both the anchor hooks. You can head back to the airlock, Tomas.
Heading back.
And Shane, since you are back at the airlock and in position, Tomas will meet you there, do the tether reconfig. So at this time, if you'd like to, you can remove the SCU from the stowage pouch and connect it to your GCM.
Okay, I'll put that in order.
And Shane, as I'm coming in, I'll pass you the LPGT.
Okay.
And also maybe my crew like bag.
Yep. All right.
Okay, and I'm at the whisper. Okay.
Copy.
Be mindful of your together.
This is Mission Control Houston. As we approach the 7-hour mark in today's spacewalk, Shane Kimbrough is almost back home, almost back at the Quest airlock, where he and Tomas Pesquet will enter shortly and begin the process of repressurizing the airlock to wrap up today's spacewalk. They were able to remove and mount the first of the ISS rollout solar arrays onto the mounting bracket at the base of the P6 truss, but it has been a deliberate process throughout the day, and the crew members were not able to unfold or unfurl the arrays as had been hoped for. So with the spacewalk winding to a close, we will have to wait and see over the next day or so what the next course of action will be in terms of the timing and the content of the next spacewalk by Kimbrough and Pesquet.
Goes to PGT. Got it? It's connected. I will send meters back. All right, ready. Okay, coming to you.
Our coverage today will continue through the time that the crew begins the repressurization of the Quest airlock. That will mark the official end of today's spacewalk. We'll compile our usual plethora of statistics about where we stand with spacewalking activities at the International Space Station, and then we'll continue our coverage through the time that Kimbrough and Pesquet are back inside the equipment lock and they have doffed their helmets.
You can both turn off your helmet.
The IROSA rollout solar array is in a safe configuration, bolted in place on its mounting bracket at the base of the P6 truss, while engineers evaluate the best course of action and timing to complete its unfolding and unfurling to a full 60-foot length to enable it to begin its power augmentation for the 2B power channel on the P6 or port 6 truss of the station.
And you're on the airlock gearing with your waist tether?
Yep, I am.
Okay, your green hook goes aft, airlock gearing, arc.
Stay firm.
And green hook is on the aft airlock gearing, green hook is locked, and the green reel is unlocked.
Copy. Those are good checks. You can attach Shane's yellow hook to your red reel.
Copy. Right reel. Let's change yellow hook.
Jenny, my SEU is connected. EDT.
Copy, Shane.
Here's yellow hook is locked. Black on black on my red reel, Jenny.
Copy, Shane's yellow hook attached to your red reel, locked. Check reel unlocked.
Which reel? My red reel? Yes, it's unlocked.
Copy. You can attach your green hook to the forward external airlock D-ring.
That's my green hook. Lock forward external D-ring.
Affirm.
My green hook is on the airlock forward external D-ring. My reel is unlocked and the green hook is locked black on black.
Copy. You can release your yellow hook and stow it on your mini workstation.
A yellow hook.
As Tomas Pesquet makes his way inside the Quest airlock, at the other side of the hatch to the crew lock section of Quest in the equipment lock, Megan MacArthur on the left, Aki Hoshide with his back to the camera, and Mark Vandehei on the right are awaiting the crew members and the repressurization of the crew lock section of Quest that will enable them to open up the hatch and bring Shane Kimbrough and Pesquet back inside.
Transferred in. So with that, Tomas, you can ingress the airlock, verify that the forward hatch pit pin is engaged.
Copy. All right. You ready for me?
I am ready.
Okay.
Nice.
I think my first off. No, it's good. Okay,
So done.
airlock forward pit pin is engaged.
Copy, Tomas. Close the hatch thermal cover, attach the hook to the magnetic plate D-ring, and cinch the strap until snug.
Yep. Hey, can you push on my feet, please, if you can?
Push so you go out.
Push down, down, down. Yeah. Yeah. Going and yeah, okay. I don't see where the AT goes. Oh, to the, okay, here's hidden.
Affirm, attach the hook to the magnetic plate
Okay.
D-ring.
Yeah, right. Hiding from me, Jenny.
Sorry, Tomas. We see it.
Not your fault at all. I get it. I'm going to cinch it.
Copy. Cinch till snug and
Line.
report the number of black lines. We're expecting 6.
1, 2, 3, 4. 1, 2, 3. SC7.
Copy, Tomas. You can remove the SCU from the stowage pouch and connect it to your DCM.
You have room, Tomas?
Yeah. You'll make that. Wait. Go from the pouch.
And Tomas, I understand you are connecting to your SCU. We want to check if you can get the magnets to engage on the thermal cover as well.
Yep, so I'm connected to the SCU. What do you want to engage, Jenny?
Copy, you're connected to the SCU. Can you ensure that the thermal cover magnets are engaged? That will be fully closed.
Closed or engaged, Tomas?
Fully closed. So it's not a strong magnet, Jenny. Not strong at all.
Copy, we understand. That looks good to us. So I'll get both of you to check your SCUs are locked.
SCU is locked.
EDT locked.
Note, TCV setting of 8 max cold minimizes time for SCU cooling. You can switch water off, OFF, forward, and expect an H2O is off message.
Water off, EV1.
Water off, EV2.
Copy. Do not close hatch until EMU water off for 2 minutes. We're timing.
Copy.
Recap today, tomorrow, the whole team.
That was a really good job.
A lot of complications.
That was very exciting for it and finding solutions. Yep, proud of everyone.
We completely agree. You guys did a fantastic job today. It's a complicated EVA.
Good job, Jenny.
Yeah, excellent work, Jimmy. The team.
Really good with everyone.
Our 2-minute timer is complete, so Tomas, you can verify the outer hatch is clear of hardware, and the handle is per the hatch decal.
Copy. I think it's the back fully on my SCU, Shane. It's kind of
Crew like that?
yeah.
Okay, I'll hold them. Okay.
All right. So the outer hatch is clear of obstruction. So I'm going to go ahead and push the press button.
Copy that the hatch is clear, and if the handle is per the decal, you can close and lock the hatch, Tomas.
Per the decal. Check me if nothing. Clear. Good. Okay. Flight today. Jenny, did you copy the outer hatch is locked?
That was a
so he's latched?
short handover. We copy now. The hatch is closed and locked. On the UIA, Shane, check oxygen. EMU 1 and 2 valves are both open.
Both are open.
Copy. Switch power, EV1 and 2, both on.
On 1 with the light, on 2 with the light.
Copy, both on, and you see EMU LEDs 2 on. Check power, EV1 and 2 volts, 18 to 19.
18.6 on both.
Copy, good numbers. On your DCMs, switch power to SCU, expect warning tone.
This is Mission Control Houston. The clock continuing to tick on today's spacewalk. Now at the 7-hour, 13-minute mark, but we're in the home stretch. The outer hatch to the Quest airlock's crew lock compartment is closed and locked. The crew now hooking up to umbilicals in the crew lock, and will soon begin the repressurization of that segment of the airlock to mark the official end of today's spacewalk.
Thank you, Jenny. Thanks to all the team. There's a lot of work going into these days and a lot of work real time to react, and it was beautiful. Thank you.
Thank
you. Hey, Jenny, thanks. Fantastic work today, Jenny, and Tomas and Shane. We are looking forward to getting our friends back inside. So here we go. Both of you take your O2 actuators to press.
Copy. One's in press. Still working on it.
Copy.
V2's in press.
Both in press. Tomas, check that the EV hatch MPEV is closed.
The hatch MPEV is closed.
Okay, I'm about to start throttling the IV hatch equalization valve. Let me know if you want me to slow it down.
Okay, copy.
That's about halfway there so far. I'll slowly ramp it up.
Very comfortable so far. Thank you.
This is Mission Control Houston. The repressurization of the Quest airlock has begun at 2:26 p.m. Central Time. marking an end to today's spacewalk by Tomas Pesquet and Shane Kimbrough at 7 hours 15 minutes. Again, 7 hours 15 minutes for today's spacewalk. The EVA, or spacewalk, ending at 2:26 p.m. Central Time with the start of the repressurization of the Quest airlock. And we'll have additional statistics for you shortly.
So both of you, when the crew lock is at 4.0, accept in the low tone.
Copy. Sorry, the 5.2.
We're already at 5, Mark.
Yeah.
Again?
We're already at 5. You need to turn it off.
I barely heard. I think you said throttle it back.
No, we're already past 5.0.
Yeah,
So
we're at 5.7, Mark.
Okay, IV hatch equalization valve to off.
yeah.
And we're going to wait 2 minutes for the crew lock pressure to stabilize. That was a lot faster than I expected.
Copy.
And Shane, Tomas, we are just waiting. We'll finish up our 2 minutes to do a 1 minute leak pressure check.
Copy, Mark.
Copy.
This is Mission Control Houston. The repressurization of the Quest airlock is continuing following the completion of today's spacewalk by Tomas Pesquet and Shane Kimbrough. The spacewalk began at 7:11 a.m. Central Time today when the two spacewalkers placed their suits on battery power, and ended 7 hours 15 minutes later at 2:26 p.m. Central Time with the repressurization of Quest. This was the 239th spacewalk in support of ISS assembly maintenance and upgrades, the 7th spacewalk conducted out of the ISS this calendar year. For Tomas Pesquet, this was the 3rd spacewalk of his career. He now has a total of 19 hours, 47 minutes of spacewalking time. Shane Kimbrough now has completed the 7th spacewalk of his career for a total of 46 hours and 15 minutes of spacewalking time. In all, the 239 spacewalks associated with ISS assembly, maintenance, and upgrades have equaled 1,506 hours and 28 minutes of spacewalking time, which is the equivalent of 62 days, 18 hours and 28 minutes of spacewalking since the first ISS spacewalk back in December of 1998. So far, for Expedition 65, there have been 2 spacewalks. The first conducted by Russian cosmonauts Oleg Novitsky and Pyotr Dubrov 2 weeks ago out of the Poisk module. So with today's spacewalk in the books, the 2 spacewalks so far for this expedition have totaled 14 hours and 34 minutes of spacewalking time. The spacewalk resulted in a mixed bag of results today. The first of the new IROSA ISS rollout solar arrays was removed from its flight support structure on the truss of the station and mounted on a mounting bracket at the base of the P6 solar array truss segment. However, a couple of issues with Shane Kimbrough's suit that resolved themselves cost the spacewalkers some time, about an hour's worth of time, and they were unable to complete all of the work planned for today. They also had an issue with some interference as they tried to unfold the array from its folded configuration once it had been mounted on the mounting bracket at the base of the P6. So the array is back in a folded configuration. It was not unfurled. It was not fully unfolded. It is folded and bolted into place in a safe configuration. Managers now will have discussions regarding the next course of action for this particular solar array and where we go from here with planning for the next spacewalk to deal with the second of these 2 solar arrays. This particular solar array that Pesquet and Kimbrough worked on today was designed to provide augmented power to the 2B power channel on the P6 truss. The next solar array, which remains in its flight support structure on the truss of the station, is currently scheduled to be removed and installed on Sunday by Pesquet and Kimbrough, but whether or not we press ahead with that work or have some modification to the spacewalking plan will be the subject of discussions over the next couple of days. The Quest airlock is almost completely repressurized at this point, at which time Mark Vande Hei, as we see, is rotating the hatch handle and now is opening the hatch between the crew lock section and the equipment lock section so that he and Megan MacArthur can assist Pesquet and Kimbrough in re-entering the equipment lock so that they can have their safer simplified aid for EVA rescue backpacks removed from their spacesuits and then have photos taken, which is a typical course of action. They'll have photos taken of their suits and gloves for analysis by engineers back on the ground before they begin to remove their spacesuits.
Station Houston, space to ground 1, heads up, crew is no longer hot mic.
Shane Kimbrough back inside the equipment lock of the Quest airlock. Tomas Pesquet now being assisted back inside by Van de Heye and MacArthur. This is Mission Control Houston, once again safely back inside the Quest airlock. Astronaut Shane Kimbrough in the field of view on the left side of your screen, partially obscured at the moment by Mark Vande Hei, and looking over the shoulder of Tomas Pesquet. They are being assisted in getting their gloves off. There will be photos taken of those gloves, as is normal standard practice following a spacewalk. Megan MacArthur also assisting in the equipment lock section of Quest. And within the next few minutes, the two crew members will get their helmets off and begin the process of getting out of their suits with their long day's worth of work having come to an end, with the first of the ISS rollout solar arrays having been installed on a mounting bracket at the base of the P6 truss, not deployed, not unfolded. That is forward work yet to be evaluated by mission managers. The next spacewalk by Kimbrough and Pesquet for the next of the first pair of solar arrays, the second of the solar arrays delivered 2 weeks ago on a SpaceX cargo vehicle. That next spacewalk is currently scheduled for Sunday, and we'll be watching very carefully to see what managers and the ISS program management decides the next course of action will be. This is Mission Control Houston. Tomas Pesquet on the right, Shane Kimbrough on the left, their helmets now having been removed, safely back inside the Quest airlock following a 7-hour, 15-minute spacewalk today, the 7th for Kimbrough, the 3rd for Pesquet, in which they removed from a flight support structure the first ISS rollout solar array, the first of 6 such devices designed to augment the power capability of the International Space Station's existing arrays. They were able to install it on a mounting bracket at the base of the P6 truss, but a couple of issues with Shane Kimbrough's suit that turned out to be minor in nature cost the 2 spacewalkers some valuable time outside while flight controllers here in Mission Control conducted troubleshooting on Kimbrough's suit. And so the 2 spacewalkers were not able to unfold or deploy this 60-foot-long array. It remains folded up and bolted in place in a safe configuration at the base of the P6 truss. The next spacewalk is scheduled at the moment for Sunday by Kimbrough and Pesquet to remove and install and activate the second of the 2 IROSA or ISS rollout solar arrays. This one for the 4B channel of the P6 truss. The one mounted on the bracket today is designed to augment power for the 2B power channel. So where we go from here will be the subject of discussion by managers over the next couple of days. At the moment, we are scheduled for coverage of the next spacewalk at 6:30 a.m. Eastern Time on Sunday morning. However, we would urge you to stay in touch with any further advisories on that, and to keep your eye on the space station web at www.nasa.gov/station. For now, that will wrap up our spacewalking coverage for today. 7-hour, 15-minute excursion outside by Shane Kimbrough and Tomas Pesquet. Thanks for joining us throughout the course of the day. This is Mission Control Houston.
Thank you.